Hello everybody, welcome to the Python programming course. So I'll be your instructor for this entire course. My name is Deepali Shinde and let's begin our journey. So we're going to start, understanding what a computer program is. All right. Now, this course is going to be your guidance, your first entry point into the computer programming world. Right now, computer programming, you must have thought with an idea, oh, I want to, do cool some AI ML stuff. I want to do robotics, or, I want to create a game. Yes, you can do all of that. But the building block or the starting point for all these great things is this particular course, where you will understand what basically is computer programming. Okay, why do we need one? And there are different computer programming languages which you can use to do these great things. Now, as far as this course is concerned, we will be learning all the programming concepts using the Python language. Why Python, you would ask? The reason is very simple. Python is very similar to speaking English. Okay, as we go deeper in the course, you would realize this. It's plain English commands, right? And as English is also the easiest language, and most of the people know English, so that's why to enter into the programming world, we're gonna use Python as a backbone. Okay, now let's start. Now, first thing is, what is a computer program? Okay, or simply, what is a program? You must have heard this, right? Nowadays, this word is very buzzing, right? Computer program, programming languages, everybody wants to do coding, right? So what is a computer program? Very simple, nothing difficult about it. A computer program is a way, all right, to tell the computer to do a particular task. What am I saying? Computer program is is basically a script or some lines of some lines written, okay, which basically is a way to communicate with the computer to tell the computer, please do this particular task for me. That is a computer program. For example, okay, let's say your mom or your dad asks you, just get, let's say, bread from the grocery shop. What would you do? What is the first task you're going to do? Your mom or dad is going to ask you to go and get the bread from the grocery store, right? Second, they'll also give you some money. That, okay, this is $30 or $40, and please get bread for me, right? So now what is this? How are they communicating this task? They're speaking normal, a language, right? Whichever your mother tongue would be, they're trying to talk to you, and then you understand what has to be done, and you go and get the work done, right? Similarly, if you have to draw an analogy, let's say, if I have to, tell computer some work to do, right? Now, let's say we have to, add two numbers. Okay. So if you have to add two numbers, what would you do? What was the first thing? Suppose if I tell you, let's say, some name might be, say, Jack. Okay, Jack, I want you to add two numbers. What's the first question Jack would ask me? Jack would ask me, what are the two numbers you want me to add, right? So if I do addition, this is going to ask me, what are the two numbers you want me to, do the addition of, right? Fair enough. So I would say number one would be, say, 2, and number 2 is, let's say, 3, right? The next, what will he do? He'll do the addition, right? He'll do the addition of these two numbers. What is the addition of 2 and 3? Is 5. Very simple. Okay. Now, when I asked Jack, now what is the addition of these two numbers? What Jack is going to give me the answer? Jack is going to give me the answer 5. He's going to tell me the addition of these two numbers is 5. So this is my result, or this is the output. Correct? So what was the task? The task was to do addition of two numbers. Perfect. Now, when this task was given, Jack asked me two things, right? This is nothing but called as input. Input means the additional information which you need to tell the person who's performing a task for you so that he can perform the task, right? If I just tell Jack, please do addition, okay, and do not give any further information, it's not possible because he does not know what numbers I have to add. Okay, so here the input the Jack is asking me, what are the numbers you want me to add? Okay. Then the next task was what? He performed addition, right? So in the world of computers, it's called processing. Processing means now what he's going to do when he takes his 2 and 3 numbers, he's going to what? He's going to do this calculation, do this addition in his mind, or might be use a calculator. Now these numbers are very easy, right? 2 and 3. So he might just do it, in his mind, or might be use a calculator. So basically he's doing some processing on the input. That means he's taking this input, okay, and then he's doing something with it to produce a result, right? So finally we get a result or a output. Okay, output is like the final outcome, right? For example, if we come back to the earlier example of somebody sends you to buy bread from a grocery shop, okay, what is the output? The output would be the bread, the physical bread which you would get. Correct? So that is the output. All right, or might be suppose the bread is not available, then you might come back to your parent and say, mom or dad, the bread was not available. Correct. So you will come back with some either a physical, bread, or you would tell them that the bread was not available, right? So that is basically the outcome of output is nothing but the outcome of the task which was given to you. Understood? Now this similar thing, if I have to, convey this to computer. Computer means what? See, computer is also, why do we need a computer? Computer is basically a human's friend, right? Computer does everything what whatever a human being tells him to do it. Correct? So that means computer performs tasks for us. Okay. So program is nothing but the same thing. Program is our way of telling the computer to do a particular task. All right. So program would also have all these things, because you would need to tell the computer what is the input for doing a particular task. Okay. What is the processing required, right? And what is the output? Now suppose this task was done by a human being, let's say named Zach. Correct? Now this, suppose if I have to tell a computer to do the task. Similarly, I have to tell the computer what my two numbers are. Let's say 2 and 3. Then computer will do the processing of what? Addition. This processing will be based on what? Two things. What the task was and what the input is. Right? The task is what? Addition, or the sum of two numbers. And what is my input? 2 and 3. That means my processing will be what? 2 plus 3. What is the output of this processing? Output of this processing is nothing but 5. Okay, so if you see this, a human being performing addition and a computer performing in addition, it is very, very similar, right? So now if we have to understand program from this example, what we understand is a program is nothing but, okay, it is a way of telling the computer to perform a particular task. Okay, and it is made up of 3 important components. What is it? Input, the processing part, and the output. All right, so you need to tell what your input is, what the processing has to be done. What processing has to be done would be depend on 2 things. What is it? What was your task you asked the computer to do? And second is what the input was. All right, and the third would be the output or the consequence. All right, understood? This is what a computer program or a program is. All right, it is nothing but a task, okay, that you ask the computer to perform for you is a program, a computer program. Okay, fair enough. Now, if we have understood computer program, let's move on to computer languages or computer programming languages, more specific. All right. See, let's come back to the example of Zach. Okay, where we had asked a human, Zach, to perform the addition for us, right? Addition of 2 numbers. All right. Now, let's say even if it's Zach, or even if it is, if I have to tell you to buy bread from the grocery, right? There must be some language in which I'll be telling you this task, right? Or there must be some language I must be talking to Zach also. Let's say Zach understands English, right? So then what I have to make sure, I also should be able to communicate with Zach in English. Then only I'll be able to tell him the task, no? Right? Let's say at your home with your parents, you must be speaking some mother tongue, right? Like Marathi, Hindi, English, Bengali, etc., etc. Right? So what will you do? So whatever task needs to be performed, your parents or your Zach, we need to communicate it. We need to tell them what task has to be done. Okay? And we tell them in a language which the person understands. Right? It's like basically having a conversation, right, with the person to get a task done. Right? Similarly, for computer program also, when I said computer program is like communicating with the computer, that means I need to tell computer in a language which computer understands. Okay, so if I want the computer to do this addition of two numbers, I need to tell the computer in a language which computer will understand. Correct? I cannot speak English. I cannot speak Marathi. I don't know whether the computer understands. Right? If computer understands Marathi, very good. I can speak in Marathi. Okay. So similarly, we need to. So that's why we need a language. Okay, by which we can communicate. Okay, our task. Okay, our task related information to the computer, and that's where computer programming languages come into picture. Right? So between humans, right, how we have different languages. We have English, we have Spanish, right? We have Arabic, we have Hindi, Marathi, Bengali, Gujarati, so many different thousands of languages we have. What is the entire purpose of these languages? To have a communication, to have conversation between two human beings. Correct? Similarly, if you have to communicate with the computer, you will need computer programming languages. Understood why we have computer programming languages? Okay. Now, similar how you have humans have so many thousands of different languages. Similarly, computer programming languages are a lot. Okay. We have Java. Okay. We have C. We have C++. We have Python. Okay. JavaScript, etc. There are thousands of programming languages. In this particular course, we are going to understand the programming fundamentals using Python. Okay. Why Python? Because it's closer to a human language, which is English. That's why we're going to do Python. Okay. But yes, there's so many different languages. Now, we understood there's a computer programming language and why it is required. Right. Now, let's understand one more thing. There's something called as computer language. Okay. Or it is also called as the binary language. Okay. I think some of the people must have heard about this, if you are a little bit familiar with computer programming. Okay. If not, we'll see what it is. So binary language is nothing but a language which has only two alphabets, zeros and ones. Okay. That means if I have to say hello to a person in a binary language or in a computer language, I'm going to say what? Okay. Or let us, instead of saying computer, let me erase this for now. It's might create confusion. Let's assume binary language, which has only two alphabets, zeros and one. What do you mean by alphabet? C. English language. Okay. If you take up any word in English, right? Okay. Those words are made up of A to Z. Correct? Right? So all the words are similarly, these are called alphabets of the English language, right? Similarly, this particular language, binary language, the alphabets are 0 and 1. Okay, the digit zeros and 1. That means if I have to say might be hi, I would have to use sequence of zeros and ones. Some sequence of zeros and ones would make, let's say, hi. Okay. Okay. So basically, whatever I have to convey, I have to use this sequence of zeros and ones is what binary language is. Okay. To understand further why this 0 and 1 specifically is, see, finally, whatever you're trying to communicate with the electronic device, right? What you do it through your electric signals, right? Through signals, might be electric or radio wave, some signals you do, right? And those signals are usually like this. Either they are on or either they are off. Okay. Usually what you do is to on a 1 is assigned and to off a 0 is assigned. Correct? So this is basically what 1 and 0. This is from where the binary language comes into picture. Okay. It's basically machine language. Okay. Some ways which are transferring. Okay. So our computer, right, which we use, basically understands this binary language. Why? Because it's an electronic device, right? We charge the computer using electricity. Correct? So it basically understands the zeros and ones in a naive stage. All right. Now, suppose that this is a binary language. All right. Now tell me, we have this binary language, okay, here, which the computer understands. Correct? Computer understands binary language. It doesn't know any other language is what I'm telling you. Okay. You are here a person who wants to give some instructions to the computer. Okay. And let's say you know English. Okay. You do not know the binary language. Now, how would you communicate? There is a barrier. How would this person communicate? This communication is not possible. Okay. How will you solve this problem? Let's look into that. Before we dive into the solution of this situation, let's just take a step back and look into a real world. Real world, suppose you are a person here, okay? You know English, okay? And you want to make friends with a person, let's say, who's Spanish. Now what happens is this Spanish person does not know English and this person who knows English does not know Spanish, but they want to, let's say, communicate. How would you communicate? What is a simple thing which you have in real life? You would use a translator, a Google translator, right? Might be. What does this translator do? Now this translator would know both the languages, English and Spanish, correct? So whatever I say, let's say if I say hi in English, suppose, this translator will take this English, convert it into Spanish and send it here. Okay, whatever this person says in Spanish, will this Google translator, okay, would take this Spanish and convert into English and send it here. So now this person A and the person B now can communicate using a middleman in between. The example I've taken is a Google translator, but you can have any middleman who understands both the languages. Instead of Google translator, let's say you have a third person who knows English and Spanish, maybe. You can use him in between and say, okay, please, translate, whatever the person is saying. Correct? This is what we will do in real life. All right. Similar thing will happen in the computer world. Now, what happens is you know English. Computer understands computer binary languages. Okay. So, what we do is we need to find a midway. Right? So, that midway is your computer programming languages, which I just mentioned. Computer programming languages. Okay. So what you will do is you will communicate with the computer using computer programming languages. That's why we said, right, a programming language is nothing but it's a way of talking to the computer, telling him what tasks you need to get done. Okay. So now how this solves the problem? You as a human being can learn computer programming language, right? As like right now you have signed up for a Python course. Okay. So you will learn a programming language. Okay. Now this computer programming language knows to convert this, let's say you wrote something in Python, suppose. Okay. Now this, whatever you wrote, let's say in Python language. Okay. So what happens is this computer programming language will take this Python language, whatever code you have written, and convert it into what? Zeros and ones, into binary language which the computer understands, right? Computer will want to send something back, communicate something back to you. Again, it will do in zeros and ones. Okay, that's the only language it knows, which has only two alphabets, zeros and one. Okay, now this computer programming language knows whatever the zeros and ones is, convert this into Python and send you back Python. Something which you will understand. Okay, so this is where computer programming language helps us. I hope this is clear. Okay, what is a computer program? Why do we need a computer program? What is a binary language, or in simple terms, why it is called computer language? Because all computers understand this, all electronic devices understand it, so you call it like a computer language. But yeah, a more specific word would be a binary language. All right. Then we spoke about why do we need a computer programming language if we have to communicate something to the computer. Understood? All right. Fair. Very good. So this is our first part. We understood all these basic concepts. All right. Now, let's say I just said that similar to our human languages, right? We have different programming languages. What is the programming languages? In layman term, just let's understand, like a middleman which sits between a human being and let's say the computer and helps us to communicate with the computer. Why you want to communicate with the computer? Because you want to get your tasks done. Okay, fine, fair enough. Now we have different programming languages. Okay, so we have Python. I think I mentioned this, right? Java, C, C++, and so on. Okay. Now let's assume, let's come back to this example where a person is speaking English and the person is speaking Spanish, right? Now this Google translator needs to pick up, you need to use that translator, okay, which understands Google and Spanish, right? Let's assume instead of Spanish, now this, let's say we are speaking to, let's say some third person, a person C who knows Arabic. Then what will happen? You might have to change this translator. Why? Might be this translator is not fit for Arabic language. Correct? So based on the language which is there, which is used on both the end, you might need to choose a perfect translator or perfect middleman. Correct? Right? So now, if I have to do the same thing applies in the computer also. See, this computer programming language is a lot of languages. No, we said thousands of languages are there. Okay, we just saw 4-5 here, right? Now there has to be a way for the computer to understand, boss, this is what See, you write a particular thing in computer programming language, all right? Let's say you write something in computer programming language. Now we're going to go one step further, okay? Computer programming language. Let me write it properly. Becoming a bit messy. It might feel that I'm repeating the concept, but it's not. I'm just going a step further. Listen carefully. What I'm saying is, let's say you wrote a program in a computer programming language, okay? And now you're expecting this should, I just said, it's like a middleman. Now this will communicate with the computer who understands what? The binary language, right? But if you go one step further, actually there is somebody in between, okay, who would take your, might be we can call it as a compiler or an interpreter. What is it called? Compiler and an interpreter. If it's a Python, it's basically an interpreter, okay? It's interpretation language. So it's a compiler and interpreter who take your programming language and convert it basically into machine code. It will convert into machine code, or what we call it as binary language. Now, this compiler is actually more like a middleman, right? Okay, if you look from a higher, from a high overview, you could just say that the middleman is like a computer programming language. But if you want to take a step further, right, if I could just break down this entire box, it's something like this. Computer program languages, there is a compiler which sits in between and who is going to decode your computer programming language into your basically this. Now you would ask, why would you need a compiler in between? Similar thing as, why would you need different translators? Okay, let's say somebody wrote Python, a program in Python. Now you would need a compiler which understands Python and converts into binary code. Let's say tomorrow somebody came and wrote a program in Java. Then might be you need a different compiler who understands Java and converts into computer binary language. Okay. So depending on the programming language in hand, you will have to choose a different compiler. All right. Now, if this is clear, what happens is there has to be some way, right? Whatever code, let's say you wrote a piece of beautiful code, nice code you've written, right? Now you need to somehow see, it's everything electronic, right? Now you have, as a human being, you have to make a machine understand what you want from them, correct? So in this case, what is happening is you need to tell the computer that whatever boss have written this code, this is, let's say, in Python. How would that person know what, let's say I've written this file name as hello? Okay, now I want to tell this, whatever is there inside this file is basically a Python code. How will I tell that? So that, why would I need to tell the computer? Because according to what that Python, whatever programming language is, my computer will choose a nice middleman for it. If it's a Python, it will pick up the Python compiler. If it's Java, it will pick up a Java compiler, right? To help it to pick up a right compiler, I need to tell the computer somehow my program is in this XYZ language. Now that is done beautifully using an extension. File extensions, right? This is not a very different concept than, in a normal life, right? If you are using Microsoft Word, right, you would have an extension, I think, .docx, right? If you must have paid attention. If it's a presentation, if you're doing something in PowerPoint, you might have a different, when you say that power presentation, there is some other extension which is added, right, appended at the end of your file, right? Those are extensions. What are those basically? Those are basically not for you. Those are for the computer to know what kind of file it is. Okay, so that it can use this particular compilers or interpreters in between to convert it into the computer language. All right, so now if you've written a beautiful hello program, okay, then if I add .py in between, now this is my extension. This will tell the computer this particular code is written in Python language. Why it knows is .py tells it it's a Python code. The moment it knows it's a Python code, it's going to pick up an interpreter which understands Python and is able to convert it into the binary language, and vice versa. All right. Okay. I'm going to say vice versa means both the direction, from Python to binary, from binary to back to giving output to the user. All right. So this is why extension is there, right? Now for Python code, it is .py. For a Java, it is a .java. It's .cpp for a C program, right? And so on. Right? So different based on the programming language you use, you have different extensions. So for Python, we'll be using .py, which means it's a Python program. This particular whatever contents are there inside this hello.py is basically are written in Python, is what you're telling the computer. Understood? Why is it important? Because so that you can communicate in a rightful way with the computer. All right. Fine. If this is understood, All right, this is absorbed. Let's move on to write our first computer program in Python. Okay, very simple. I think you must have even heard about it, might be. Okay, all we're going to do is using a computer program. Okay, we are going to type hello world on the screen. What we're going to do, we're going to use a computer program. In this case, it's going to be Python code to write, to just print out hello, to print or to display hello world on the screen. Okay, fair enough. Now, before we do that, I would like to give, few, just disclaimers maybe. In this particular course, I would be using an online, interpreter for Python. All right. This is free of cost, so you can also use it. Or might be if you are really interested, you might just Google up and, have installed Python and everything in your system. Whichever works for you is fine. All right. Fine. So let's talk about our first program, which I'm going to say is we're going to print hello world. What we're going to do? We're going to print hello world like this on the screen. That's all we want to print. And let's say we're going to give exclamation. That's what we want to print. That's our program. So what is our task? If I go back to, to whatever we learned, task was also called as program, right? In a sophisticated word, it's called program. Almost, when I say sophisticated, I mean to say in computer programming world, we call it as a program, right? So what is my program? My program or my task is to print hello world on the screen. That is my task, right? Now, what is my input? What is my input? Input is my user or me, right? I am the one. I am the user, right? I am telling I want the computer to print hello world. So what is my input? My input is the string. My input is this hello world. This particular thing has to be printed on the screen. This is my input. Okay, to display this on the screen. To display on the, so if I write in a nice handwriting, display on the screen. What screen? Computer screen. Simple. What is the processing? Processing would be internally, where the computer will give its, signal to your, monitor that please print this for me. Hello world has to be printed. Correct? What is the output? Output would be that on the screen, right? Whatever your computer screen is, you would have printed hello world. That is your output. This is the output of the consequence, right? You will have hello world printed. Got it? See how I divided the task. My task was, what was my input? Display hello world on the computer screen. What is the processing? Processing is where I will be writing a code which that code will tell the computer, okay, computer will instruct its, monitor that please display hello world to me. What is the output? Hello world actually getting printed on the printed or displayed on my screen. Correct? So let's see how I'm doing it. Okay. So all I'm going to do is I'm going to just write one. So let's say this is my, file. I open a file. Okay. In your this, you might just open a notepad and just, start typing. You might just say print, and I'm going to say hello. Let me write it properly. I'm going to say print. Okay, print hello world, and we also wanted an exclamation, right? So I'm going to say print hello world. I'm going to, let's say, save this. I'm going to save this file. Let's say hello.py. Now this name of the file can be anything. Okay, it can be what? This name I can say is at abc.py. Agreed. Can I say dummy.py? Fine. This name part you can give anything you want. Name part. Okay, but can I have something like this? Can I say hello.world? This is wrong. Why? This extension does not make sense. You have written the code in Python. So .world, there is no language might be which is .world, unless and until you might be tomorrow, come up with a language, say, and you say that extension is .world, right? Possible. But right now, whatever code you have written, whatever code I've written here, right? This code is what in Python. So I cannot say .world. I will have to say .py because it's a Python code. Understood? Okay, why we have to do this? Because you need to tell the computer, okay, boss, listen, I'm going to communicate with you today in Python. So make sure you have your compilers and your middlemen in place. Correct? So that's the way. All right. So the moment I say hello world, okay, it's going to display on my screen like this, hello world. We'll see in practice also. Just explaining now. Hello world. Okay, a very simple Python program. So let me first show you how it's going to work. Okay, so I think I've already written. So let me just, so this is the one particular site I use. It's called repelit.com, /languages/Python3. Okay, it's free one. You can just go to your browser, whether it's Safari or whether it's Chrome, or Mozilla Firefox, any browser, and just type in this particular URL. I'll also give this URL. Okay, and you can just say print hello world. All right, and this is you can see this green button. This is going to say like run. This green button means run. You're done with the code and it's going to be run. The moment you run this, okay, there's some issue. Let me just refresh this. It's been open for a long while. Yeah. So I'm going to say here, yeah, see, hello world. So the issue I got right now, right? It's possible you might also get it. When that issue comes, that issue will come. Let's say you have, left your computer open, on this particular, this might be for 1 or 2, 3 hours, nothing you have done, right? So then just refresh it and then it will start working. Okay, so when you say print hello world, it's gonna say hello world. Why it's given comma? Because I gave comma. So let me remove this and I want hello world. I'm gonna say hello world. Got this? Okay, so now here instead of this, if I put double quotes, this will also work. Yeah, if I do this, it's gonna say hello world. Yeah, but let's stick to the single quotes one. It's easy, single quotes. Putting here. If you do this, what will happen? Let's try this without single quotes. It's gonna give me error. See, it says invalid syntax. What does it say? Invalid syntax. This means what? We're gonna see this. Why is it saying invalid syntax? Okay, let's just note this down. When I'm missing the quotes, it's saying invalid syntax. Okay, let me put this back. Might be in single quotes. Okay, again run it. It's working fine. All right. Let me now remove this. Again, it's saying what? Syntax error. Some syntax error is there, right? Now, let me again try. It is working. Voila. Instead of print, let's say I don't like the word print. I like the word display. Okay, I'm going to use display. See, again there is some error. I am not getting the output. Some error is there. Red thing something means there is an error. Okay. So again, I'm going to turn back to print. It seems the computer is not liking display. It likes the word print very much. So it's now hello world. Okay. Now let's see why those errors were coming. Let's understand it. Let me go back to my. Oh, fair enough. So if you saw, instead of see, if you write this particular statement, type this particular statement as it is, either it is hello world, or you do it, instead of single quotes, if you double quotes, it's going to work fine. There's going to be no issue. But the moment you change anything in this particular statement, right? So you're going to start getting error. Error as in you're not going to get the expected output which you're expecting from your program, that is to print hello world on your particular computer screen. Okay, why is that error? Let's understand. Now, when you learn English language, right, or when you learn any kind of language, what's the first thing you learn? You learn the alphabets. What are the languages made up of? And second important thing is you learn the grammar. Right? You learn grammar. Grammar tells us what is the correct way of using those alphabets or putting those alphabets together to make some sense. Right? If I say I am Deepali, this is a correct English statement. What does it mean? It means my name is Deepali. Like I am Deepali. If I say something like I Deepali am, does it make any sense in English? No. It's an incorrect English. Grammatically, it's incorrect. Correct? So, this, how do you say it's grammatically incorrect? Because I was not following the grammatical rules which are laid out by the English language. Correct? Now, this Python is also programming language. Yes, programming, but a language. Alright? So, like, so your, human languages, programming languages also have grammar. Okay? When I say grammar means they have certain rules in which you should write your particular code. Alright? So, the rule here is you need to use the word print. This print is going to tell, when the moment you use print, okay, after it gets compiled, okay, zeros and ones, whatever it happens, then the computer will know print means I have to, display whatever is there in this single quotes or double quotes to my screen. Instead of print, if you use display, okay, it's like the computer will not understand the language. It's no more Python now. It's some gibberish. All right. So that is why it's very important in your programming languages, no matter what programming language you're trying to code in, to follow the syntax. Or, okay, we call in programming language, we call syntax, which is very similar to grammar. Okay, you need to follow the syntax of your programming languages if you have to communicate with your computer correctly, because makes sense. If you are using a language, you need to use a grammar of that language. Otherwise, you will end up saying something which nobody will understand, right? So you need to write your, you need to use Python, which is a programming language, plus you need to make sure that you're using it correctly, so that it is it's easy to for the compiler to convert your Python, your correct Python code into machine readable format, which is nothing but binary language. Understood? Okay, so we saw just writing this one particular statement, okay, and saving this file. So right now, see, if you just noticed, I showed you this output on the online interpreter, right? There I didn't have to save a file. But if you are doing it, might be installing it on your system and, then trying to write a Python file, you can definitely do it. There you might need to save the file and give the extension .py. Okay, because I'm using a browser and it's like online, interpreter. It knows whatever I write in that particular black screen, right? It's going to be a Python code. Okay, so that's why explicitly I did not have to save it. Okay, so I'm saying print hello world. The moment I say this command, it's a correct Python code. It gets interpreted correctly in a machine language or binary language, and the computer does the job of displaying it on the screen. All right. So this is, I hope you have understood, what is a computer program, why do we need it, what are different computer programming languages, okay, why do we need a compiler or an interpreter in between, okay, what is the meaning of extension, why do we need an extension, file extension, right? And we understood and we wrote our first Python programming language code, which is to print or display hello world to the screen. Okay, I hope you've understood that. Hi everybody again. So in the second lecture, okay, we're going to understand variables and data types in Python. It's okay if you have not understood anything from this topic, nothing to worry about. The entire 1 hour ahead is going to be about these two words I spoke about, variables and data types. Okay, fine, let's get started. So now, until now, after the first lecture, everybody, I hope, have understood what a computer program is, why do we need one, right? And why we doing Python, all right? And we also wrote a first Python program, which was to print hello world onto the screen, right? Now, if you recall from the first lecture, there was one example, a typical example which I had taken was addition of two numbers. Where I had mentioned a human being said, Zach, I named the person Zach, and said, if I have to tell him to add two numbers, what all he will ask me. He'll ask me two numbers, do the addition and give me back the result or the outcome. Correct? Remember? Fine. Now, that was an example, if you remember, was of a task, right? A task is nothing but, something which you want a particular, like a task is what you want a computer to perform for you, right? In other words, it's called a program, right? In the same example, instead of, telling Zach, if I have to tell computer, if I have to write if I have to tell my computer to do addition of two numbers, if that is what my, I have to do, then I might have to write a Python code which tells the computer to do the addition. Correct? Fair enough. When I'm doing addition, what all input I need to give? First thing, I need to tell what is my input for this particular task. Input would be to do addition or to sum two given numbers, right? Let's say sum two given numbers. Obviously, you will be given some numbers, right? Okay, say two numbers. What will the processing done? Processing will be the addition of these numbers. Correct? That is the processing. That means addition is the processing. Okay. Next is what? The outcome or the output, which is nothing but the whatever the sum is. The sum would be the output. Okay. Fair enough. This is what my task is. Now, let's say I told you, now you understand, very smart. Now you understand if I have to do addition, I have to give input, which is the two numbers. Okay. Now see, when I tell you or when I tell Zach, okay, those two numbers, let's say the two numbers were 2 and 3, right? Now where would that two numbers 2 and 3 Zach would, store, right? Suppose let's say I give two numbers. Number 1 was 2, I think, right? And number 2 was 3, correct? Now, Zach would store this where? He would store this in his memory, in his mind, right? He'll remember, okay, Deepali has given me two numbers, 2 and 3. Correct? He'll store in his mind, in his brain. He's going to store this two number, right? Then he'll do processing also. Correct? Processing, he'll do addition of these two numbers. He'll also do addition of these two numbers in his mind, in his brain. Correct? And then whenever I ask him, let's say, if I ask him after 2 days, okay, forget 2 days. Let's say if I ask him, let's say at 10 o'clock, at 10 a.m., okay, let's say 10 a.m. on a Monday morning, I tell Zach, these are my two numbers, 2 and 3, okay, and I'll ask you the output later, whatever the additions, okay. And let's say I come back at 1 p.m. in the afternoon, and on Monday morning itself, and I'm asking him, hey Zach, have you done with the addition? Let me know the output, correct? Then Zach, what will do? Then Zach will tell me 5. That Deepali, the output is, or the sum of two numbers is 5, correct? If you realize, between 10 to 1, how many hours are there? 11, 12, 1. 3 hours are there, right? 3 hours, Zach has remembered this output 5. Where? In his brain. Correct? So, moment I ask him after 2-3 hours, he's going to tell me, Deepali, the output is 5. So, are you understanding what I'm trying to build up here? I'm trying to say, basically, if you realize till now, computer is nothing but we're trying, see, whoever the computer scientist, who created this computer, programming language and everything, what he basically did was, he or she is basically tried to mimic, okay, a human behavior, okay, and then try to put it, in something in the computer, in the machine. So similar, if you'll see, we need input, processing, output. Similar, now see, in this particular human example, what a human is needing is memory. Or human is needing his brain or his mind, where he's doing all the processing, he's keeping, remembering those numbers, remembering the output and giving me, the result. Right? Similar to this, okay, human person, computer should also have memory, no? Computer should also have a mechanism where he can also store numbers, and maybe if I ask him after 2 hours or 3 hours, he should be able to give me the answer 5. Correct? Yeah. So we would also need something called as computer memory. Did you understand why we need computer memory? Why we need computer memory? Because let's say I'm doing the simple addition, right? Where will I store this number? Okay, it is similar to your brain, your mind. Computer should also have a brain or a mind where he can do all this. So that is what we have computer memory for. Usually the RAM, which we call. Okay, simple terms, let's forget RAM and all. Let's say computer memory. All right. Now in your Python code also, there has to be some way of telling the computer, "Ki boss, listen, store this number 2 and 3 in your memory." Right? What your computer program is. It's a way of communicating to the computer. Correct? So that means somewhere in your code, you have to tell, hey computer, listen, you have to store this number 2 and 3 so that whenever you do addition, if I ask you after 2 hours, you should be able to retrieve and give it to me. Correct? So that's why there has to be a mechanism to tell, that you please store whatever this information is in your memory. And that mechanism is nothing but called as variables in Python. What is it called? Variables in Python. Now, in Python, they are called variables. In Java, also variables. So this is one concept, right? I think across all the programming languages, most of them, they are called variables only. It's basically a way or mechanism, of telling, your computer via your computer program, you're trying to communicate to the computer, whatever information is stored, you try to store it in your memory. All right. So we're going to study variables. Understood what variables means? Variables is a way of telling the computer, please store whatever information is there in your memory. Okay. Now, if I have to write this program, a Python program to do what? Summation of two numbers or addition of two numbers, right? What two things needs to be stored in memory? This is one thing. This is the second thing. And the third thing would be the result. Correct? No? Yeah. Now, somebody might have a question. I don't think not everybody, but someone might have a question. Ma'am, why would you want to store 2 and 3? Okay, just store the output. See, if you have this question, let me give you an explanation for this. Why do you need to store 2 and 3 is, see, when I tell you to add two numbers, 2 and 3, you are kind of storing, registering that in your brain. Okay. Very similarly, computer also has to do somewhere registering. Why registering it in your brain? Because how will you perform addition? Okay, let's say you know how to do addition, but you do not know the input only. You won't be able to do addition. Are you understanding? That's why we need to even store this information in computer's memory and final outcome also in computer's memory. Right? All right, got this? Now, we do that using variables. Let's see what is the, now what next step we need to see. We understood the concept. What is the second important thing to know now to write a Python program for it? We need to know the syntax, the grammar, right? How am I going to tell, in a correct syntax, correct Python syntax or Python grammar, that this is my variables. There has to be some syntax for the concept of variables. And there is. What we have is the syntax, if I have to say, goes like this. It's variable name, okay, equal to, or assignment. Equal to symbol, I think everybody knows this equals to symbol from mathematics, okay, or it is in a very fancy word, it's also called as assignment, okay, and whatever value you have here. All right, so this is like a syntax. Syntax means if you have to tell something in the form of variable, this is how you say. So how, let me give an example. So I had two numbers, number 1, number 2, right? Now this variable names, I'm going to say like this. I'm going to say number 1, or let's take a simpler one. I'm going to say A, okay, equal to 2. I'm going to say B equal to 3. Just see, this is, if I'm saying this is my syntax, okay, I'm saying this is my syntax or my grammar for variables. These two lines look very similar, no? Variable name is nothing but A. Value here is 2. In the second statement, variable name is B, small b, right? Value is what? 3. Understood? So now, this is going to tell Python, please store these values 2 and 3 under variable names A and B. Now, let's understand further. I'm not now somebody, ma'am, I understood variables is like memory, telling to store something in memory. But how actually it happens in computer? What is the use of this, letter A? Let's understand that. All right. So let's assume this is our computer memory. Okay, I'm not a very good artist, but I'll try my best. Let's say this is a computer's memory. Okay. And there are different locations. Locations means, see, if I have to come to your place, let's say after you learn this course and you become a very good programmer, a Python programmer, and then you decide, I will give treat to Deepali ma'am. Suppose you decide, what you will do? You'll call me to your home maybe, okay? Or might be you might call me to a restaurant and let's say, ma'am, I'm going to sponsor your lunch or dinner. Possible, right? Let's assume, wildest of dreams. All right. So what will happen? You will give me an address where I should come. Otherwise, I'll not know where to come. Right? You will give me an address. What will that help me? That address will basically help me to come to a particular location, to tell me, okay, let's say if you give me an address, let's say Dadar, Mumbai. Okay. So what I'll know from this, okay, there's some place in Dadar. Okay. And I have to, where is this place located in Mumbai? Right? So you might give me this address and I will be able, if you give me a correct address, a detailed correct address, I would be able to come to that location. Correct? Similar to this, computer will also store, if this is a computer memory, okay, computer memory has addresses. Okay, now here we do not have similar to how we have our addresses, but here what they have is basically numbers. Let's say, if to understand, let's not go very much in detail, just a high level if I have to understand. Suppose, let's say this particular location, okay, has a number 1100, let's say 1. This particular location might be here. Let's say this has a location, address 2001. Possible. I'm just giving an example. So whatever I store in this block, okay, this particular block has an address what? 2001. Whatever I'm storing here has an address 1001. Okay. So now what happened is, now this 1001, 2000 is 1. This is for the computer to understand. Right? But for you, let's say tomorrow, if you have to write the code, it becomes very difficult to deal with numbers, no? So what, let's say if I give a label, I would say this 1001 has a label. What I'm saying it has a label A. And let's say this 2001 has a label B. Okay. So this is what? This is like, this is a physical location which has 1001. I'm giving assigning a label to a memory location. What am I saying? Variables in another words could be said as these are nothing but labels which are assigned to memory locations. Can I say that? Yes, I can. Okay, in simple terms, I could say variables are nothing but, variable names are nothing but labels assigned to memory locations, right? So let's say now my 2 gets stored here and 3 gets stored here. Understood? Now, what have you understood now? When the moment I use this syntax, this is what happens inside the computer. This is what, whatever we saw here, this is what happens. It's going to find a location, an empty location, right? You cannot overwrite something. Let's say somebody here was 10. You will not put here, no, that you won't do. Okay. What we'll do is we'll find some empty location. Let's say 1001 empty, and we're going to give a label, say A, and I'm going to store the information. What was my information or value? This can be information or it can be a value. Okay, information of value is 2. Second, if I found B equal to 3 was this. Why is the word assignment used? Because 2 is assigned to this memory location. 3 is assigned to B. Understood? Okay, I hope it is clear. Variables, it's a way of trying to tell your code that please store this whatever information I'm giving here under this particular label. Why label? Because now might see when you're doing this now, once you store this, in future in your code you might use it. No, in our particular program, our program is to do summation. So once you store this, you would use them to addition. No, you would have to somehow call this value 2 and 3. How would you call it in your program? You can call it using the names labels. What happens because of this? You do not have to know the addresses where the computer is storing. Right? Let's say at 10 o'clock you run this program. Let's say this label A was assigned to 1001. Okay. Might be in a after 2 days you again run this program. Might be that time 1001 was not free. Some another location, let's say this location was free. Correct? And suppose this was given the label A. Possible. But does it affect you? No. For you as a computer programmer, what is important? Labels, which is nothing but the variable names. Right? You don't have to worry about the addresses or anything. Okay, if this for some of the audience, if it is going a little beyond, not able to understand, it's fine, it's all right. All you need to understand is variable names are nothing but labels assigned to memory locations. It's basically like an address. Okay, the moment you call it, you will get your value, whatever is stored inside it. Okay, if that much is understood, it's more than enough for the entry level. All right. Now let's move forward. Now what we did, now we understood the first step was to input, right, some of the 2 given numbers. Now we know variable concept. So now I can take this input A equal to, I can, store this value A equal to 2, B equal to 3, right? Next, what I have to do, my processing step is I have to do addition of 2 numbers. All right, I will do addition. What do you do addition? Usually what would you do in maths? In maths you would do 2 plus 3. Okay, and you give me the answer as 5. Now this 2 is stored under which label? A equal to 2. So I'm going to say A plus, right? Python also understands this plus symbol remains the same. And I would say B. Why B? B is storing 3. Correct? So A plus B would give me 5. Now again I want to store this value 5, right? If you go back, if you see, we said we have to store this. We have to store this to computer's memory and this, the result. Correct? So I'm going to go back here and again, what is my syntax for variable? Value gets assigned to the variable name or label. That means this is my value now, A plus B 5. This has to be assigned to a variable. Let's say my variable name is answer. Okay. Instead of answer, I can give a nice name here. I can give sum. So if you look at it, right, I can give this variable names anything I want. Instead of sum, suppose you want to give your own name. Ankita. Fine, no problem. Instead of A, you want to give, let's say chocolate. No issues. As long as you, let's say you have given A equal to 2 and you're using again A here, it's fine. What is not fine is, suppose here instead of A, you might use, let's say, parrot equal to 2. And here you are saying A plus B, then that is not fine. Why? Then the computer does not know what parrot means. There is no label in the computer memory which there's no memory location in computer memory which has parrot. All right, you just need to be consistent. If you are given a label for 2 as A, make sure when you're doing the summation, try to use A plus B. All right. Okay, somebody might have, come up, like, ma'am, let's say this particular location has a label, let's say parrot. Okay, suppose. But we do not know, no, is this the value where you stored 2? No, we do not know what this value is. You have stored your value under the label A. So that's why make sure you use the correct variables, names whichever you have assigned in your computer program. All right. So I'm going to say sum equal to A plus B. Now what happens? There'll be one more location here, might be, let's say 1500. And now this location is free and I'm going to have the label sum, and here my sum is 5. So 2 plus 3, 5 is stored here. Okay, understood? So what I've done, I have done the input part. I have done the processing part, right? Input is done, processing is done. What is the last step? Output, right? If it's a computer program, what will be the outcome? You will have to print it or display it on the screen, correct? And I think everybody is a very expert in how to display something on the screen. What did we do last time? If we had to print, hello world or display hello world, what we did, the syntax was, we used the word print, right? We opened a bracket, closed a bracket, in between I'm going to say sum. So what this basically tells is print. The moment you say print, computer knows that whatever is there inside this open and closed, braces, I have to display that onto the screen. Okay. Now because this is a variable name, okay, it is going to look into the computer memory and find, is there a variable name or is there a label name sum? And it will find one, right? Whatever value is assigned here, that would be displayed on the screen. So the output on your screen would look like 5 once you run this program. Is it understood? Okay, let me go again step by step. What we thought about is variables in Python. All right, what are variables? These are nothing but a concept by which, nothing but labels which you assign to memory location. It's a way, via your computer program, via your Python program, you're telling computer, please store this information under this particular label so that you can retrieve it later in your code. Okay. All right. So now if I have to do addition of two numbers, what I have to do is basically first save this two numbers in my computer's memory, which I did by using these lines, A equal to 2, B equal to 3. What was the syntax? Variable name equal to value, right? After that, I did the processing step. What was the processing step? Sum equal to A plus B. And the last step was output. I have to display it on the computer screen, which I did print and sum. Okay. All right. Let's see, how this actually works on the code. Let me switch back to the, online interpreter. Okay, it still displays that particular print hello world. Let me erase this. Okay, how would you do? Just do Control A and delete. All right. So what I'm going to do is I'm going to say A equal to 2. That's what I'm storing. A equal to 2. B equal to 3. Fine. Now I'm saying sum equal to A plus B because I want addition. Then I want to print it, display it to the user. Then I'm going to say sum. Now if I run this, it says 5. Correct? What happens if I remove this line number 4? Let me just erase this. And if I run this, the program has run successfully. Did it give me any error like last time? Anything red is being displayed here on this part of the code, of the screen? No, right? That means what? It did input, it did processing, okay, but it is not telling me what the output is. If I have to somehow print whatever the output of this program is, I need to tell the computer that you need to print the output, right? Where is the output stored of this program? In the variable sum. That's why I'm saying print sum. The moment I do this, what happens is it's going to print me the value of sum. Understood? Let's say one example which I gave, right? Instead of A, let's say I like the bird parrot and I'm going to say parrot. And if I do this, what will happen? Let's see. See, it gave me an error. It's saying, see, A is not defined. That means it did not find this A only in your memory location. So it's not able to understand what I should do. That's why it's giving you an error. Error means what? When the computer does not understand whatever you are trying to communicate. Okay, that's when its way of telling you back is by giving you an error. That boss, I don't understand what you're trying to tell me. All right. So then you go to the code and see, oh, by mistake I did parrot. So you will again do what? Change here A. Or might be if you want parrot only, you like parrot so much, change this A to parrot. because your information 2 is stored inside the label parent. And if I do this, it's going to run fine. Right? Did you understand? So that means whatever labels you give, for your information or for the value you want to store, make sure you use it when you're trying to, when you actually want them in the code, right? So if you're at this line number 3, I want the value sum. I want the value, 2, right? So that's why I have to make use of the correct label, which I have assigned. All right. Yeah. You can just take this down maybe, and, just try it out. Okay, might be on this online interpreter, or if you have installed Python on your system, just write this 4 lines of code, yeah, and just save the file. What name would you give any name you like, addition or program 2 or sum, but I would say try to give a name which will make sense. Tomorrow, after let's say 4-5 days, you come back and see what program you've written, right? If you give the name appropriate name like sum.py, you can make sense. Oh, this was the program where I did addition of 2 numbers. All right, so might be save this program as sum.py and then try to run it. All right, now one more thing, right? Make sure, suppose let's say if I give a space here, right? And let's see if I run this. See, it's giving me error. It's giving me indentation error. Okay, what is it giving me? Indentation error. So in Python, this is specific to Python language, you do not have to give any space. Make sure all this is without any spaces. Otherwise, it'll give you indentation error. Okay, print this as it is. Like, don't put, you put a equal to 2, you decided no, I will do like this, b equal to 3. No, it will give you error. See, just try to do it as it is, because it's a syntax of Python. Indentation is nothing but how many spaces you give, right? So in Python does not like it if you do not give a proper spacing. It wants the program to be written in a particular way. Okay, so make sure every line, this is one subtask, right, on a given task, right? Every subtask should be in a different line. Okay, so this line number 1 and 2 is basically input, right? You're trying to give the input and storing. Line number 3 is nothing but processing part, right? And line number 4 is where you give the output or the outcome of the program. Okay, fair enough. Let's go back. Let me move to the, yeah, okay. If this is understood, right? Now let's do something which is called as, let's do similar line scale. Let's do second program, which is subtraction. Okay, subtraction program. What I want to do is basically you need to take input would be to take 2 numbers and give me the subtraction. Numbers is a short form for numbers, basically. If you don't like this, you can just write numbers. Yeah, and I'm going to say 2 numbers. Okay, so take 2 numbers and provide the subtraction. That's what your program is. Next program. Will you want to give it a try? What the steps would be? Very similar to addition, right? What the steps would be? First steps would be to take 2 numbers. Correct? So how would you do? Let's say you have to subtract, let's say 7 and 5. Then 7 minus 5 is, what is 7 minus 5? It's 2. Correct? So your output should be 2. What is the input? 7 and 5. Right? So what you do, say, let's say I'm using the same variable names because a different program, right? I can do that. I'm going to say a equal to 7. I'm saying b equal to 5. Now I've written in one line, don't make a mistake. Excuse me. I'm saying b equal to 5. Okay, so this is nothing but my input. Every program has 3 parts. Second part should be the processing. Correct? And the last step should be my output. In our case, what my output should be, my program wants me to print the subtraction on the screen. Okay, so what am I going to do is, I'm going to do subtraction. So let's say I put it as subtraction, sub. Instead of sub, you can even write the entire word. Instead of, if you do not like the word subtraction, you can also say difference. No problem. You can say whatever you like. If you want to say subtraction, difference, you want to say answer, that is also all right. Anything is okay. So if I'm going to say result here, suppose I like the word result. Result has to be, what is the processing part? I have to subtract. What I have to subtract? 7 minus 5. So what will I write? A minus B. Okay. If you wrote B minus A, this processing is wrong. Why? Because you are expected to do 7 minus 5. Correct? Where is my 7? 7 is in A. That's why I can't change the order. So I'm going to say A minus B. What is this step doing? Whatever, it will do the processing. Let's say this 7 minus 5 is what? 2. Now this 2 gets assigned to the label result. Right? Last step is I want to print the result. I'm going to say print. I know print is the command which is used. Right? I'm going to say open and close, and I'm going to write this variable name which is result. Right? How many steps? 3 steps. Input, processing, output. For this, yeah, let us try this out quickly. So let me make change. Let me just erase this. Sorry. Control A and this. Yeah. So I am saying A was having 7. B is having 5. Okay. I said result. Result is equal to A minus B. Yeah. I'm going to say print the result. Right. Let's do. Yeah. Instead of result, if I want here difference, yes, I can do that. What needs to be done? If this is difference, this also has to be difference. Yeah. So I got the output as true. Okay. Instead of A and B, if you want some different names, some nice names, let's say number 1 and number 2, yes, you can go ahead and do that. Number 2. And if I run this, it's gonna. Oh, why did it give me error? See, it's saying A is not defined. Why? If I'm making number 1, I have to make sure I use here also number 1, and here has to be number 2. Alright. If I give a space, let me first run this and show it's working here. If I give a space here, by mistake, it's going to give me an error, because what is the variable name? Number 2. Okay. So Python is very sensitive with cases of spaces. Okay. So make sure you do not make any mistakes. Alright. Fair enough. Yeah. Let's move on. Alright. If this is understood, okay, so where we've understood, what is variables, how to make the computer store those values in the variables, and how to use it, right? Now, let's talk about data types in Python. See, there's a reason I'm always saying this word in Python, okay? Because might be there are 2 things. One thing is this concept is present in Python language, okay? I'm not saying it's not present in other languages, but right now specific about a particular language I have in hand, which is Python. Second thing important is syntax. Okay. So right now the way I'm writing A equal to 7, this is correct for Python. Might be it may or may not be correct for, let's say, Java. Alright. So the syntax, okay, might change depending on the programming language you have in hand. But the semantics might remain the same. What do I mean by semantics? See, when you're writing a computer program, I told you that you need these 3 things: input, processing, and output. Okay. For input, the concept we saw was of variables. Variables, nothing but it's a way of trying to store something in the computer's memory. Right? This is a concept. Now, this concept will be there for all languages, all programming languages, right? Because everybody has to store. There has to be some way of telling the computer, okay, in that language, the programming language, please store this information in your computer's memory. Right? That means this variable concept is there everywhere. What might differ is the grammar, the syntax of the way of writing it, or the way of communicating it to the computer. Did you get me? Okay. Now, suppose one more example. Let's say print. What is this print function doing? What the print thing is doing? It's like a command in Python which tells the computer, please, whatever is there here, please display it on the screen. Correct? Now, this is in Python. It makes sense. But tomorrow, if I'm using Java language, maybe I won't use print. Might be some another command which is suitable for Java language. It's similar, like, for example, if I have to tell somebody, hey, you are a very nice person. If I tell them in English, what will I say? Hey, you're a nice person. But if I have to tell them in Marathi, what would I say? Tu खूप चांगली आहेस. Okay. Both the sentences mean the same thing. The semantics is same. The meaning is same. But the way I'm saying it, the alphabets which I'm using, everything is different. Okay. Similar what we have in computer world also. That's where your languages differ. Concept remains the same. Okay. But the syntax differs. All right. And listen to me, if you just know a piece of advice, might be now Python is very popular. Okay. And more than popular, it's the simplest programming language if you are new to the programming world to understand. Okay. A programming world in general. But as you want to, let's say you master Python, tomorrow if you want to say learn Java, it's not going to be a difficult task because the concepts are transferable. The concepts of memory are going to be in Java also. What changes is the syntax. And that is not something, too difficult to pick up. You have Google at hand. You can just Google out the syntax and it's okay. All right. Try to understand the concepts which I'm trying to give you. All right. Because those are transferable for any programming languages. Most of the programming languages, which you will encounter today and tomorrow in your future. Okay. Let us get back to the subject. Okay. Now, we have data types in Python. I kept on saying here is variable name, whatever information or whatever value you want to store in the computer's memory, you can give a label, right? So I mentioned the word information or value. In layman's term, I said value. Okay, yes, this is what I did, correct? So this information or value, okay, this has to be divided into two parts, is what I'm saying. Okay, to give an example, suppose I say Deepali and write a word here 24. Forget programming language, forget everything. You tell me, let me just remove those double quotes. Just write here. This is plain English, right? What do you understand? What will you tell me? What is the if I ask you what is the difference between these two? This is one, this is two. What is the difference between these two things? What is the thing you will tell me? You will say this is a number or these are some digits. Correct? And this is what? Some word. Okay? Somebody is, very good in English might say this is a noun. Proper noun. If you do not know that much of English, forget it. But what is it? It's a word, English word, English word. Okay, right? So what is the difference? It's a number, it's a word. Simple. Correct? Now, how do you know that? Because you know the English grammar. Correct? And what is benefit of knowing this? You can make sense, right? Right? If I am saying Deepali is going to come to Bangalore tomorrow. Okay, so what do you understand? You will understand, okay, Deepali is some person. Okay, what you understand? This is some person and he's going to come to Bangalore. She's going to come to Bangalore, tomorrow. Right? If I say Deepali has 24 chocolates. Okay, this 24 is like, it's like a number. It tells you 24 is a number, right? It's quantifiable. It's a number, right? So these are two different semantics which we use when you're trying to convey information even in a normal human languages, right? So every piece of information can be broken down into words and into numbers. Similar to that, in Python also, every information, let me erase this, every information can be broken down into two things, into words and into numbers. Okay, this words, right? This words is something called in Python language as strings. What are they called? Strings. Strings and numbers. Let me write this again. Just want to make sure everybody understands my handwriting. So, numbers. Okay, this is strings and numbers. Okay, let's understand numbers easy. Numbers is nothing but you would have 1, you would have 2, 3, 4, 5, okay, and so on. You will have what else? You can have 0. You can have negative numbers also, no? In maths, we have studied negative numbers, right? What else we have? We have 1.2, 3.5, correct? What else you have? You can even have negative minus 1.2, right? These are all numbers, no? So there has to be a way of representing this in Python also, okay? So numbers further are divided into two parts. They are called integers, okay, and they are floats. So let's remove the s, it's not required. It's either the number is an integer or a float. Okay, integer means without decimal points, means 1, 2, 5, 0, -1, -2, and so on. Okay, float means with a decimal point, 1.2, 3.5, -1.2, and so on. Okay, so float is what? What is the word float? F-L-O-A-T. It is with decimal point. So numbers with decimal points are called float. That means float also has 1, 2, 3, and so on. Right? Integer means no number without a decimal point. If I have to put it in a diagram, what could I say? If this is a space which represents all numbers, okay, suppose integer is inside and then there is a float. What does this mean? 1.2, okay, is only a float because it is decimal point. It cannot be an integer. But let's say 1. 1 is an integer. Yes, it's an integer. Okay, I can call it as a float too, but it's an integer. If I have to call this as a float, I'm going to say 1.0. Float. Getting my point? So it's an integer, this is a float. Floats, just remember, with decimal points, integers without a decimal point. Simple. Nothing to, even if you don't understand this diagram, it's fine. All you need to remember is numbers can be further divided into integer and float. That is what this is Python's way of understanding information. Data types means whatever information you're trying to tell Python to store or to, process, okay? Python will try to understand in two ways. One is it will say information is either a number or information is either a string. Similar to we saw, right, when I gave you those two things, I said Deepali and 24. You told me 24 was a digit, it was a number, and Deepali was a word, English word, right? Similarly, when you give something, to the Python would say 24 is a number, okay? Specifically, it would say 24 is an integer. Why? Without a decimal point. And it would say Deepali might be a string. We'll come to strings part now. Okay, so data types in Python, it's a information can be divided into two parts, strings and numbers. All right, now if strings, it's very easy in Python. Whatever you put inside double quotes, okay, or whatever you put inside single quotes. So in Python, right, in Python 3 specifically, double quotes and single quotes means the same thing. Only just make sure if you're starting with a double quote, end with double quote. Okay, that means if you're starting like this, don't do this. This is wrong. If you're starting with this, don't do this. No. If you're starting with double quote, end with a double quote. Starting with single quote, end with a single quote. Okay. So strings are nothing but whatever you want, just put it into double quote, that becomes a string. So what am I saying is, suppose if I say Deepali like this is going to be a string. Why? Because it is inside a double quote. If I say Deepali like this, what is it? It is a string in Python's language, right? If I, let's say, move, let's say if I say, good, this is a string in Python. Let's say if I say 14, what is this? If I give this like this to Python, according to whatever we saw now, what is it? Is it a string or is it a number? What do you guys think? Think it through. What was the definition I gave? For Python, see, when it's machine, no, everything has rules. It will always obey rules. No? It's not like us. It will always obey rules. Huh? So numbers I said is what? Integers, either 1, 2, 3, 4 or float point, whichever decimal point, right? What is string? String is nothing but anything. I'm saying anything you enclose within your double quotes or single quotes become a string for Python, right? Now, the first thing might be somebody would say it's a number. No, it is wrong. This is a string. Why? For Python, it's not going to even look inside. It is saying, okay, there is a single quote, okay, which is then there's some information here. I'm going to treat this piece of information as string. All right. Okay. See, yeah, finally it's 14 only, but it is the way it is going to process the information. It is going to say that it's like similar to saying, right, when I gave you when I gave you a number 24 and Deepali, you told me this is a number and this is a word, right? Similarly, if I give now this to Python, Python is not going to tell me this is word. Python is not going to tell me this is a number. Python is going to say this is a string, similar to this is a word. Understood? So whatever is there inside your single quotes or whatever is there inside your double quotes becomes a string. Yeah, understood? Okay, so this is a string. Okay, as opposed to if I give it simple as 14, this is a number in Python. All right. If I do 14.2, this is also a number. So what is a data type attached to it? It is a number. All right. Yeah. Now, the reason why we have data types, let's recall that again. It is basically the piece of information. Python is trying to make sense of it. It divides every piece of information to two categories. Okay, the division of, classification of information into two categories, strings and numbers. All right. Why is it useful? See, if you remember from this memory location, this is a computer's memory, right? Let's say for numbers, let's say it is giving only one piece, one block to store. Okay. But let's say the moment the information, let's say if I put your variable like this, x equal to Deepali, right? So if it is a string, Python might decide to give it 3 blocks, right? So might be one of the use of, the type of data type it is. One of the use of recognizing what data type, my variable is storing, okay, would be, to decide the amount of space I should, give for this information to store in my computer's memory. Makes sense, no? Number might be, it is suppose it is 2, might be it is a smaller, it just requires, let's say 1 block. But let's say Deepali requires might be 3 blocks. Now it is 3 blocks or 1 block. How it will know? It will know when it can, categorize or classify that information into different types. What is it? Numbers and strings. Okay, just an example. Why might it be useful? We'll see further as we go further in the lectures, right? Why, this classification is important. Okay, understood. So one more example which I can think of is, let's say you tell, see, you're saying a equal to 2 and say b equal to 3, the addition example, right, where you are doing the addition of two numbers. Okay, now see, you told computer a equal to 2 and b equal to 3. Fine, you know that these are numbers. Okay, and you can do addition, right? But Python also, it's a machine. Machine means you have to tell them everything. You cannot assume that it knows everything. You have to make it intelligent. A machine itself is dumb. It's human beings who program it, who code it, are intelligent. Okay, so it's your job, because you are intelligent. You are trying to literally baby feed a computer with all the small steps it can take, okay, to achieve its goal. What is the goal? The task which you have at hand, right? What is a program? Program can also be like a baby steps. You're telling computer how to achieve a specific goal by following these baby steps. All right. So you need to, first thing, you need to tell your computer, boss, listen, we are going to do addition of two, numbers. That's why treat this thing as a number. How it will treat this as a number? Because it doesn't have what? Double quotes or single quotes. Therefore, this is a number. This is also a number. Right? So now if I do addition of two numbers, yes, we can do addition of two numbers. All right. Let's say by mistake, suppose if you give it a equal to Deepali, all right, and if it says b equal to 3, now if I do sum equal to might be a plus b, it's wrong. It's mathematically wrong. You cannot add a word and a number. Makes no sense. Or you do, so let's say subtraction of Deepali and 3. No, doesn't make sense. Both of the information should be of same type. Correct? Deepali is of type string and 3 is of type number. Okay, so such things, right? It's very important that Python understands, or the computer understands, what this information should be treated as. Should it be treated as a, a word or a string, or should it be treated as a number? Okay, understood? All right, so that's why the concept of data types in Python, very simple. We just need to know two. One is strings. Whatever you put inside single quotes or double quotes becomes strings. Numbers are nothing but your, it's with a decimal point and without a decimal point. Without a decimal point are integers. With decimal points, including decimal point, becomes a float. Okay, this is what you need to know. Yeah, I hope the concept of, computer's memory, variable, and data types is clear. All right. Welcome back to the third lecture. So in this particular lecture, right, we're going to do something a little easy. Okay, I know it's might be variable concept and data types a little difficult to understand, but so this lecture keep it a little light. All right. So if you recall, right, one of the programs or whatever programs we have done so far, what we have done is, let's say addition, right? We said a equal to, what was it, 2, b equal to 3. Okay, and then we had a result, right, where we basically, let's say, where we do let's say sum, and I said a plus b. All right, and then I had to print the value, and I said sum. Okay, now this did the job beautifully well, right? It took two numbers, 2 and 3, and it's gonna print it for me. All right, fair enough. Now let's say you take this particular code. Okay, let's say you have stored this, might be saying, sum.py or addition.py. Okay, and you're very excited, you wrote your first Python program, you go to your father or your mother or your best friend maybe, and you want to just show off, oh, I've written C, let's see my, addition program. Okay, and let's say you run this. What will happen when you run this? It's gonna just display 5 on the screen. Agreed? Yeah. Now, just by looking at 5, right? Let's say your father or mother says, my dear, this is a good, it's giving you the addition of 2 numbers, 2 and 3. But why not, you add a message, okay, saying the addition of 2 numbers is 5. What is it saying? Instead of just printing 5, your mother or father or your best friend is saying, it would be very cool if your program could say the addition is 5. Fair ask, right? It's saying, Yana, it should print this. Now what will you do? You know how to print the value of this. Remember? Also, if you recall from the first lecture, we had printed like this, hello world. Remember? Yeah? So we know how to print a string. Now, look at this, the addition is, right? This particular statement, the addition is, it is going to remember same, correct? Okay, so I will be calling this as a string. So somehow I have to store into my computer that the addition is string. I have to tell when I'm printing that it has to print this, particular statement, the addition is followed by whatever the value is present in sum. This is present in where? In sum. Okay, forget string for now. Let's say this is some statement which, I have to print and followed by the value which is present in sum. Correct? Sum is my variable. Correct? So how do I do that? Using print statement. So ideally what I have to tell my computer? I have to tell my computer that please print or please display the addition is followed by the number, the sum. Right? So I do that using a syntax. Okay? Let's see. I'm going to say the addition is. Why did I put double quotes? Because is this a number? No. And Python only understands 2 things, either number or string. Okay, so whatever I put inside my double quotes becomes a string. So it's going to say the addition is, and I also have to print sum. Okay, now this is a string, right? Followed by whatever the value is present in your variable, right? This is a variable. So you are going to tell them print this followed by this. So print this and this, right? So that is done using an operator called comma. Simple comma, which you have in English also, comma. Okay, you can see it in your keyboard also, there will be some comma. Usually, below that angular less than sign, right? So when I say this, computer will understand that whoever is writing this program wants me to first print the addition is followed by whatever the value is present inside sum. Okay. So this particular thing, this is basically syntax. Okay, this helps me in conveying to my computer that boss, please first print this, then print this. Okay, it's like a separator. It's like and or separator, right? Okay, so let's try this out. Let's see how it works. I hope you can see my screen. Yeah. So now this is difference, right? Let's forget this. Let's write that code again. Where is A equal to 2, B equal to 3, right? So, and we had sum equal to A plus B, right? And usually I just print the sum. That's what we had done before, right? Which will give me 5. Now what I want is, I want to print the addition is followed by sum. So what am I going to do is, I'm going to say, let's say I'm using single quotes. I'm going to say whatever you want to write here, you can write, right? It does not check. Basically, when you say double quotes, it does not check syntax inside it. Whenever Python compiler, sees double quotes, it is going to just treat it as, it's not going to do any processing. Okay. So when I'm saying the addition is, okay, if you put a space here also, it is going to come. I'm going to put a comma and I'm going to print sum. And the moment I run this, it's saying the addition is, see, it gave space between 5 and this, right? Because the reason I gave a space here. If I remove this, see, one space is gone, right? Okay, by default, one space would be given because of the comma, right? Because it's a separator. But here, if you give additional commas here, like this, it's gonna print those additional spaces. Okay. So here I do not want that. I'm just removing it. because I just want the default one space, and this is what I'm going to get. The addition is 5, right? So the cool thing, so what we did, instead of just printing out the value, just a number, I'm also giving a message. So now what is happening, my program's output has become more expressive. All right, I do not even have to tell my mother, father, or my best friend what this program is about. The moment they say this output, they know, okay, this program must be doing some addition, and the addition of some numbers is 5, right? Fair enough? Yeah. Now let's do more. Let's try to give more information. Okay, now if your mom and dad said, or your sister, your sister, brother, your friend said, whoever you're showing the program, okay, this is cool, you could do this, but how about you also display the numbers which you're trying to do the sum of? That means they want you to tell that the addition of 2 and 3 is 5. That means this is crystal clear, no message. Addition of 2 and 3 is 5. This is what they want you to print. Okay, so how would you break it down? The addition of, can this be a string? Yes. Something which I can put in double quotes or single quotes. This number, this 2, where is it stored? A variable. So can I just put it as A? Now somebody might argue, ma'am, why can't I put everything, starting from here end till here, why can't I put into double quotes? Yes, you can put into double quotes. No mind, it's going to print the same statement as it is, right? But the reason I'm trying to use A here, because tomorrow might be, your mom or dad says, now do not do addition of 2 and 3, do addition of, let's say, 1900, right? So what will you do? The value of A and B is going to change, and also you'll have to make the change here also, right? I don't want to do that. Okay, I want to pick up whatever value of A and B is set, right? So this is A, this I can pick up from B, and this can be picked up from the variable sum. Whatever else is remaining is nothing but string. String means if something I want to print or display as it is without the Python, using its own memory on its own head, I'm going to just put it into string. I'm going to tell Python, boss, don't do anything, whatever is it, just print on the screen. For this I'm telling, if I'm putting this A, that means I'm telling Python, this is the label, just go to the memory location and retrieve the value which is stored inside this label A or under this variable name A. Understood? So if I have to say this, in your Python language, right? Let's see how we're going to do. What I said, I'm going to use the command print. Print remains the same. Nothing changes. This open and close bracket is there. That is the syntax. Now what is the statement? It's saying the addition of. I can put this inside my single quotes. If you want, put in double quotes, is fine. If in some of your, Python editions, if single quotes doesn't work or double quote doesn't work, just try to switch it, right? Use single or double. One of them will definitely work. Okay. So you can say the addition of, all right, I'm ending this. Now what I have to do? I have to tell after this print the value of the variable A. How you do that? We saw in the earlier example using a comma or a separator, which is comma here. So I'm going to say comma A. Again, I have to, this is a string. So I'm going to say and. Again, what a comma. 3 is a variable. Again, a comma. Why? Because is a string. Again, a comma. Where is my 5 stored? This is same. Understood? The addition of, this is a string. Comma is like a separator. Like first print this, then print the variable. Why if I do not put comma, what happens? Now the computer will not understand. These are see, if you look at this, these are two different constructs, right? This is a string, this is a variable. Okay, when it looks at this, it doesn't have to do any processing. Okay, it needs to know that this has to stop here and then something else begins. It's like saying and. Do this, print this first, and then print this, then print this, then print this, then print this, then print this. Right? Follow a order. Okay, did you understand this? Okay, I think it becomes clear when we try to code it up. So instead of doing this, what I want is the addition of A and B is, addition of 2 and 3 is your 5. That's what I want to print, right? So this becomes addition of, all right, I'm going to put a comma. What is my value A stored? Here A. Again, I put a space. Why? Because I need to print the word and. Then A and what? B. B is a variable. Then I have to do what? Addition of A and B is sum. Right? If I do that, See, voila, I got that addition of 2 and 3 is 5. Okay, now how does this help? Now tomorrow if I change it to 6 and let's say 2, I'm gonna get 6 and 2 is 8. I didn't have to change anything in my code. Do I have to change the statement? No. Once I set this, it's fine. Okay, did you get this? So what you're doing is, we learned using a comma, okay, we can try to separate, here we're trying to print a string followed by the value which is present at a variable, again followed by whatever string is there, right? So you can print using the print function or the print, using this print command in Python. You can not only, print only the value which is inside a string, or the value with of a variable. You can also try to print both of them together, like one after the other, as we have done in this example. Did you understand? Yeah, you could also like this, you could say print by. Yes, possible, I can say print by. All right, okay. So what am I doing is print this part, the addition of, because this always remains the same, that's why I'm saying addition of, oh my spelling, TION, the addition of A and B. Okay, or you could say the sum of A and B, the sum of 6 and 2 is 8. So now we're looking at this output is complete, right? Just when if anybody looks at the output, anyone can understand that this particular program has taken two numbers. The numbers are 6 and 2 and has given the sum as 8. Okay, did you understand this? So we have understood in this small lecture that how you can write, how you can display messages onto the computer screen, okay, by making use of the variables also, right? So here we are trying to print some statement plus some, some message, right? Some message you're trying to give, plus you're trying to display some value of a variable. Value of the variables here which you are printing are A, B and the sum. There are three variables, right? Excuse me. How are we separating this two? By using the comma operator. Now see, let's say if I forget to give a comma here, I give space here. It is going to give me an error. See, it's going to say invalid syntax. So you have to make sure you give commas everywhere. Okay, that means your grammar always has to be correct. Did you understand this? Just try it out, right? And I think you'll get a hang of it. Okay, just to separate between a string and a variable, just put a comma. That's all. Right? Yeah. I hope this is clear. Okay. So by using, until now, what have we covered? What a program is, what are different programming languages, what is a extension, like .py, right? What is a binary language? Okay. What is a compiler and an interpreter? Why do we require one? Okay. We understood, what a variable is. Okay. What is the syntax for it? What are data types which are present in Python? And we have understood, we've written a small code to print hello world to the world, okay, on the screen, and also, to do addition and subtraction of two numbers. And we also try to give messages. Okay. We can do one more thing, right? This was for addition. Can you try, might be to print the same message for your subtraction? Yeah. I think for subtraction, if I do 6b, I had to do here, let's say a minus b. And let's say that I think the variable which used for difference, you might have used some another variable like result or something, is totally fine. Now I have to tell here the difference of A and B is the whatever the difference is, right? So what change I can do? I can just say the difference, okay? Or instead of saying difference, I want to say the subtraction. Okay, the subtraction of A and B is what? Difference. Yeah, and if I do this, see, it's 4. Okay, if I give something like this, if I do your B by mistake, and I do A, what will happen? Will it give me error? No, it will not give you error. Why? Because you have, though it is wrong, okay, subtraction of 2 and 6 is 4. You're subtracting 6, subtracting 2 from 6, right? So you basically want it to be printed as subtraction of 6 and 2 is 4. But even if you do this, computer will not give you any error, because according to computer, the syntax was correct. Okay, so it's gonna just obey your instructions. It's a very faithful, I would say faithful device. Okay, a very loyal device. Okay, whatever you tell it, it's gonna blindly follow it without questioning, as long as you communicate to it in a clear and an error-free language. Okay, let me switch it back to A and B, and this is done. Okay, I could even use the word difference here. Let me give one more thing. It's not going to give me an error. Why? Because whatever is there inside my single quotes, computer is not going to look at it. It's going to just display it as it is. Okay, only when it looks at a variable name which is outside the single quotes, it's going to go to memory, find what value is there for this label, and it's going to display it on the screen. Understood? Here there are three variables for which we'll do that, which will be A, B, and difference. Okay, so we have given the messages for both the programs we have done so far. I hope you have understood this. Hi guys, the next lecture. So in this lecture, we will be looking at a concept called as input function. Okay, so I think till now we had seen something called as print function. Before I move forward, right, let me tell you guys that print, right, it was a function. And the easiest way to understand what a function is nothing but where you tell the computer that you need to do a particular task without telling him how to do it. For example, if I have to tell you, let's say your name is Ria, and if I have to tell you, Ria, please get me a glass of water, right? So what will you do? You would know how to get a glass of water, right? You might go to your kitchen, or if you have a bottle, of water, you might hand it over to me, correct? That means what I'm telling here is, I'm telling you to do a particular task without actually, telling you how to do it. Getting my point? So suppose if I say, Priya, walk, right? You know how to walk. I'm just telling you to walk. So similar way, when you tell someone, when you tell a computer here specifically, when you tell a computer to perform a particular task without telling him how to do it. Okay, so it's a little different from what we studied so far, right? What was it? We always said, whatever you will tell the computer will do it for you. That means you need to tell the steps to achieve a particular task. Okay, but functions are a little different. These are nothing but these are actions which the computer already knows how to perform. You just have to order it to do that action. For example, print. Okay, what does a print do? Whenever you say print of hi, right? When you say print of hi, what happens is computer knows that I have to print whatever is given in this brackets onto the computer screen, right? But do you tell the computer how to print it on the screen? No, you just tell that you have to print and you tell what data has to be printed on the screen. So this is like a function. Similar to that, we have one more function which is very important in Python, is called as input function. Okay, so today's lecture will be dedicated for this. Now, let's understand what input, where it is required. All right, now let's take an example where the first example, right, where we had seen, we had done print hello world. Yeah, so here this particular program had done the task or done the job of printing some message. This is a message, right? Our message is hello world onto the screen. Now what if you went to your friend and showed, oh, this is my cool Python program which I've written today, hello world, and your friend says, hey, this is all cool, but can we change the message? Instead of saying hello world, she wants to say hi everyone. What she wants to say? Instead of saying hello world, she wants to say hi everyone. This is what she wants to print on the screen, right? What would you do? The one of the easy way you would do is you would go to your Python program, yeah, whichever hello.py, you must have saved this program, right? This particular in a file, say hello.py, suppose, right? Then what will happen? You will go to that file, yeah, you will erase this part and you will just change it to, you will erase this part, right? And you will change it to have what? Hi, let me just erase this, yeah, and you would change this message to have hi everyone. Yeah, you can do this, and then if you run this, then you will have printed on your screen hi everyone. Yeah, that means what? Let's say you take it to a second friend of yours. That second friend wants to print some another message. Might be he wants to print his name. Okay, So that means again you'll have to go to the file and change your message which you have to this, right? Is it a very good way of doing it? No. A computer program is what? It should not always, I don't have to always go on and keep on changing the names of, all my, messages. No. Wouldn't it be nice if we ask the user to enter the message which he wants to display on the screen, and we take that and we then display on the screen? Okay, let's say suppose if you take this program, let's say you've written a program hello.py. Yeah, when your friend runs this program on the screen here, a computer will ask the question, please enter your message, right? The moment it says this, and let's say the message the person enters is hi, right? Then when this program runs, a hi is printed on the screen. So what I'm saying is, what I'm trying to introduce is here a concept where you can take the input from the user. Okay, for that I gave an example of this. Another where can be used. We just did, two more, different programs. One was to find sum of two numbers, and the other one was to find the difference or the subtraction between the two numbers. Remember, sum of two numbers and difference between the two numbers, right? So if it was sum of two numbers, I think we had taken a equal to 2 and b equal to 3. Now what if, do you always want to add these two numbers? No. Might be tomorrow you want to add, let's say 10 and 100. Possible. Or might be 99 and say 87. Correct? So will you always, go to the file and make the change, remove this a, make it 99, remove this, make it 87. No, that is not feasible. What is the best way? Is to always make the program ask the user what is in your mind right now to add. What do you want the value of a to be? What do you want the value of b to be? Right? And then this program, this sum.py might be just take these values from the user and then calculate the addition and give us to us, right? This makes more sense. Yeah. Then when you take this program to your friend and tell her, this is my program which does the addition of two numbers, and you can enter any two numbers you want to add. Then she'll be more impressed, right? Your friend, your mother, father would be more impressed, right? Because now they have the freedom to add any numbers they like, and that's how it should be, right? So for this, to ensure this we can, enable in a program, okay, we need to tell the computer somehow that please take the input, like wherever you write this, right? A equal to 2 and b equal to 3. And then you do what? Then we say, let's say sum equal to a plus b, and then you write your print. Instead of this, you might even give the message which we had seen in the earlier lecture, right? Now, what you have to make change, instead of saying 2 and 3, this should be taken from the user. You have to ask the user. Now, you would say, who's a user? User is anybody who's trying to run your program. It might be you also. Might be you are running your program, and the computer program should always ask you what the value of A you have in mind right now. What is the value of B which you have in mind right? That is what we need to tell the computer. So for this, we have a function which is called as input. This function, the moment you use this function, computer knows that I have to ask my user to take input. Okay, the word input, also the function means is this. So this is how it is used. Okay, the syntax is you can give any message here. Now, for example, if I say input, okay, and I have to somehow give a message note for my user. Let's say tomorrow your brother is running your program which you have written, right? Now, what will he know? What to input? You should give some message. No, please input first number, please input second number, or might be please input your message. Something you have to give, no, so that the user can read and understand. Otherwise, what is the other way? He has to actually open your Python code and see what is it which needs to be input. And not necessarily each of your friend knows Python, right? And it's not a good way. Okay. So that is why here we give a message saying, please enter your, whatever your message, please enter your message, or please enter a number, anything which you put in your double quotes, or you can also put in single quotes, basically a string. Understood? Because anything which is in double quotes or single quotes, it's a string. So you need to put a message here along with input. The moment you use this function, okay, computer is gonna take input from the user. Okay, we'll look at how it works. Let me share my screen. Let's go to our editor. Okay. Yeah. So let's say I want to ask my user, all right, to tell them how to please enter a message. So I'm going to say input. I know I have to use a function input. and I'm going to give a message to them. Please enter your message. Correct? I'm giving this message. Then I'm going to say print. Whatever the message this user has given me, I can print. Alright. So let's run this. See? So I can print here, hi everyone. See? It's printing hi everyone. Now let's say if some another friend of yours wants to print hello world. Can he use the same program? Yes. He can print here hello world. Yeah? Hello world. Did you get this? Because I've asked this message. Now let's say if I do not give this. Let's say I'm not using this. I just remove this part. And if I run this. See? I can still say hi everyone. Okay? Yeah? See the first line, it's actually taking input. And the second line is actually printing this. Okay? Now, because I know that I have to give an input, I was able to write hi everyone. But let's assume you give to your friend who doesn't know what your program is doing, will not do anything. Okay, it's been like a deadlock. The person is waiting for the program to say something to it, and the program is waiting for the input from the user, right? So that is why it's better that you give some message. You can say, give me your message. You can write whatever you want, right? Because this is what? This is a string. Well, let me stop this. Let me run this. Yeah, give me your message. So now I am saying here, hi. That's what I want to print. I can say hi. Yeah. Let's say I want to print 1, 2, 3, 4. Let's say I want to print here 1, 2, 3, 4. Fine. 1, 2, 3, 4. So whatever your message is, you put it, input will read it and it will print on the screen. Did you get this? This is where how you read your input from the user. Alright. Now, let's look at the other part. Other part was we had done a question, okay, addition of two numbers, right? Where we had taken number 1 and number 2 from the user. Correct? Oh, sorry, we had given the numbers, right? We had given 2 here, I think. Here B was equal to 3. Then we did sum equal to, I think sum or result equal to A plus B. And then we said print. We could write here the sum of, and let me say, we said comma, remember? And comma B, comma is, right? And I'm saying this. Alright. And now if I run this, it's going to say sum of 2 and 3 is 5. Now what I want to do, instead of always adding 2 and 3, I want to always add different numbers. Okay. That means I want to ask the user what numbers you want to add. So what function will I use here? I'll use input. Correct? I would say input. What message I would give? Enter first number. First number to add. Right? Can you say that? Yes. Why not? Here what would you say? Here you would say input. Enter second number. Correct? If you want to give a message saying that this program is about addition, you could do that. What can you do? Just say a print message here. Print. This program adds two numbers. Alright, let me give a space there. Yeah. Now let's run this and see. Yeah, it should work, right? Enter number. See, I did not give any colon or space. That's why the cursor is there itself, right? So I said 12. Another I said 45. The sum of 12 and 45 is 1245. There's something wrong, no? Sum of 12 and 45 is 12 and 45, 1245. No, it's not. So what is the problem? Something is wrong. No error also. Okay. Now let me say instead of doing A plus B, let me just change it to minus. Let's see whether we get error here. Okay. If I put a 12 here, I put 45 here. Now what does it say? It says unsupported operand type for minus str and str. Something is going wrong. It's not doing the subtraction which we thought it should do. Correct, no? So let's see why this is happening. Now, if I just change this, let me make it to, plus. Okay. Let me change it to int. We'll see why I'm doing this. And let's say I put here, use the word int. Int stands for integers. Remember I said in data types, a number could be of type integer or a float in Python. Okay. So your int which we have, alright, so int is nothing but integer. So when you say int is also like a function. The moment you say int, the Python knows whatever input is coming, I have to read it as a number, and what number? I have to read it as an integer number. Integer number means it cannot accept decimal points. Correct? Yeah. Similarly, on B also I'm saying I want this to be read as an integer. All right. So B equal to int. I did this and now I'm going to run. Right. Now again my first number is 12. Second number is 45. Yeah. Now I'm getting the correct output. Let me make it a little more readable. Let me put, a space here. Yeah. Now let me run this again. I'm saying a 12. I'm saying 45 and I'm getting 57. Right? The sum of A and B is 57. Did you get this? What happens is that means whenever you're using your input function, by default, right, Python will always assume that whatever input it is, being given by the user is always a string. String means what? In single quotes or double quotes. Okay. So if you want to explicitly, if you want to tell Python, boss, do not take it as a string, but I am trying to give you a number. Specifically which number? An integer number. In that case, you will have to, whatever you have input, right, you have to put this inside your int function. Int function is a function which tells your computer that, boss, whatever I have as string, I need to convert it as an integer. That means I have to read it as an integer. The user is trying to give me a number. All right. That's why now it is working fine. Okay. So now let me give numbers here. Let's say I can put a number, let's say 60 and the other number is 7. Yeah, 67. So now I can use this program to add any two numbers. Okay, got this? All right. Now, let's say instead of doing plus, if I do minus, will it work? Yes, it should. Because I'm adding two numbers. Yeah, only what is this? My print statement. This particular thing I might have to change because it's not making sense if I'm doing subtraction. But yeah, it's going to do my job, right? If I say 34 and if I say 12, it's going to give me the sum of this is 22. So all I need to do is go ahead and change this. The difference of A and B is, let's say instead of sum, I want it as to be difference. Okay. So let's copy, paste here. And I'm going to say the program subtracts two numbers. Okay. Now I'm going to go ahead. My first number, let's say, is 98. Second number is 33. And I'm getting the difference of 98 and 33 is 65, right? So I'm doing subtraction of two numbers also. So what we did, we started off whatever programs we have done so far, right? Before these lectures, we were giving the input in the program itself. But right now we're trying to make the programs more generic. Generic in the sense, we just write the logic in the computer program, but whatever input the user wants can be given at when the program is being ran, right? So for example, now I'm doing addition of two numbers. If I'll always ask the user, tell me the numbers you want to add. Similarly for subtraction, I'll ask user, what are the two numbers you want to subtract, right? You can do this using your input function. Similar to print. What does print do? Print will take whatever you put in that, in those between those circular brackets, round brackets, and it's going to display on the screen. At the same time, what the input function does, input function will always read from the user. Okay, will always read in the format of string, right? If you want to read a number, you have to tell the program specifically that it has to be read as a number. For that, you use a function which is called as int. Okay, now what if I want to read this 12.6 and the other, see, I just got an error there itself. It says invalid literal for int, because what is it? We said numbers are divided into two parts, which is integers and floats, right? Integer short form is int function, which does not consider decimal points, right? So now 12.6 as a decimal point. That means I need to say, boss, please read as a float. Means it should have a, what it should have? It can have a decimal point. Now if I run this and if I give 12.6, it's going to run fine. The second number I give 4.09 suppose, and then I get my answer like this. All right. Yeah. So if you have to read if you want your input to include decimal points, make sure while reading, tell computer specifically that it's going to be a float number. If not, you can say it as an integer. Understood? Yeah. Let's summarize what we did so far. Yeah, let's see. So if you look at this, what we did right now is that we looked at the input function. Input function which tells us which tells a computer to read input from the user. Okay, how does it work? Let's again see. If it is say input, let's say enter message, suppose. Yeah, it reads it from the computer, from the terminal, right, where we run it, and assigns it to the variable A. Okay, the moment I say print of A, whatever value is stored inside this variable will be printed. Correct? Now, if I have to read as an integer, as a number, then I need to use the functions int, or I need to use the function float. When do I use int? Int when I know I need to read integer numbers. When I need to read what? Integer numbers. Or in other hands, when I need to read numbers which do not have a decimal point. I need to use floats when I know the numbers can have a decimal point. With a decimal point. Right? So I can say int. Again, I have to use input, right? Because input is a function which is to read from the user. Read from the user. I'll read this, whatever, let's say, suppose when what happens in this is, let's say you say enter A, okay, and let's say A has been entered as say 12. Now this input function, okay, let me use a different color, okay, this input function is going to read it as 12 because it is reading it as a string. Now the moment you pass this int, okay, when the moment you use this int function, right, int of this 12, it's going to convert this string into number. So this will give you a integer which is a 12 without a single quotes. Got this? Similarly, if I do your input, okay, suppose, and if this number is reading it as, let's say 13.6, this will be read it as a string. Because you are using a float, now this will convert, this float function will convert this string, this is what? A string right now, it's still not a number. Will convert this string into a floating number which is 13.6. All right, understood? Yeah, so I hope it is clear. We saw all the three functions. We did addition of two numbers taking input from the user, subtraction of two numbers taking input from the user, and also try to display a message taking the message from the user. All right, fair enough? Yeah, all right. Hi guys, to the next lecture. So in this lecture, we are going to cover two important things. One is the arithmetic operators in Python, and the second concept is the comments which are used in Python. Okay, fine. Let's start with the first one, which is arithmetic operators in Python. Right? I think most of the people must have guessed from the name, like what exactly this is. All right, so let me change it to white. Yeah. So what are these arithmetic operators? What is arithmetic? Maths operators, right? In maths we have what? Addition, subtraction. What else we have? Division, multiplication, power function. Yeah, and so on. So here also we're gonna look at similar, right? Suppose if you we just looked at these two examples, right? Addition and subtraction, right? Without even doing this, we knew that by suppose in maths we use the same symbols, right? Addition and for subtraction also. So here also we're going to use the same symbol. Change the pen. Yeah. So addition, subtraction, we use the symbol. Then for multiplication, what is the symbol which we use in our maths? We use this symbol, right? A cross. Correct? But in Python, we are going to use this symbol, asterisk. Okay. In your keyboard, you can see, I think it will be above 8, the number 8, right? Above that it will be. So using shift and 8, pressing shift and the 8 key will give you this asterisk symbol. Okay, so plus, minus, multiplication is your asterisk. Then we have some special symbols. Now what else will be remaining? Division. Correct? And there's something which is called as modulo. I don't know how many of you all know about modulo. If you're in school, right, maybe you must have not heard about it. Never mind, we will be discussing it in this particular topic. Remainder operator. Okay, so division is of two types in Python. Okay, one is called like integer division, and the other one is called as the long division. Okay, so what do I mean by this is, let's say, suppose if I do 10, okay, if I do 10 integer division by 5, all right, So what is this? 10 integer division by 5. So let's say if I am doing this, 5 2s are 10, correct? What is the remainder? 0. All right. So if I do integer division, what is this? I'm going to get to this, let's say modulo. If I do like this, 10 mod 5. This, the operator is basically the percent symbol. Okay. So the percent symbol in, which we usually denote to use percentage in maths, but in Python, this percent symbol is called modulo, or the remainder function. It basically tells you the remainder. Like after I divide 10 with 5, what is my remainder? Getting it? Okay. Now even here, if I do 10 normal division with 5, is again going to give me 2. Okay. Now let's see how this is different. Let's take another example. Might be, let's say 8, 9, and if you divide it by 4. Okay. How will you do this? 4 2s are 8. What is the remainder? 1. Yeah. If I have to completely divide this, I might have to take a decimal point and then do this. Correct? Because 1 is what? Less than 4. Agreed? Yeah. So let's do that also. So 2, and if I point here, I would put here, what is it? 4 2s are 8. Correct? Again what I get as my remainder? 2. I can add here 5 4s are 20. Remainder is 0. Right? Now if I have to get this, if I do, what is it? 9 integer division with 4, 9 complete division with 4, and then 9 mod 4. Let's look at what values we will get. 9 integer division with 4. The word integer, okay, that means you need to, this particular operator will give you the answer before the decimal point. Okay. In the earlier case, there was no decimal point. That's why we got entire 2 for complete, and for this both were same. But here we need, when you say this, you will have it before the decimal point. This is what? This will be the entire division, which is 2.25. Complete division including decimal point. This is the remainder. What remainder? Remainder before you took the decimal point. What was the remainder? This was the remainder. Right? This was the remainder. Then we took a decimal point and we took a 0. Let me, if you want, if you're not sure, let me show it again. If I'm doing this, what was it? 4 2s are 8 I did, and I got a remainder 1. Then I went ahead and put a decimal point, right? So this is the remainder I'm talking about. So this will be given by the mod operator. Understood? Yeah. So simple. If whenever you do your normal maths, right, normal division. So in Python, you have 3 different operators associated with division. One is your integer division. What is this? Integer division. Integer division is nothing but the answer you get before the decimal point. Before decimal point, whatever answer you get in your division, that is going to be given by your integer division. This is your complete division, right? So this will be including your decimal point, which is visible 2.25. This is basically the remainder. The modulo function, or also called as the remainder function, this tells you how much is, what is the remainder, right? When it is completely divisible, right? In this case, right? You can see 5 completely divides 10. In that case, what is the remainder? 0. That's why 10 mod 5 was 0. I hope it's understood. Let's take one more example for simplicity. Let's first do division normal. Let's say 2. Let's say 2 here, and might be, we can say 11 here. Okay. So how would you represent this in normal maths? 11 divided by 2. Correct. Now what are we looking at? We are looking at 3 things. We want to see what is the answer. 11 integer division with 2, 11 complete division with 2, and what is it? 11 mod 2. All right, we need these answers. So if I do this, let's say, what is it? 2 5s are 10. See, you do not need to do this division, right? I'm just showing this so that right now you're new to it. Might be some people get a hang of it, and then slowly, so without doing it, you can easily answer these questions. Okay, just showing you the the rough work what we do. Okay, 5 2s are 10. What is the remainder? 1. Correct. Now can I divide 1 further with 2? No, I need to take a decimal point. Correct. That means I have got my answer for this integer division, because integer division is nothing but basically the answer, right, before the decimal point, which is 5. What is mod? Mod is the remainder which I get before I add a decimal point. What is it? 1. So I've got my 2 answers, right? Now I need a complete division answer also. So that's why I'm going to go ahead, put a decimal point here and add a 0 here, right? So what is it? 2 5s are 10. Answer is 0. So I have to do until 0, right? So what is this answer now? 5.5. Yeah. So this is my complete division. Okay, the name itself also makes sense, right? Completely dividing it until I get a 0, right? This is my remainder or my mod operator, remainder or modulo, or you can also say is mod operator. Okay, this is your called as integer division. Okay, basically you get the integer part of it, right? I mean 5.5 is what? A float number when it comes to Python, correct? Integer division is just get the integer part of it. All right, does this make sense? Yeah. So what all operators we have seen so far? We saw the addition, we saw the subtraction, we saw multiplication. This is multiplication, right? Then what did we see? We saw division. So then for division, there are 3 different kind of operators. One is integer operator, integer division, complete division, and then we have the mod or the remainder operator. Remainder, and this is your integer division. This is what? This is complete division. And there are many more, and I think there is one more power function also in arithmetic operators, but that's okay. We just look at these. This addition, because I want to keep this course basic. I really don't want to give a lot of information. Yeah, I don't want to overwhelm you guys. And subtraction, right? So these are your basic arithmetic operators. How many have seen? 1, 2, 3, 4, 5, 6. So 6. Okay. Now what are we gonna do? We are gonna try to solve some questions based on these operators. Let's see in working how does this work. Okay. Now before we move ahead, before we see examples for this, I want to introduce one more concept. At the start I said that this particular lecture would have 2 concepts. One is your arithmetic operators and the others would be the comments in Python. So let's look at the second concept is comments. Comments, anyhow you want to pronounce it. Comments in Python. Right? So before we understand what are comments in Python, what do you understand by the word comment or comment? You must have heard about this word like running commentary, which happens in cricket. When you're watching a cricket match, right? Comments are there. So what is it basically? It's kind of like a summary, yeah, some description about what is going on, right? So let's say, suppose if you're writing an essay, right? Let's say you're writing an essay and you are trying to add comments or trying to add description about whatever topic is given to you, right? You're trying to describe that, right? Or whenever let's say even in an online thing, right? Online when you're chatting, somebody adds a comment to your profile picture and stuff, right? That's what it's like, kind of adding extra information to some to the information at present we have, right? So similar to that, right, in Python also we have a similar use case where what is happening is, let's say now see whatever lines of code you have written, like in the part of this course we have written not more than I think 5 or 6 lines of code, correct? Because that's a basic, this is your entry point into the programming world, right? But let's say tomorrow you go on to do great things and let's say you're going to create a game, maybe you want to create a game in Python. Then do you think only 5 to 6 lines of code would be sufficient to complete the entire game logic? No, obviously not. You would have written thousands of lines of code and hundreds of files and a lot of things, right, depending upon the complexity of your game. Correct? Now when you are dealing with such a massive code base, or when I say code base, nothing fancy word, code base is basically the entire code which is going to make up your game at hand, right? If that is the case, then wouldn't it be nice if we add some small description at the start of every piece of code? For example, let's say I have 1 to 100 lines of code. Okay, some Python code is here, 100 lines of code. Now suppose after, let's say I worked last month on this project, okay, I did not find, might be let's say suppose I worked in January on this project, February I was busy, did not find time to work on the project, and let's say March I have some time and I decide to continue working on the project, yeah, and there are already, let's say I opened a file and there are already 100 lines of code written, right? Now it will be difficult. What would I have to do? I have to actually sit and read what I had written so far, understanding the code, right? And trying to figure out what I had written. Instead of that, wouldn't it be easier? Let's say if I add some comment, I would say here, okay, the below lines, suppose I add a comment, below lines are for moving the character. Suppose I have a character in the game and it's supposed to move. Moving the character let's say from right to left. Okay, another comment I add here, maybe this is, the piece of code will actually makes jump, jumps the character, right? Correct? I can say that, right? So basically, what is it? It's basically plain English, and in plain English, I'm trying to just say that was this particular piece of code is doing this work. This particular piece of code is doing this work. So what happens? It's suddenly now my code is being easy to understand and read, right? Let's say I have worked on, the project might be 2 months back, and if I come back and open my Python file, I'm not going to be overwhelmed. It's easy for me to skim through to see where how much I've finished, and I can pick up. Right? What will happen now for this? Let's say in 100 lines of code, I have only covered these two functionalities. I will just look at this particular, description which I have in line number 1 and line number 2, and then might be on 101, I start writing my another piece of functionality. Might be I wanted to, let's say, dance. Possible, no? I can write this piece of functionality here. Correct? Or maybe, let's say another more relevant example would be, let's say you and your friend are trying to work on a Python project. Possible, right? Both of you have taken up this course, and now you want to take it further and want to develop a Python game, right? So now let's say your friend has worked on this particular code. He has written this code, right? 100 lines of code, and he said, boss, I have done my work, and now you please take it ahead. Now you need to understand somebody else's code, right? In the earlier example, at least you had written the code, still it might make some sense to you. But somebody else has written the code. That means you have to go line by line and understand, like go through all these 100 lines of code and try to make sense of what this person is trying to achieve, right? See, at the end of the day, you will understand the code. There's no doubt in that. But that is more time consuming, right? And we are here to try to save our time. What if the person, your friend, let's say your friend has put in this, description like this, boss, this particular line of code is doing this, second line of code is doing this. It will be easy, for you, right? You will be like, oh, thank you so much. I don't have to actually go through 100 lines of code. Just read these 2 sentences and I know what the code is doing. Correct? Yeah. So this particular description, which I'm talking about, a summary, what I'm using the word description, or I'm saying like a summary. What is more apt? Summary. It's kind of giving summary of whatever, the code is trying to do. That same thing is achieved using comments in Python. Okay. It's like adding description or summary, okay, summary statements in between your code, okay, to make it more readable. To make it more what? To make it more readable. So that especially in the industry, right, not one person is working on the particular part of a project or trying to code something, right? So there are all these big organizations will have huge teams. The teams would be in India, would be in New York, in California, might be in Australia, and so on, right? So thousands of people from different countries are going to work on that particular code. So it's very important that these descriptions or the summary is added in your code so that it becomes very readable for the other person who's going through your code. Understood? And that's where your comments thing comes into picture. So now, how do we say that this is a comment? Okay, that's the first thing we'll have. Yeah, or we can say this is a comment in Python. And second thing, whatever comment I write, do you think computer has to do anything with this? Do you really think computer needs these comments? No, computer does not need. For computer, what computer understands? Computer understands pure Python code, right? And these comments seem to be plain English language, right? It's not meant for the computer. It's meant for another human being who's going to go through your code, right? That means your comments are never gonna be processed by your compiler or interpreter. What am I saying? Comments are meant, okay, as descriptions or summary to make your code more readable. That means it is not needed by your computer, correct? It is meant for another human being who understands or who codes in Python language, right? That means Python compiler or Python interpreter is not going to look at your comment section. It is going to be ignored by your compiler. It goes very simple. Let's say I have like this, a equal to 2, and let's say I add a comment here, taking data. Suppose this is what I wanted to add comment, and then the next line I have b equal to 2. Python is going to come and say, okay, this is a Python code. This is a Python code. It's going to act as if this line never existed. Let's say this is line 1. This is line 2, this is line 3. Of course, this code is not correct because I need to somehow indicate to the Python that this is a comment. So how do I indicate that? By putting a hash. I think everybody's familiar with the hashtag, right? We have this in Instagram, hashtags, right? So yeah, similar to that, we have a, key here, hash. So the moment you put hash, okay, whatever comes after that on that particular line is going to be treated as a comment, right? And this is not going to be read by the Python. So I mean by the computer. So this particular line is going to skip. Python is going to come, it's going to say, okay, this is there, it's going to ignore that line. All right. Let's say now, instead of writing one line, let's say you want to write 2-3 sentences as your comments. To your description is, let's say, not fitting in one line. It's going to be in, let's say, 2 to 3 lines. So there is one more way of doing it. What is one way to do it? You would say comment hashtag here, hashtag here, hashtag here. Suppose you have 3 lines as your comments, right? That's what you're going to do. Hashtag, hashtag, hashtag. Now, instead of doing this, right, this is what is called as a single line comment. What is it called? It is called single line comment. What is it called? It is called single line of comment, right? Now, instead of that, now this is single line. What if I want it as a multiple line? What could you do? We could use this. What is this basically? These are 3 double quotes. 3 double quotes, right? Now, whatever you write here, it's okay. This is called as multi-line comment. What is it? Let me write it properly. It's called multi-line comment. It's called multi-line comment. Excuse me. So now what happens is, instead of having this hashtag, I could write like this, write all my sentences and then end it like this. Now what happened? How many lines have I covered? Line 1, line 2, line 3. So I just need to use this whenever there is a multi-line comment. If there's one single line, I can just start with a hash, write whatever I need to, type whatever I need to have, and that will be ignored. Okay, so comments can be of 2 types. It can be multi-line, it can be single line. For single line, you use a hashtag, and for multi-line, you use this 3 double quotes. Okay, fine, fair enough. I hope you've understood the comments. It's basically just to make your code readable. That's it. All right. Okay, guys. So we did the 2 topics in last lecture, and that was arithmetic operators and the comments in Python, right? So we just did the concept. In this lecture, I'll be trying to solve, some problems around it and see how it really works on your, in the code. Okay, let's do the addition, subtraction, multiplication, division, and all those operators. Okay, so let's say I'm taking 2 numbers here. Instead of saying A, I'll say number 1. Okay, and for now, let's say I'm giving the input. We might then change it to, give the person, the user, to take input from the user. Here I'm saying, let's say it is 49. Number 1 is 49. Number 2 is, let's say, 6. Okay. Now, let's do addition first of these 2 numbers. So I'm going to say sum equal to number 1 plus number 2. Correct? That's my sum. And, for simplicity, I'm also going to, add a comment. How do we do add a comments? We add a hashtag. And I'm going to say addition of 2 numbers, right? That's what the comment I'm going to add. Next is going to be subtraction. So I'm going to say difference. Okay. And here I'm saying number 1 minus number 2. All right. And here I'm saying subtraction of 2 numbers. All right. Next is what? Multiplication. Multiplication of 2 numbers. Yeah. And I'm saying here, let's say multiplication equal to number 1 asterisk number 2. Next is what? Division. So what division I want to do? Let's say I want to do integer division. So I'm saying integer division of 2 numbers. All right. And here I'm saying, let's say I use the word integer division. Okay. Integer div equal to number 1, that symbol, and then number 2. Okay. Make sure you do not give any space, right, when you're having this 2 slashes for, integer division. The next one is what? The complete division. Let's do complete division also. Complete division of 2 numbers. Yeah. And I'm going to do your, let's say, complete div. And this is going to be number 1. Okay. Divide by number 2. Last one which we need to see is your modulo function. So your modulo of 2 numbers. Okay. would be simple. Let's say mod equal to number 1, mod number 2. Alright. And if I do this, it's gonna work fine, right? Completely fine. But let's say I want to print all these values. So let's say, let me start printing from here. You know, I'll have to add here also. Let's say I'm adding your print. Okay. I'm not giving any message, or let's say, let me give the message here, sum equal to, and then I'm adding sum. Okay. Here I'm saying difference. Yeah. And let's be consistent. I can say give a comma and then say difference. So basically we are trying out all the operators we have seen so far. Okay. Again, I'm saying print. Okay. It's going to be what? Multiplication. Now instead of saying multiplication, I mean, you can say give a very big message. That's fine. Right. I'm just trying to write a shorter message here. Next is print. Let me give a enter so that doesn't become messy. So the reason I've left line at line number 15 or 11 or something is just to make it more readable. Okay. There's no any particular requirement for syntax. Let's say I'm saying an integer division. Alright, and I can say your integer div. Okay. Let me copy paste this. Control C, Control V. Let's say Control V. I can make it mod. Yeah, this is complete div. And let me change your modulo. Or instead of modulo, I can say remainder. Right? This is going to be complete division. Right? I have done this. Also, I could say, I could write a multi-line comment also. Let's try that also. Okay. So, I'm going to say here, this multi-line comment is, I can write it here, right? So, I'm going to say, this program demonstrates arithmetic operators. Okay. So, I'm going to give this. Alright. So, basically, I'm going to add the this plus, minus, multiplication, integer division, complete division, and mod. So basically I have 2 lines as my comments. Alright, and I've also added this. Now so we have also added a single line comment. We have added a multi-line comment. Now here see I've given a space, here I have not given a space. That doesn't matter. Just make it uniform. Let me say I'm putting a space everywhere. Okay. I hope you can see this. So this is, yeah, so I'm starting from here and this is how it is ending. Okay, let me run this. See, it's saying sum is 55, difference is 43, 49 minus 6, multiplication is 49 into 6 is 294, integer division, right? 49 divided by 6, you get your on the top 8 before you do and you get a remainder 1. So you can see remainder 1, and complete division would be 8.166, right? So it's showing a lot of, you can adjust the precision, but right now let's not get into details of precision and all. So let's say this is how it gives us. Plain vanilla example. Okay, so we have seen how to add comments. So what is happening because of the comment? See, anywhere this comment is getting added, this comment is getting displayed onto the screen? No, right? This comment is for us, for our developers, right? For the one who's writing the code, for us to understand. So tomorrow, if I show this to code to anybody, he can understand what is happening in the code. When I'm saying addition of 2 numbers, they know this line number 9 and 10 is basically doing the work of addition of the numbers. Okay. Now, suppose if I have to make this more interesting or more interactive, what I can do, instead of taking 49 and 6, I can take the input from the user. Correct? What do you want to do? Want to do int or float? Let's say we'll take for float. That means all the numbers. I can give like this input. I'm going to give a message. I'm going to say enter your first number. Okay? You can say anything you like, but this is what I'm going to do. I'm going to just copy paste this, Control C, put it here, Control V, and I'm going to say enter your second. Okay, now what I have made, I have just made my code interactive. Interactive means it can work for any kind of input, taking the input from the user. Okay, so I'm going to say first number, let's say 100, second number, let's say 10. Right, so what I have, sum is 110, difference is 90. So you see, right, you get 110.0. Correct? The reason that dot 0 has come because it is a float. You have mentioned it as a float. Okay. So if it is a float, we'll make it dot 0. If I change this to int, right? Yeah, you will not see that. Let me run it again. And let me put the same numbers, which is 100 and which is 10. See, you would see without a dot. Only complete division will have a dot, because complete division by default, because see, what is complete division? Its job is to give you including decimal point, right? So by default, it converts that into decimal point and give it to you 10.0. Okay, understood this part? Yeah, so I'm just turning it back to float so that my code can accept all variety of numbers. All right, so let's put it again here. Let's say 112 and let's say 6, and we can have a number here. Okay, so I hope this is clear. Okay, this is one of the example. Yeah, now let's try more examples. Now what I want to do is, I want to do calculate, one of the program which I want to write now is to calculate the area of a square. What I want to do, calculate the area of a square. What is the formula to calculate the area of a square? Does anybody know? I think in maths, I think some of the people might be knowing. Let me, yeah, I hope you can see the screen now. So let's say, what is the program you're trying to do? You're saying WAP means write a program. Okay, write a program to calculate the area of a square. Okay, suppose this is a square. A square has 4 sides, right? Equal sides. Mine looks more like a rectangle, but assume this is a square. Okay, suppose this side is, say, side. Okay, all the sides are going to be equal. Okay, so area of a square, the formula is side into side. What is the formula? Side into side. So what we need to do, write a program means we need to take this side from the user, correct? Yeah, because we need to know the side from the user, and then calculate this area and give the this program should display the area of the square should be. So what is your input? The side. What is your processing? You apply the formula, which is side into side. And what is your output? You display the output onto the screen. Simple, correct? Let's try this out, how this works. Yeah, let's go here. So here I'm going to say what? Take first input. Okay. Now tell me, when are you going to take input or side from the square, right? A square ka size, square side can be 4.2 also, 4.3 also. It can be 4, it can be like this, right? That means it can be both decimal point numbers and without decimal point numbers, right? If that is the case, what should I use? An integer or a float? I think you must have guessed it, right? It should be a float, because you can, in a side of a square can be decimal point numbers also. Correct? So here, let me take that this. I'm going to give meaningful names to my variables. I'm going to say side. I'm going to use float. Okay, float is again a function, right? Then what do we use for taking the input? We use a function input. And I'm going to give a meaningful message. What message I would give here? Enter the side of a square. Correct? Yeah. Now what I'll do next? Sorry. Next I'll do what? I'll calculate the area. I'm going to say area equal to side into side. This got added. Yeah, side into side. And then I have to print. And let me give a nice message. The area of the square is, and I'm going to say simple. Let me run this. And let me say the area of my 4, and this is 16. Now what mistake I did? Not mistake, just make it more readable. Let me run again. Let's say 5. It says 25.0. Why 25.0? Because I've read it as a float. That's why it's adding that dot 0. Correct? This 5 is being read as a float. So when you read a 5 as a float, it will be read as 5.0. So now it happens 5.0 into 5.0. That's a float again. So that's why you get 25.0. Right? Let's test it again. Let's say 4.2. Because we said we can give decimal numbers. Yes, it's working fine. It's been 17.64. All right. That means if you do a float, you can even accept integers and decimal point, right? That is what we learned, correct? Let me go again. See, I gave this 5, which was an integer. It's still accepting because it's a float. If you remember the diagram I had drawn when I was teaching integers and floats, I said floats can accept both decimal and non-decimal point numbers, right? But for accepting decimal point numbers, you need to use a float. Okay, integers will only accept integers, no decimal point numbers. And what I'm trying to say is, at the moment I put an int here, and if I run this, and if I'm trying to do 4.6, it's going to give me an error saying that, see, it's for int. Okay, so the moment I do this float, the moment I do a float here, okay, And if I run this, okay, now if I do 4, it's fine, it's happy. If I do 4.6 also, 4.7 also, it's gonna be happy. Okay, that means it will convert an integer internally to a float by appending dot 0 if it's a float. Okay, so this is one of the examples. Let's do more examples. Let's say, let's come back to notes. Yeah, let's do an example of a very interesting example where we can use the concept of mod and integer division. Okay, so the question would be, let's say you have some chocolates and your job is, okay, these chocolates are given by user to you, all right, and the user has asked you, your program is to evenly distribute those chocolates amongst your friends. Let's say there are, suppose there are 100 chocolates, and you have 10 friends. Assuming you have 10 friends, and let's say you have 100 chocolates. Now you have to divide this 100 chocolates evenly among 10 friends. Evenly means, suppose if friend 1 gets 2 chocolate, then all the remaining 9 friends should also get 2 chocolates. Okay, so if you divide this such that everybody gets equal number of chocolates. Okay, now you can do it easily, right? 100 divide, if I have to divide 100 chocolates among 10 friends, what is it? Each friend gets 2 chocolates, right? Right? Are there any number of chocolates remaining? No, 0 chocolates. That means if I do 100 minus 10 into 2, what is it? How many chocolates? Is 10 into 2 or 10 into 10? 10 into 10, right? That means each friend should get 10 chocolates, correct? That means each friend will get 10 chocolates, and I can divide equally, distribute equally, and there will be 0 number of chocolates remaining, correct? Now, instead of this, let's say I have 49 chocolates. Yeah, chocolates, and I have, let's say, 6 friends. Now I have to equally divide. So how would I do that? Let's say if I give every friend 8 chocolates, am I left with any chocolate? Yes, 1. Because 6 into 8, right? 6 into 8 is 48. How many chocolates I have in total? 49. 1 chocolate is still remaining, which is not given to any of your friend. Each friend gets 8 chocolates. Okay, and 1 chocolate is remaining. Correct? So the question is the same thing. Question is saying that you have to take from user the number of chocolates and the number of friends, and you need to give out 2 things. What is the number of chocolates each friend can have, and are there any remaining number of chocolates, right? In the case of 100 chocolates and 10 friends, your answer would be each friend gets, say, 10 chocolates, and are there any remaining number of chocolates? You would say 0. Okay, but in the second, suppose the user enters this as input, number of chocolates as 49 and number of friends as 6, you would say that each friend would get 8 chocolates, and there would be 1 chocolate left. Why 1 chocolate left? Because I cannot give as one person 9 and other person 8, right? I have to evenly distribute. That was the requirement in my question. Did you understand? The question is, you're going to be taking 2 things from the input, the number of chocolates and the number of friends. All right, and you are supposed to, your job is to give out 2 things. What are the number of chocolates each friend gets if you have to equally distribute the chocolates amongst your friends? And the second part you have to tell the user is, are there any chocolates left after we equally distribute the chocolates amongst friends? Okay, let's do this. Let's try to code this up. So what will change here? Okay, let me give a nice heading here. I am just feeling in a mood to write a comment. So I'm going to say chocolates and friends. Okay, so first thing I'm going to have what? Number of chocolates. So I'm going to say total number of chocolates. Now instead of writing such a big name, you could choose to make it shorter, but I'm just trying to give meaningful names to my variables. Total number of chocolates I have to take from what? User. Now you tell me, total number of chocolates, can it be a floating point number or decimal number? No, right? You cannot have 1.5 chocolate. No, so it will always be an integer. So I'm going to say int input. You're going to say enter total number of chocolates. Okay, that's what I'm going to do. Next is I need to know what is total number of friends. So I'm going to say total number of friends. So again, You cannot have 1.5 person, right? So again, it's going to be an integer. I'm going to say enter total number of friends. Yeah. So I've got my input in these two. Now what I have to do? I have to find out how many chocolates each friend gets. So I'm going to just use the word chocolate here. So each friend gets how many chocolates? Total number of chocolates. Okay. What do you think this would be? And total number of friends. And the other part is remaining chocolate. This would be again something I have to do this, right? What do you think? Which operator can I use this? For division, yes. What division should I use? Should I use integer division or should I use a complete division? What happens? Take the example of, 49 and 6, right? 49 total number of chocolates and 6 as total number of friends, right? If you do a complete division, would you get the answer 8? No, you would get something 8 point something. What do you want? You want 8, right? Because you cannot give half chocolate to someone. That means I need to use your integer division here. Correct? Once you do integer division, what happens to the remainder? You need to know whatever remaining chocolates are there, right? After you distribute. What is it? What you can get by? You can get by mod, because mod operator is nothing but the remainder operator. Agreed? Yeah, what am I saying is, if I do a total division here, okay, that is not gonna work, because let's say if it's 49 and 6, then I'm gonna get something answer as, if a total division 8 point something, but that is not what I want. I want a whole number, right, without decimal number. That is 8, which would be given by integer division. Then along with that, I also need remaining number of chocolates. After I distribute 8 chocolates to, let's say, 6 friends, how many chocolates are left? 49 minus 8 into 6, right? Now, instead of doing 49 minus 8 into 6, I do have an operator called as the mod operator, right? The remainder operator, which will also give me the answer as 1. Total number of chocolates mod total number of friends. Okay, so if I do that, yeah, and then I just have to print this answer. Let's see whether this works. I'm going to say each friend gets, yeah, and I'm going to say chocolate. Okay, this many chocolates. Let's put a S here because a person can get more than one friends. Yeah, and the other one would be, print statement would be to say what are the remaining number of chocolates. The remaining number of chocolates, and this would be, this is there in my this again I'm trying to put a S here. I'm putting a S here. Yeah, let's print this. So here I'm taking the example, let's say 100 chocolates. Okay, number of friends are 10. So you see each friend gets 10 chocolates and the remaining number of chocolates is 0. So each friend gets, let's say this, and I also want to add the word chocolates. I can do that by adding it. Okay, so let's, if I run this again, and if I give 100 here and make it 10 here, so it's going to be each friend gets 10 chocolates and the remaining number of chocolates are 0. Correct? Let's try with another input. What is that? Let's say total number of chocolates are 49 and the number of friends are 6, right? What did we calculate? It should get 8 chocolates each friend and 1 chocolate would be remaining. Let's see whether we get that. Yes, very good. Each friend gets 8 chocolates and the remaining number of chocolates are 1. Okay, this is where you could use this operator mod. All right, I hope you're getting this. If not, let me explain this further. If you have understood this, right, so it's okay. I mean, you are done with this lecture, I would say. But then if not, let's just hang on. Let me try to explain. What I'm trying to say is, see, when you had 49 chocolates, total number of chocolates, and let's say 6 friends, right? You will basically divide each of these, right? 49 chocolates among 6 friends. Now, usually 49, this is 6. What would I do? 6 8s is 48. What is my remainder? 1. The moment I put a decimal point, that means each friend would get 8 point something. That is not possible because the question is asking us that you should give either 1 chocolate completely to a friend or do not give. You cannot give 1.5 chocolate. Okay? That means my answer should be 8. Each friend will get how many chocolates? 8 chocolates. Correct? What was the remainder? 1. This is answer for your whatever is remaining. Yeah, because in division, if you remember, I can say 49 is equal to what? 8 into 6 plus 1, your remainder. Correct? So this I've already got, right? This plus 1 is coming from what? This, the remainder part. To get this remainder, do we have any operator? Yes. In Python, we have this mod operator. So that's why I've used this mod operator. Similar things will happen for, 100 and 10. If there are 100 chocolates divided by 10, what is it? What can I do? 10 ones are 10. Right? Now, what is this? This is 0. This is 0. Yeah. Okay. So what I can do is, you will get a 0 remainder here. Okay. And this will be your 10 chocolates. So 10 into 10 is 100. All right. Yeah. So there's a 0 remainder, and that's why you could just get your, from mod, you get the answer for this, and by this you get the answer for your total chocolates distributed. Is it clear? If the question would have said, you can distribute it, without like half chocolate can also be given, then might be, there won't be any question of remaining, right? Because you could just, what you do, just add a decimal point and say 8 point something. So if I add it here, what is it? If I, this is 49, this is 6, this is 8, right? What is it? 6 8 is 48. Yeah, there is 1. I'm adding here. Can I do something about this? Yes, 6 ones are 6. What is my remainder? 4. Again, I take a carry. Yeah, what can I do? 6 6 are 36. Okay, might be I do this. And then so on, right? You can just go on doing it until you get a 0. Correct? So that is where, I could have used that answer, that particular operator. But right now, I do not need it. Correct? Did you get did you get what I'm trying to say? Okay, I think this would give again 36, and this would give 4, and this might, go recurring, something like that, right? So it's okay. It will be 8.1.6 something, you might have to give, if I have to, if that half of chocolate thing is valid. Understood? I hope this is clear. Okay. This is it for this lecture. Let's meet in the next one. Hi guys, for the next lecture. So in this lecture, we will be basically looking at 3 things. One would be the relational operators. The second would be the variable naming rules, like when we name a variable, right? So there are some rules when you are trying to give a name to a variable. We'll be looking at those rules. And the last part is we'll introduce the conditional statements, which will start with the if statement. Okay, so let's start with relational operators. In the previous lecture, we had looked at the arithmetic operators, which are addition, subtraction, multiplication, division, right? Division, there were 2 types. One was your integer division, another was your complete division, and then there was a modulo or the remainder function. Okay. In relational operations, this is also something which you must have done in maths. Okay. I think this must be familiar. If I say 8 is less than 9, correct? I can also say 8 is less than or equal to 9. This is what you will write in maths, right? 8 is less than or equal to 9. Next would be what? I could write the other way. 9 is greater than 8, or 9 is greater than or equal to 8. Okay? So this similar operators we have in Python. In Python, you can use this less than, greater than symbol. Okay. Only this is written as like this. 8 is less than or equal to 9. Okay, because we do not have any key like this, right, which looks like this if you look in your keyboard, correct? So we just separate it out, less than, equal to. This would be written as 9 is greater than or equal to 8. All the semantics, I mean the meaning of the symbols, remain the same. There is one more thing. Suppose if I have to say 8 is equal to 8. Okay, there can be 8 is not equal to 9. Or I can also say this, 8 is not equal to 9. Okay. This, if you did not understand now, it's okay. We'll be seeing this further when we do, the if condition. But for now, if you have to consider for relational operators, we have this less than, greater than, less than or equal to, greater than or equal to, or the equal operator, right? It's 2 equal to sign. It's like checking whether 8 is equal to 8. 8 is not equal to 9. Either you can have this exclamation and, a equal to sign, or you can have this symbol. Both of them mean the same. So either you can this use or you can use this one. So this is not equal to. This is equal to. Correct? This is greater than or equal to. Okay, so this also will be greater than or equal to. Okay, here I would say that 8 is less than or equal to. Yeah, this is 9 is greater than 8, 8 is. So relational operators are basically the operators where you would require some relation between the two entities, right? Between the two numbers. All right, and this will only work with your numbers. Obviously, right? You cannot say a string is greater than another string. Does not make sense, right? So this will work with numbers. This is your relational operators. Very straightforward. All right. The next we are looking at now is going to be the variable naming rules. Okay. So far, whenever we had to name a variable, the only thing I had told you guys was try to give a name of the variable which makes sense. For example, if you're trying to store the side of a square, you would give variable name as side or side of a square, something like this, right? Instead of giving A, B, X, Y, Z, instead of giving random names, you would give meaningful names so that it's easy. Your code becomes more readable. Correct? So there are some more rules when you have to think about naming a variable. Let's look at that. The first thing is, I'll just first list down all the rules and then we'll see example. The first thing is your variable name, it must begin with an alphabet. Okay. So when you say alphabet, is your English alphabets like A to Z. Okay. Or an underscore symbol. Or an underscore symbol. Underscore is what? This underscore symbol, right? Okay. So you should either begin with an alphabet. Alphabet, I can have something like this. Okay. Or I can have this. Or I can have an underscore. So I can have ABC. I can have this. Or I can have this. So all these are valid. Okay. That means I cannot have a variable name like this. This is invalid. Why? Because the starting of this variable name is what? It's starting with a number. Right? This is not allowed. That's the first rule. Second, no special characters. No special characters such as blank spaces. Okay. If you recall from the example about number of chocolates and number of remaining chocolates, right? If you see, I had written total number of chocolates. How? I had written it something like this. Total. If I show total number, I had written capital. I did not give space, right? Total number of chocolates. Just to distinguish between the words, I had written, capital letters. You could do this, but you cannot choose to give space in between. That's what it's trying to say. No special characters such as blank spaces or comma, right? Or a semicolon are allowed in the name. In which name? In the variable name. Correct? Except for underscore, because underscore is like a special symbol, right? Other than alphabets, only underscore is allowed, except for underscores. Okay, that means I can have ABC. Okay, I can have A underscore BC, right? I can have underscore ABC. All right, I cannot have one. This is not allowed. I cannot have. This is not allowed, right? Because the only or I cannot have A, B, C. This is also not allowed. That means the only special character allowed is a underscore. That's what the rule number second has to say. Correct? Let's look at the third rule. The third rule is keywords cannot be used as variable names. Cannot be used as variable names. Now, what do I mean by this? First thing is we need to understand what is a keyword. Keywords are those words, okay, for which Python understands them. For example, if I say print, this is a word, right? This word is basically a keyword. Why? Because the moment Python reads print in your code, it knows that this is a function. This means that Python, the computer understands that like by using Python language, you're trying to tell me to print something on your screen. Correct? Another keyword which we have seen is input. Right? This is a function name, right? Where basically the moment you use input, the computer knows that it has to read input from the user. Correct? So such words which have some special meaning for Python, right? That those words you cannot use as variable names. That means what it says is you cannot say print equal to 2. This is not allowed. Or you cannot say input equal to maybe, let's say hi. This is not allowed. Okay, but you can use all the other words. So the keywords are those words which have already been used by Python, and it means something to Python, right? Int also means something, right? It's a function we saw. When you have to read a particular input in the form of a number, we use int or float, right? So all these are keywords. That's what it's trying to say. You cannot have keywords as your variable names. Otherwise, Python will get confused. Simple. Okay. The last and the final rule is variables are case sensitive. Or variable names, variables, let me put that as on that way only. What I'm saying is variables are case sensitive. Okay. What does this mean? Do you understand the meaning of case sensitive? Case sensitive means ABC is different from capital ABC. This is a different alphabet. This is a difference. What? A only, small a, capital A, right? So what it's saying is, suppose if you say ABC equal to 2 and you say ABC equal to 3, this is allowed. This is considered as two different variables. When I say two different variable means, what happens? This is a computer memory. Okay. There might be one memory location here which has been labeled as ABC, which has 2. Let's say that location is say 1000. And there's say one more memory location here, okay, which has address 2000, and this is labeled as capital ABC. Okay, both of them actually are ABC only, but what is the difference? One has a smaller a and the other one has a capital A. So what it's saying is variables are case sensitive. That means if you even change the any of the the capital or small letters, right, in your alphabets when you're naming a variable, those are going to become two different variables. Okay, that's what it's saying. Variable names are case sensitive. All right, so let's revise the rules what we have seen so far. So there are in total how many rules? 4 rules, right? One, it is saying it must begin always with an alphabet or an underscore. Correct. Second is no special characters are allowed. Only what is allowed? Underscore. Third one is keywords. Keywords meaning something which Python already understands. Okay, those words, those English words which Python already understands, that cannot be used as variable names. And the last one is variables are case sensitive. Okay, case sensitive meaning the Python can make a distinction between capital letters and smaller letters. Right. Now, based on this, let's look at some. Let us do some problems. Okay. Here I'm going to mention some variable names, sample variable names, and you're gonna try to guess whether they are valid variable names based on the rules we saw or whether they are incorrect. Okay, let's do this small exercise. Let's say first one I have this. Then the last one, let's say okay, all right, and then I have last one is okay. This is what my example is. What is this? This ABC, can I have a variable name ABC? Yes, no problem. Starting with an alphabet, all alphabets, no issue. Can I have this? Yes. Okay, it's just this. Are these two different variables? Yes, because though it's ABC, but this is what the first one is a small caps, the second one is a uppercase. Correct. This one is also a variable because there's an underscore. Correct. Here this is a variable. This fourth one is not a variable. Why? Because you cannot have a number. What does it say? Your variable should have what? It must begin with an alphabet or an underscore. Okay. And what are the characters it can have? It can have only what characters? It can have only underscore as a special character, right? Now, can I have this $C? No. What is the reason? Dollar is not allowed. So this is also not possible. Now, sixth one, my name is. There is no special character, or there is, right? There is a blank. There are two blanks and this is not possible. You cannot have blank spaces. Is this possible? Yes, it's possible. There are no blanks. So it's fine. Okay. 8. Can I have 8? No. Why? Because this is a keyword and you cannot have a keyword. Look at the ninth one. What do you think? There is a keyword, yes, but it is, added with 1, 2, 3. What do you think? Is it a variable name? Is this possible? No. Why? Because you cannot have digits in your variable name, and again your int is also a keyword. Okay, but if you had something like int abc, then this is possible, might be, because it's kind of int abc together, just not pure int, it's int abc together. All right, I hope the variable naming convention is clear. Okay, so this was the second bit of this topic. The first was your relational operators, which were very easy: less than or equal to, greater than or equal to. Then we saw equal to and not equal to, right? After this is done, what we're going to do, right? Now we're going to look at the conditional statements. Conditional statements. Now, in Python, we have conditional statements which are given by if, else, if, else, and if, else. Okay. Now, because conditional statements are present in most of the programming languages, right? If you try to do it in Java also, this is present. That means this is one of that core programming concept. No matter what programming language you use, you are bound to have this conditional statements. If you remember, we had done similar concept called variables, right? Where we store something in memory that would be present in all programming language. Okay. Similar, what we had input function is something which help us to take input from the user, right? Similar thing would be there in other programming languages also. Now this second, the next important concept, which is common in all programming languages, called conditional statements. Okay, what we'll do for this is we'll first understand why do we need conditional statements. Okay, what are the different examples by which you can have this conditional statements written. Okay, and we'll see examples and syntax, right? So let's start. Let me give you a scenario. Let's say you were given two numbers. Okay, simple scenario. Given two numbers. The numbers are 10 and 12. Okay, I give you two numbers, 10 and 12, and you need to tell me which is the greatest one. Between 10 and 12, which is the greatest one? How would you do? Based on whatever Python I have taught you so far, how do you think you would do this? What's the thing you would do? First thing would be you would store this in some variables, right? That's the first thing. You would say, let's say a is equal to 10, b equal to 12, right? This is the first thing. All right. Next, what you would do? You would have to compare, right? Somehow you have to compare that if 12 is greater than 10. How would you do that? You can do using the relational operators, which we just did. You could say b is 12 is greater than 10, then I need to say 12 is the largest, right? If 12 is less than 10, you could say what? 10 is the largest. Okay, I mean, instead of this 12 and this, what I could do is I could write a and b here. Okay, so what I'm saying is if a is greater than b, what am I going to say? A is the larger one. If a is less than b, that means who is larger? B is larger, right? So in a given this, okay, in a given two numbers, assuming that the two numbers do not have the same value, one of the thing is true. Either this is true or this is true. Correct? If both the a and b do not have equal values, that means either one of them is true. Agreed? Yeah. Now, based on whatever we did so far, is there any way we can do it? There's some condition, right? What is the condition? If a is greater than b, then a is larger. Okay? Or if a is less than b, then b is greater, right? So there is a condition. So based on a condition, right, we have to execute something. What is the execution here? We need to print the greatest number. Okay, the question is saying, given the two numbers, print the greatest number. So our execution part is what? Greatest. Okay, so you would take input, then you have to do some processing. Okay, based on this processing, what you have to give me a output. What is the output? The largest number. Right? So what is it? Suppose if a is greater than me, then you would do what? You would print a is greater. All right. If a is less than b, what would you print? You would print b is greater. Right? So this is condition. Either this will execute or this will execute. Correct? There is no chance both will execute. Why? Because I am saying a and b cannot have same values. All right. So if that is the case, that means only one of them is true. Now we need to come up with something. Now for this to, to, you know, what to say, to have conditional based execution of your, you know, program, we have something called conditional statements, and that is where your if statement comes into picture. So what it does is, so now the syntax is, if I say if A is greater than B, what is the value of A? We had seen here, A was 10, okay, and B was 12. All right, we have this. Let's say if A is greater than B, okay, then what we can do is print A. If B is greater, or let's B is greater than A, then I would say print B. Fair enough, that's all. So this will get executed only. So let's say how this gets executed. Now, the way I've written this if, this is the syntax. If the condition, right, this semicolon is part of the syntax, no? Similar to the grammar we have, right? We need to write in a particular way so that the Python compiler or the interpreter can understand, right? So it's saying if condition, okay, semicolon, whatever your statements, whatever you want to execute here, whatever you want to, you can have any number of lines. You can have 1 more, 2, 3 lines, no matter what. Another thing to remember, there is some space given here, white space, right? This is important. You cannot write this execution here. I mean, what I'm trying to say is, I cannot write like this, print A. This is wrong. It will give me indentation error. If you recall, one of the time I had mentioned in Python, what is important is the amount of spacing you give between your different, the way you type, right? Because what is it, why there is space given is, this is to make sure that the computer should understand whatever you're writing, this block, whatever lines you're writing, this will get executed only inside the if condition. That means when this condition is true, okay, when this condition is true, then these lines of code will get executed. Now to tell that these lines are inside, you know, this if condition, we need to give the some space here, okay, and you need to follow that. If there you are giving one space here, make sure every line are giving one space. Be consistent, that is important, otherwise you'll get indentation error. So if condition is true, this will get executed. The condition is not true, it will not get executed, right? That means what is the thing, whatever condition I give you has to evaluate to either true or false. True means what, whatever condition you're giving is correct. False means what, whatever condition you're giving is false. I think might be, you know, when in your school or in your colleges, you must be knowing, right, true false statements, right? They give you, okay, and usually in English, right, they tell you, okay, this is what the line is there, do you think this is true or false, based on might be a story or, you know, some chapter. Similar thing here, right? In coding we have this, if the condition is true, then you execute. If the condition is false, then you do not execute that part of the code. That's why it is called conditional statements or conditional execution. Based on a condition, you execute a part of code. All right, now here where we are trying true and false, we are not telling. So see how it actually works. If A is greater than B, what is the value of A? 10. Is 10 greater than 12? Is 10 greater than 12? No, this is wrong. So what will happen? This value would be false. This condition is not satisfied. That means what? This part will not get executed. This will get executed. It will check what, whether the condition mentioned in the if is true or false. What is it? False. That's why this will not get executed. Okay. What is the next condition we have? Is B greater than A? What is our B? B is 12. Is 12 greater than 10? Yes, it is. Condition is true. So what will happen? Now this condition is true. If this condition is true, I will come inside the if block and execute. What I have to execute here? Print B. What is my value of B? B. So on my screen, I have what? 12 printed. Understood? Okay, how the conditional works. So let's say instead of this, when I have here, I'm saying if A greater than B, I have print A and I'm saying print by. Okay. Then I have if B is greater than A, I'm saying print B. And I'm saying print hello. So what will get printed now on my screen? This will get executed. This will not, this will not. This will get executed. This will. So I'm going to print what? Print B. B value is what? 12. And I'm going to print hello. Okay. Both the lines. So that means what? Why did I show you this? Is because you can have any number of lines inside your if condition. That means what? What will you put inside if? You will put those statements or those part of your code, that logic inside the if statement which you want to be executed when a particular condition is true. What was my condition here? My condition was if that B is greater than A, then I want to print that value of B. Did you understand? Yeah. So what question did we solve here? We had two numbers, A and B. Based on whoever is greater, I need to print what is the greater value. Now, can I do this? I did this using relational operators, because relational operators help us to compare between the two numbers, right? That's the first thing. Second, we used if conditions. Why? Because this helps us to achieve conditional execution of state of your code. Okay, is it clear? What is the syntax for this? Syntax would be, if you need to mention a condition. If this condition is true, then you can execute this part of the code. Understood? Once let's say you write some part of the code which is outside this if condition, you can write on the same line here, say print, suppose, y, or you can say print end. Okay, now this print statement is outside the if condition. Correct? Okay, this signifies your if condition body is your if body has started and your conditions are over. So this is your if body. Okay, this is outside the if block. Okay, usually it's called block, if body block. Okay, it's outside the if block. All right, now let's look into the code. Let's try to code this question. Let's see. Okay, so what we're going to do, we're going to try to find the greater number between two numbers, right? So we can have these two numbers from the user, or you can have just take two numbers, right? Let's make our code generic. Let's take it from the user. Okay, so how would you do that? Let's say I would just want, instead of saying number A on B, you can also say number 1 and number 2. Okay, it's you and up to you. I'll just say A, and I'm going to say int input. Okay, see, I'm making it int. Don't forget this. Okay, I'm saying int input, enter first number. Okay, I'll do the same thing here. I would say B int input, enter second number. Correct? Now, what I need to do, I need to find the largest number. So see, I'm putting a comment here. Finding the largest number. All right. So this comment is just for our understanding. Whose understanding? Whoever reads the code. It's not for the person who's going to execute, or not for the computer. Correct? Find the largest number. I'm going to use if. See, becomes what? Pink. Why? Because it is a keyword. It is something computer understands. Okay. So if A is greater than B. If let's say A is so between two numbers, right? Only one of them would be greater. Correct? If A is greater than B, what I'm going to say? I'm going to say print. See, print the largest number is, what is my largest number? A. Okay. Then I'm going to see, I am going to say from here, if you look at this, okay, I have given, see, a space there, right? So now I'm going to say if. Yeah, if, see, I'm giving there is no space. The line number 4 and line number 6 are at the same line. Correct? So if, so the indentation is correct. So if, now what is the next thing? If either A is greater or B is greater, right? So how do I check if B is greater? If B is greater than A. What I'm going to write here? Print the largest number is B, right? And then I want to write something, no matter whichever is true, I want to say print we are done, or we can say end. Okay, understood? So this is going to basically, this is inside your if block. I can also write a comment here inside. Okay, this is executed if A is greater than B, right? Similarly, I can write a statement here, correct? And it's a comment, right? So I can make it like this, right? Similar thing I would write here. I'm going to say this is executed if B is greater than. So why am I writing this comment? For me to understand, right? I'm just giving a space here just to make it more readable. Okay, now let's run this enter the first number. Let's say I've entered 5. Okay, so it's 54. Second number, let's say 67. So the largest number is 67 and end always gets executed. So which statement did you think got executed? Which if got executed? Did A was what? 54, right? B is 67. Did you think, 5 got executed? The condition was false, right? That's why 7 did not get executed, right? The 11, line number 11, this print statement got executed. Okay, and that's why we got the value. Why it got executed? Because 67, which has value stored in the B variable, right, is greater than A. A is what? 54. Okay, and this line number 12 is outside both of the if, right? So this will always get executed. Understood? I hope this is clear. This is like based on the condition you are telling computer to execute something. What I'm trying to say is, if the condition in line number 5 is true, then execute line number 7. Okay, if the condition at line number 9 is true, then only execute line number 11. Okay, for line number 13 will always get executed A and B, while line 1 and 2 will always get executed. Is it clear? Yeah. Now let us just make a small change to it. What we want to do is, instead of having 54 and 67, let's say we can also have same numbers. Let's say the user can enter, let's say 54 and 54. Let us look at that. Suppose if I run this, I'm saying user is entering 54. Second also it's 54. What do you think the output would be? Just think. Look at this code. Assume A. What is the value of A? I have entered 54. What is the value of B? I have entered 54. Do you think on line number 5, which is saying if A is greater than B, which is what? Is 54 greater than B? 54 greater than itself? No. So on line number 5, this condition would be evaluated to false. Correct? Similar, line number 9 is again, what is the another value of B? Again it's 54. Is 54 greater than 54? No. So will line number 11 get executed? No. So what should be the output of this? The output of this should be only end. Did you understand this? What is it? A is strictly greater than B and B is strictly greater than A. If I have to make sure that only one of them, like it can be equal to also, what I need to do? I need to make sure I add here equal to symbol. Now, if I do A is equal to B, what will happen now? What will get printed? This will get printed. Okay, don't believe me? Let me run this. I'm going to again put this value 54. Again 54. What is happening? See, the largest number is 54. Now, why did it get printed only once? Because line number 5, if you see this condition I added, A is greater than or equal to B. And this became true, so this got printed. Here I have not changed anything. Here if also I put equal to, now what will happen? The largest number is 54 will get printed twice. Why? Because even this is true and even this is true. Right? So let me run this. If I put 54 here and another put a 54 here, see, it's printing twice. Why? Because even line number 9, the condition line number 9 is also become true. And I don't want this, right? I just want to be told only once that, one of them is greater. So I just did that. Okay, now if I run this again and let's say type some other output, say if I say 43 and if I make it 43, okay, the largest number is 43. All right, instead of this, let's say you do not like to put it here, you want to put it here, it's fine, no issues. Just make sure do not give any space between greater than and equal to, it's one operator. And if I run this and again, let's say give 78 and a 78 here, it's going to work. The largest number is 7. Is it understood? Yeah. So now you see, right, the reason when you're giving this comments, right, it's making your code easier, right? Now we are written a little slightly bigger code than we've written before, correct? So it's become, you can now read it. Okay, what this particular, now we know, now just by looking at this, we know this is executed when B is greater than A, correct? All right, just try it out on your own. I hope you'll understand. It's just based on some condition. If the condition is true, a particular lines of code is getting executed. Just want to show one more thing. Just, to show that we can add one more statement here, I could say print the sum is, okay, and I'm doing, let's say A plus B. So what I'm saying is, if A is greater, I'm also printing the sum of the two numbers. Okay, let's look at it. Let's make A greater. Let's say I'm 70. Next one is say 10. Okay, now what I'm going to have, see, the largest number is 70 and the sum is 80. Why? Because here I have one more condition. The sum is A plus B. Alright, now if I remove it outside of the if block, okay, how do I remove it? Just by making the line number 8 and line number 5 vertically on the same line, correct? It is outside this, then what will happen? This line will always get executed. Okay, let's see this. Suppose if I make, let's say if I make A as less, right? Let's say I made this 80 and let's make this 90. Now what will happen? See, you'll always get this sum, right? Because this sum is outside, no matter, see, at now at this 80 and 90, this, whatever, is A greater than B here? A is what? 80, B is what? 90. Is A greater than B here? No. But still this line got executed. Why? Because it is outside that if condition. Did you understand? It's outside the if condition. If I have to make it inside, what will I do? I'll just try to give a space here. The moment I do this, and if I give the same output, what will happen? Now it will not get printed. Because the sum is getting printed now only when when A is greater than B. Okay? Did you understand this? All right. Fine. Let's meet in the next lecture and we'll continue the conditional statements. Hi guys. So this is the second lecture on the conditional statements. All right. So let's start. Till now what we had done was we did one example on if condition, like where we have given two numbers from the user. Okay, number 1, number 2. And let's say you had A equal to 10 and suppose B equal to 12. And we had to tell what is the larger one, correct? Which is the larger between A and B. So we said B, correct? Then we also spoke about some relational operators, right? And we said, let's say A equal to 10 is there, B equal to 10 is there, which is the larger operator, the larger number. And we also said it is 10 using this greater than or equal to, correct? We said if A is greater than or equal to B, we could print that. Here you could say you would print that A is bigger, right? The second if condition we had used, if B is greater than A, then we said we could print this. The reason I'm not using an equal to sign here, the reason being because we do not wanted to print the larger number more than once, right? Yeah. So that was a quick summary of the if condition. Now tell me, suppose, okay, see, between the given two numbers, only one of the number would be bigger, right? So in this case, suppose even if the numbers are equal, you would just want to print something one time, correct? So there is one more way. Instead of writing two if conditions, okay, instead of two if conditions, we have something called as if else. Okay, that's where we're going to look at. So what this is, see, what is the condition, what is the syntax for if? Syntax for if is that we say if there is some condition, right? And then we have some block of code which you have to execute. All right. Now, when is this block of code executed? When this condition is true, right? If the condition is not true, okay, the condition is not true, what happens? This block of code is not executed, right? Now, if you let's look at the example which we did, right? Finding the largest number between two numbers. Where we had, what was the condition? We said if A is greater than B, so then what we do? You print something. And then we said if B is greater than A, then you say you print the largest number, correct? Now, tell me, when this condition is true, right? Do you think this condition would always be false? Correct? And when this condition is false, then this condition would be true always. Correct? No, because between two numbers A and B, either only one of the number would be the larger number, right? That means out of this, only one of the if block will be executed. Why? Because only one statement would always be true. Correct? So instead of having this two if condition, okay, what if we had some way of telling the computer, boss, for this particular situation, okay, there can be only two things are possible. Either this condition is true, you do something. When this condition is false, you do something, right? Which we had. If A is greater than B, what do? You say print A is greater. If A is not greater than B, then you print B is greater. Correct? There's like, when you flip a coin, either you get a heads or a tail. Similar to that, if you have situations like this where a particular condition, if it's true, you know what has to be done. If it is false, you know what has to be done, right? And there are only two possible conditions possible, all right, either true or false. Then in such situations, instead of writing two if, right, we can introduce what is called as if else. So this exact what we have written, how this will be transferred as, we would write in if else, we would say if A is greater than B. If A is greater than B, you would say print what was it? We said the larger number, right? So you could write a statement. Right now for shortcut, I'm just mentioning A in the bracket, but you can also give a nice message saying the larger number between A and B is A. All right. Instead of checking for this, instead of writing one more if, right? What we would do, we'll say else. Else we would say print B. So what this does, let's see. Let's assume we have A is equal to, let's say 10, B equal to 9. Okay. Now what happens? A greater than B is, 10 greater than 9. Yes. That's why this condition is true. If this condition is true, let me even write down, line numbers here just for explanation. Right. So we check this. We say the condition is true. If this condition is true, that means you will come inside the if block. Inside the if block, what you have? You will have the print statement. That means on your computer screen, what will be printed? 10. Right? Now, else this third and fourth will not be executed. Computer will not execute it. Why? Because here we are telling, so in whenever you have if else, it's like telling the computer if there is, just execute one of it. So this part is executed if the if condition is true, and this part is executed if the if condition is false. So that's why I said, right, it's like flipping a coin. If you have a situation where there are only two possibilities, right, then you can use this if else thing. Okay. Now, whatever we have here online, let's say we say print end. This will always get executed and this will have a end. Okay, understood? Now let's change the inputs. Instead of having this, let's say, let me change this. Now we are saying, let's make A a smaller number and this as a bigger number. Okay, now what is the bigger number between A and B? 12, right? Now what happens is, let me even erase this part. Yeah, let's start. So now, is A greater than B? What is your A? A is 8. Is 8 greater than 12? No. So what is this? This condition is false. If this condition is false, that means you cannot enter the if block. Correct? Yeah. Because this is false, the else part will be, the computer will go to the else part. This will go and it will execute this part. What is it? The else part says print B. What is print B? The value of B is what? 12. Right? And this will always get executed, which is end. Now, if you see, what have we, so this is where the true part gets executed. Why? Because this was false, so this true part got executed. Okay. Now, if you see, when you come to the else part, there is no condition. Right? So as opposed to what we had written earlier, where we had two if conditions, right? So we had to check, computer had to check two conditions, right? That means computer has to spend, let's say 1 millisecond or something to check check the condition 2 times, which is not necessary. Why is not necessary? In our case, when you have to find larger between the two numbers, we know that between two numbers is only one of the number is, larger. If we know that A is larger than B, I don't have to check whether B is larger than A. Okay, because it is not possible. If A is larger means I definitely know B is the smaller one. Correct? That means I don't necessarily have to check these two conditions. I don't have to check the condition twice, right? So using if else, what have I done? I have, helped the computer to reach the same outcome in less number of steps. Okay, by doing less number of comparisons. So if you see, this is a comparison, right? How many comparisons we have here? The number of comparisons we have here is 1. Here we had 2 comparisons, right? Correct? Now, if I have to, let's say, change this particular code, okay, to, let's say my input can also be like this, 10 and 10. That means what? Again, we wanted to only print one of this. Either you print an A or B, right? We don't want to print it twice. So only thing you could do is, in this existing code, will take care of it. How it will take care of it? See, it will say A greater than B. Is 10 greater than 10? No, false, right? That means this part will not get executed, but this part will get executed, the else part, and it is going to print B, right? That means by using if else, I have written a very efficient code and also done less number of comparisons. All right. Now, it's not always possible that you can convert two if conditions might be in else, not always possible, but yeah, there are situations where that if the condition is true, you have to do this, and if the condition is false, you do this, right? If that is the scenario which we had here, right? So you do not have to check two conditions. You can just write a if else. Okay. Look at the syntax. Similar, only in the else part, you do not have a condition. Why do not have a condition? Else will take the condition, exactly the opposite of whatever you have in your if part. What is an if part? The condition is A is greater than B. So the else part will be executed when B is greater than A. Alright, let's see how it actually works on the interpreter, right? Let me just, yeah. So what was it? To find the larger number, right? Find the greatest number between two numbers, correct? So let's first take the number. Let's say A equal to, I'm taking int, you can take float also. Int input, I'm saying enter first number. Okay. Then I'm saying B equal to int input, enter second number. Then what am I supposed to do? Find the larger one. I'm saying if A is greater than B, okay, I'm saying print the largest or the greatest number is, or the greater number is A. Okay, I'm doing an else part. See, my else is exactly below my if part. Okay, so else I'm saying print the greater number is B. Right, so, and let me have one more statement here just to say print outside the if-else block. Okay, let's run this. Say I give 10 first, then say 12. The greater number is 12. So this part always gets executed, right? Let me give the other way around. Let me make this as the greater number and this as the smaller number. We got it. Let's try with one more input, which is it. Let's give same number. Let's give 8 and 8. And you see the greater number is 8. Only once it got executed. Why? Because the else part got executed. All right. Did you get this? Okay. So this is how we did using if-else. Okay. Now let's get back to our okay. Now after, so what all we've done so far in conditional, we saw the if part, we saw if else part, right? Now there's one more which is very interesting, which is called as if, else if and else part. Okay, if, else if and else part. Let's look at that. Now let's say my question is, even before going there, right, we can do one more question on if else. All right, so the question may be, I'm saying the question is, suppose take a color code from the user. You're supposed to take what input, a color code from the user. Okay, if the number entered is 2, you say the color is red. Okay, that's all. So in your color code, you just know one number which is red. Okay. In other cases, you do not know any color code. That means if the user enters any other number, you could just say unknown. Correct? That means what? So how you can do this? See, look at, understand the question. The question is saying that you know, you just know one color. Okay, one color code you know. Like for red, the color code is, the code number is 2. Okay. For any other colors, you know, we do like for green, yellow and all, we do not know the corresponding color code, corresponding the code number. Correct? That means if the user enters 2, you can say red. But if the user enters any other number, you could say unknown. You can say unknown code. Got it? This is your question. This is your program. Write a program for this. How to do this? Whatever we have done, we've done if and we have done if else. What could you do it? You can do using if. Yes, you could. What you could do? You could say if my whatever code is there, right? If my code is equal to 2. Remember this operator equal to from relational operators. Yeah. When we had to check two numbers are equal, we could use equal to operator. Okay. So that is the operator. So if code is equal to 2, we just have to say print red in double quotes. Correct? And for any other numbers, you could say, you know, just print unknown. How to do that? We could say if code is not equal to 2. Remember the symbol not equal to. We could say print unknown. Right? We could do this. Print unknown. Yeah, you could use this or you could use this, right? This or this. Anyone is okay. Okay, both the operators mean the same thing. So this means equal to, this means not equal. So this will work, correct? Now, do you think instead of now try writing this code using if-else? Can you do using if-else? Yes, because there are only two outcomes, right? What is the outcome? One outcome is this particular program will just generate two outcomes. What is it? Either red or unknown. Okay, so if I check if code is equal to red, if this condition is true, that means I know this will always be red. Okay, do I need to check this condition? No. If let's say this condition is false, then obviously it has to print what? Always unknown. Right? That means see that I can have like this. It's like a binary. If this is true, I know what to do. But for all the other cases, when this condition does not get satisfied, I always need to print unknown. Right? If that is the case, I can do either using two ifs or either I can do using if else. Okay, which is a more easier one to do. Because why? Because the number of conditions are less. I'm checking here only one condition, plus the amount of code you have to write is also less, right? You have to write this entire line here, right? In this, but here you just write one else and you're done. Understood? Okay. Let's just simply code this up and see how this will work. Yeah. So instead of this, now I will have to take a color code. Okay. So I'm saying code. I'm saying enter color code. Okay, then I'm going to write, let's first do it using two ifs, right? I'm going to say if code is equal to 2. I now have to print red. If on the line. If let me just make sure this indentation is very important. Okay, so it's here. So if code is not equal to 2, okay, so for all the other cases, I have to print unknown. Yeah, that's it. So let me run this. Okay, see, it's saying invalid syntax. Why? Because some of the interpreters or some of the compilers do not understand this as not equal to. There you could just use this. So that's why there are two operators depending upon the kind of compiler. So the one which I'm using online does not recognize it. That's why it gave me an error. Okay. So let's say 2. It's saying red. Now let me give any other number. Yeah. Saying unknown. Okay. Same thing I want if I using if else. What I have to do? Just I have to remove this and just say else. That's all. Now if I give say 8, it's going to say unknown. So only when I give 2, it's going to give me red. Understood? So same question I could do using 2if or you could do using if else. Okay, fine. Let's come back. And let's do the last bit for the conditional statements, and that is the if else part. If else part. Okay. So now let's say instead of earlier we had only one code, right? 2, which is red. Now we know the codes for few more colors. So we know right now 2 is red. Okay. We know 3 is blue. And we know 4 is yellow. Okay. And for all the others, we need to say unknowns. How would you code this? One easy would be, you could say, right, how many if conditions? 1, 2, 3, 4. Correct? No, 4 if conditions. You would say if, whatever your color code is, suppose if it's equal to 2, you would say red. If color code is equal to 3, you would say blue. If it is equal to 4, you would say yellow. And if it is for unknown, what would you do? For unknown, you would say if the color code is, we do not know, right? We do not know how to do for unknown. Correct? So we do not know. We would say if the color code is what? If it is greater than or equal to 5, right? We do not know how to do it for unknown. Until now, we do not know, right? Using this if condition. You all cannot even use else part. We don't know how to do for that also, right? So now let's do one thing. Okay. What we can do is, see, when you're given a color code, Okay, if you wrote, say, how many, forget unknown for now, we'll take it later up. Okay. Suppose you had this, you would write how many if conditions? 1, 2, 3. 3 if conditions. Correct? That we had 3 if conditions. Now, in this if conditions, right, whatever you would write, C equal to 2, C equal to 3, and C equal to 4. Okay, I've removed the unknown part. Let's not make it difficult. Simpler one, this is the right. Now, out of this, okay, how many at a time, how many number of, if conditions would be true in a given time? What do you think? There'll be some number given, right, to color code. What is possible? Either only one of them is, true, or none of them are true. Correct? Let's say if color code is entered as 8, that means none of the if conditions are true. Okay. But if the color code is entered, let's say, 2, then what is it? Which is true? This is true. All these are what? False. Correct? That means, now you tell me, is it even necessary to go, should it be even necessary to go and check this? No, it is not necessary, right? Because color code, once you have found one of the if condition to be true, right, then there should not be even a need to check all these conditions, if conditions. Yeah, ideally you will never enter the inside the if block, that is given. But what is I'm trying to say is, why even waste computer's time by even checking the condition? Not needed only, no. Because we know a color code can have only one integer value, correct? And at a time only one of the condition is going to be true. So let's say if I found let's say I found here, I don't have to check the remaining 2 if conditions. Okay, simpler. Let's say if I make now C equal to 3, then what will happen? I'll check this. I did not find, this is not true, right? This condition is not true. I will go and check this. I found this is to be true. Do I need to now check the third one? No, not required. Correct? But let's say instead of 3, my answer is, the number entered is 4. In that case, what I'll do? I will check this condition is false. I'll check this condition is false. Then I have to check it because I have not found till now. And then I will check this condition. I will, whatever code is written here will be executed. Okay. That means what? There should be some way, of telling the computer that if in the given these 3 conditions, the moment you find any one of the condition to be true, you do not have to check the remaining 2. Correct? That is what we're trying to do. Do you understand? Because why? This color code can always take only one of the value. If it is 2, I do not have to check for other 2 if conditions, because they're always going to be false. Okay, understood? So this way of telling the computer that from a given list of conditions, just if one of them is true, you do not have to check any other condition. That can be done using if-else. Okay, what I'm saying? If-else. Now that how can I do? I'm going to say if my color code is equal to 2, you would say what? Print red. I'm going to say, instead of writing another this, I'm going to say else if. What is it called? This is a short form for else if. What is it? Else if. So else if C is equal to 3, I'm going to do what? Let me say I'm printing red. Here I'm going to print, what is my color code? Blue. Right? Next condition is else if C equal to 4. I'm going to say print yellow. Yeah. So now, because now it is else if, computer knows out of these 3 conditions. Okay. One thing to remember, you cannot have something starting with else if. No, you need to have an if at the start. Okay, like this. So if, else if, else if. Understood? Okay. So now when the moment you write a block like this, computer knows from these, if conditions, if one of them is true, I do not have to check the other one. So let's say, suppose I have color code is equal to, let's say 3 is enter. Now what happens? Computer comes and checks this. Is 3 equal to 2? No, false. Now you'll come and check this. Is this true? Yes. It's going to print what on your screen? It's going to print blue. But it will not check this. Why it will not check this? Because we said it is using if-else if. And if-else if, the one of the condition is, if one of the condition is true, you don't have to check the remaining ones. So it will come out, it will not check this part, and it will directly come and say print end. Understood? Okay. Now, instead of 3, let's say the value is 2. Now what will happen? Again, this will be checked. We got it true. That means this will never be visited and you will have the value as red. Are you understanding? Only one of them would be true by using this if-else if conditional statement. Okay, now let's get back to unknown. Now we said if there is no, out of this color code, right, any other number is entered by the user, we do not know the color code for it. We know the color codes for only 3 colors, right? In that cases, we need to print unknown number. Now, how do you do that? If you remember for the else part, right? Remember the else part in if else. What was it? We said if whatever condition is in if right, if that is false, then you execute the else part. Right? What is else? What was the else part in if else? If condition was false, then else part was getting executed. Here what we are saying, either one of this has to be true. Okay. Now we are saying if none of this is true, okay, none of this is true, then I wanted to, let's say, introduce an else part, which said print unknown. It is similar to your if else, but the only difference is here instead of having one if, you would have multiple else if. Okay. Okay, so he's saying if none of these part is true, then you can execute the else part. So what I'm saying is, let's say when color code equal to 2, what will happen? It's going to print red. When color code equal to 3, it's going to print what? Blue. But when color code is equal to, let's say 8, then what happens is, this is not true, this condition is false, this condition is also false. Then the else part gets activated because none of these conditions were true, and that's why for this you would get unknown. Okay, because these conditions have similar weightage, similar value. We want one of them to be at least true. Not all can be true at the same time. One of them is true, we are fine. But if one of them is not true, and if the else part exists, written like this, then you can go and execute this part. So similar to if block, see, if you remember, you can only have a if without a else, right? We just did, we had only one if. It's fine. You can also have a if with else, but you cannot have an else alone. Similarly, you can have if and else if, any number of else if you want, 1, 2, 3, any number of else, okay, without a else. Or you can have else if and then you can have else. Okay, so in both the cases, right, your else cannot exist alone. It needs to have a if or a else if with it. Understood? So we have how many different parts? 1, 2, 3 and 4 different ways in which you can express your conditional statements in Python. Yeah, one if is right. One if is similar to having one condition. Okay, if else is what? It's like having binary. If you whatever you have written in your if condition, if that is not true, then you want to execute it for the exact negation of the statement, then you can do else. That means what I'm trying to say, if I'm saying, let's say if I love Python, and I'm gonna, let's say, go and code Python. That is my if block. Okay, but my else block is if it is not if I do not love Python, then I don't have to again check the condition that I do not love Python. I know if is false, if the condition is in if is false, I have to execute the else part. Okay, but let's say instead of one condition, I have, let's say a choice. It's like making a choice. No, here this color code can have only one value. That is, C can take only one value. Correct? Any one of them can be true, right? So when I have different choices like this, I can use if else if, yeah. And if one of them is true, I'm good to go. I don't have to check for other conditions. But let's say I suppose none of the options, which are given in my else if are true, and I want to give a default option. Default option as in, let's say, if a user enters a color code, okay, which we do not have in our chart, right? This chart, okay. Then what happens is, instead of not giving any output to the user, we thought it would be nice to tell unknown. We do not know the color code. How could we do that? This else condition would always be true when nothing of this is true. When C does not have a value 2, 3, 4, okay, C has a value other than this 2 and 3 and 4, else will always be activated. Understood? Yeah. Okay, let's try to code this up. So again, we have color code. I can leave it as it is. Let me have this else part also. I need to do is add else if. Okay, so I'm going to say else if. So ELIF, it is basically the short form for else if. Okay, but in the syntax is else if. Okay, I mean, this is how you write it. So I would say when code equal to 3, what we had in a color code, we had, I think it was blue. Yeah, it was blue. So I'm going to say blue. Yeah, then I'm saying else if code equal to 4. I'm printing it, right? Now let me run this. Let me put a color code 5. See, unknown. Why? 2, 3, 4 is not there, right? Let me make it color code 4, yellow. Color code 3, blue. Color code 2, red. Yeah. If I remove this else part, let me just remove this. What will happen? The moment I put a color code 5, it's not going to give me any output. Why? Because there's nothing there, no, to print. Okay, but if I print something like 4, it will print me a value yellow, right? So it doesn't. So if I want to give a default case, I can say else, and now it will give me a value for 5. Understood? This is how your if-else-if part works. It's also similar to switch statements. Understood? Where one particular variable can hold multiple values and only one of that value is possible at a time, right? Because it's an integer, it can either be 2, 3, some number, no? Okay, so where you have a choice like this, where a variable can have a variety of, values, and based on each value, you have a condition, you have something to do. Like, for example, if it is 2, you need to print red, right? Then you can use a if-else-if part. And for a default case, then you can use a else part. Understood? Yeah. Now, if I have to just, print something outside, I'm going to say print enter. Yeah. Then if I run this, let me say 7, and it's going to say unknown. Make sure if you look at this if else if, right, look at the indentation. Everything is in one straight line, right? I mean, vertically, correct? You make sure to, maintain this, indentation when you're writing the code. Otherwise, you'll get error in Python. Understood? Nothing, you don't have to do anything. If you have kept one space, okay, like suppose if you look at this, right, this is how many spaces? This is 2 spaces, correct? So just keep 2 spaces, that's all. Just be, uniform, okay? And always it has to be inside to show that it is a part of the else block or part of the else if block or if block. Yeah, so here we have finished our if, all different types of if else if blocks. Okay, how many we saw in total? We saw in total 4, right? We saw one was if, other one was if else if, and if else if else part, right? Yeah. Now let's do one last thing, a little complicated. Okay, until this you've understood is more than enough. If you're just a beginner in coding, right? And if you understand, if you want to understand the coding conditional statements in programming, right? So because this concept of conditional statements remains same across all programming languages, all right? So far, if you have understood, is very good. The next which I'm going to cover is a little more complicated. Okay, stay tuned with me, see if you can understand. What it is called is basically, what I'm going to do is I'm going to do a nested if else part. The word nested, what does the word nested means? Something inside something, right? So nested if else means, so inside a if you usually have a condition, correct? And then you have some statements, right, which you execute. These statements can be in another if else, or it can be just if. This is possible. This is what your nested if else is saying. Understood? Yeah, means this body, right, whenever I say there's some executional statements, right, these executional statements can be another if block itself, is what your nested part says. Nested conditional statements say. Very easy. Okay, so let's look at an example where we might need something like this. Till now we had seen, we found the larger number between 2 numbers, correct? A and B. Very easy. Either you write 2 conditions or you use an if else. Simple. That's what we had seen. Yeah. Here, could you use an if else if? No, you cannot use, right? You cannot have 2 choices. That is not possible. All right. So now what would you do? Suppose instead of making 2 numbers, let's say I change the question to have 3 numbers. So now you have 3 numbers A, B, C, and you are supposed to tell which one is the largest. Which one has the largest value? How would you do it? Think, give it like a minute. Suppose instead of 2 numbers, so for 2 numbers, what we did for A and B, we checked if A greater than B. If A is greater than B, we said A is greater, otherwise we said B is greater. Correct? Now for 3 numbers, how will you extend this thinking, extend this logic? What would you do? We would do, let's start small. We would say, we'll take 2 numbers first. We'll find the larger of this. Do we know how to find larger between A and between 2 numbers? Yes, we do. Let's say the larger number is A. Then again we have two numbers, this and this. We will try to find the larger between this, which is 1. Suppose let's say C is the larger. Have we gotten the largest number between three numbers? Yes. What we did, we took two numbers at a time, tried to find the largest in that, and we kept on doing it until we got a number, the largest value. Correct? Now, this would be like one condition, this would be like one condition. Agreed? Yeah? So how would we do? Let's write the code for it. What would you say? If A is greater than B. Right? Let's take the else part also. Either A is greater than B, or what would be? Yeah, B is greater than C, right? This else part means what? If I put a comment here, B is greater. If it came to else part. If A is greater than B, then we are following this, right? What we did here. If A is greater than B, let's say A is greater, then what you have to do? You have to check this A with C, correct? So we said here inside this, if A is greater than C, then what do we know? Who's the larger number? We said we stored in a variable, the larger number is A. Otherwise, let's say between A and C, if let's say C is larger, then who is the largest number? C is the larger number. Then we would say larger is equal to C. Do you understand what I did? What I did was, let's take small numbers, let's say 15, 10, okay? And let's say 5 first. This is my A, B, C. What I'm saying is A is greater than B. I check this first. What did I get my greater number? 15. Then I need to make sure, if I have to find the largest in 15, 10 and 5, I have to compare this 15 with 5. Agreed? Yeah. So I will say what? 15, A is greater than C. Did I check that using it? Yes, I did. Now I found out who's my larger number, A. Whoever is larger will be the largest in all the numbers, correct? So I said large is a variable where I store the largest of all the numbers, suppose. Okay? Then I'm going to say what? Large is equal to A, right? What if I change this to 50? What will happen? Who's the larger number between 15 and 50? 50. That means my C is larger number, so I can just have if else. Understood? So this is case when I have A is greater than B. Can I have the opposite? Yes. Can I just change these numbers to make it as B is the larger number? Okay. So how would I do that? I'll just make this here 15. Suppose just change the order and this is 10. Now instead of A greater than B, what is it? B is greater than C. If B is greater than C, again what I have to do? I have to compare this B with whom? C. Correct? So I will say, is B greater than C? If that is the case, what is my larger number? B. Similar to what we had done above. Else what will happen? What is my larger number? C. Right? Suppose if this is, which one is the larger? Suppose C, then I'll say LC. Otherwise, suppose if it was the other way around, it can be B. Understood? So have I covered all the examples? Yes. And what is this? Is a nested condition, right? You are having a if else, or you're having a if block inside a if. You have an outer if else, right? This is your outer if else parent. Inside this if, you have what conditions? If else. Again inside this else, you have if else. Okay, this is an example where, in practical example, where you would need to, have a if condition inside another if condition. Got it? Yeah? Understood? Let's try to code this up and see how it works. If it is a little confusing, just try to rewatch. I hope you will understand. All you need to remember is, see, if condition is used, in the coding when we try to, do some execution based on a condition. Okay, where we have to decide what I need to tell the computer next. Okay, based on a condition. When you have something like this, you try to use a if else block, or if else statements. Correct? So here a condition, here our problem was to find out the largest in 3 numbers. In that case, I need to compare all the 3 numbers. No. So what I did was, I knew how to compare 2 numbers using relational operators. I did that. Okay. Once I got the larger between the 2 numbers, I compared that larger of 2 number with the third number and found my largest in all the 3 numbers. Simple. Yeah. And if you see, I even wrote a comment. Why did I write this comment? For myself. When I'm writing the code, it's easier for me to write comments, so it's easier for me to build up my logic. Understood? Okay. Let's try to code this. Okay. Instead of this, I'll just change the numbers here. I'll say enter first number, right? So this is one of the one of the example which I gave you, right, where you could use nested. There can be many number of examples. So if I say input, enter second number, C, input. Instead of saying ABC, you could say number 1, number 2, number 3. Okay, you are free to write, give variable names as long as you follow the rules of the variable naming, right, which we saw in the previous lecture. Now is where our logic begins. We said if A is greater than B, we would do something. Okay, else part we had, right? So you are writing a comment also. Comment is I'm saying B is greater. That means this block will get executed when B is greater. Fine, right? Now here I'm saying if A is greater than C. Let's say I am saying large is equal to A. Otherwise, I'm saying else large is equal to C. Correct? Here what I have to do, same thing. If B is, if you know this, then I have to compare B with C, right? So if B is greater than C, then what will be? What is the large? Large would be B. Otherwise, what is it? Else large is equal to C. Correct? Now I need to even print large. I'm actually making a mistake here. See if you can find out. I'm saying print the largest number is, I'm giving large. What is the mistake I'm making here? Look at the variable large. Will this work? Yeah, it will, because large has been initialized everywhere, no? Then it will. But what if I had removed, let's say not used here large, right? Then it would have been a problem. Okay, I hope you got that. If no, we'll see them further. Now let's run this and see. Let's say I gave those numbers, right? What were the numbers I had used? I think I'd used 10 and I'd used 15 and I think it was 50. Right? The largest number is 50. Let's run again. Say, let me change the order. Now instead of 10, 15, 50, I would make 15, 15, 50, and the last one was, let's say 60. Largest 60. Let me run it again. Let's give 60 as the largest number. Okay. In between, we can give 15 and let's give this as the smallest one. Largest number is 60. So it's working with for all combinations. I think I've tried all. You can even try if I've missed on some. Did you understand this? Now, instead of saying, see, the only reason I, kept on giving large here and then just wrote here is because what I've done here effectively is, if I had not used this variable large, right, I would have to write how many print statements? Line number 6, 1, line number 8, second, 11, and 13. So total 14 print statements. Instead of which I just stored the value in the variable called large and I just used it once. I just wrote a print statement once. So what I'm basically doing is I'm writing in clean code. Instead of writing print statement 4 times, I'm just trying to use our variables to store the value and just printing it out once at the end. Understood? Okay. If this is confusing, you could just choose to, write the print statement, wherever you have large equal to A, just print it. Print the largest number is whatever, A or C. Understood? This is where you're trying to do nested. Nested is nothing but having a if block inside another if block. That's all. Okay. The reason, see, if you look at it, why do we need a condition like this is, see, because this if A is greater than C, right? This condition I want to check only when I'm sure when A is greater than B. Otherwise, there is no meaning for me to check A greater than C. When I know that A is greater than the first number is greater than the second number, then only I want to check this first number with the third number. That is why we have, we have this if. That is why there's a practical need of having this nested if conditions. Understood? Please give it a try. And I think that's all for, your conditional statements. Yeah. We have studied all different 4 types of this. We even did the nested one. Correct? Now just one last thing. We're finished with the conditional statements. Okay. We did when it came to operators, we have done the arithmetic operators and we have done relational operators. Right? There's one more which I wanted to show, which are called as logical operators. And these are fairly easy. One is you could have and there are or. Simple English. Okay. And is like you could use, and when do we use and, right? When you want, let's say you want your dad to get you chocolate and ice cream. You want both of them. So how would you tell your dad? You would say, Dad, please get me chocolate and ice cream. Okay. Would you use or there? No. Or is like giving an option. Either get me a chocolate or either get me an ice cream. No. But in your case, you wanted both chocolate and ice cream. Then you would use the word and. Right? When you want both the things. Or is when you would use one of them and you just want, when you're okay with having one of them. If you get two, it's okay. But if you get at least one of them, you should be happy. That's when you use or. Right? When you try to give a choice. Right? Similar semantics, similar meaning is used in programming also. Okay. When you want, and these are usually used with conditions, right? Let's say you were writing a if condition and you want to know that if condition 1 and condition 2, if both of them is true, then only you will do a set of statements. If that is the case, then you would use and. But let's say you want to, do some statement. Let's say the statement which you want to do is you want to say print hi. You want to say print hi only when condition 1 and condition 2 is true. But let's say you have another requirement. You want to say bye only when condition 1 or let's say condition 3 or condition 4 is true. So either one of them is true, you would say bye. Understood? But let's say both C3 and C4, both of them are evaluated to false, then what will happen? Then you will never say bye. So when you're saying or means either one of them at least. And I'm saying at least means if both of them, let's see, what I'm trying to say is this, when will this bye get executed? If this is true, this is also true. Good, very good. No problem, you're going to say bye. Let's say this is true and this is false. Fine, you're still okay. One of them is this. If this is false and this is true, still okay, right? Because one of them is true. But if both are false, then what happens is you are not happy. You want at least one of them true. So for this, the bye will never get executed. For all the other case, bye gets executed. What about C1 and C2? No, this will get executed only when this is true and this is true. You are not happy if one of them is true. No, you want both of them to be true. Then only you would say hi to a person. Is what are conditions. Understood? These are called as logical operators. Yeah. Very simple example is now when we did the finding the largest of three numbers, right? See, what is this basically? If you give it a thought. What do you want? You are trying to say A is greater than B and A is greater than C. If both is true, then you would say is A is the largest number. Correct, no? So instead of having two if conditions, you can combine these two if conditions using one and. Are you getting me? What I'm saying is, see the code which we just wrote, we said if A is greater than B, then you will say A is greater than C and then you would say larger is equal to A. That means for a number A, okay, a variable A to be larger, it has to be greater than both B and C. Correct? Before you do not know the logical operator. So how did you do it? We do it using two if conditions, nested if conditions. Okay, why nested? Because we wanted both to be true. So when you reach large equal to A, you are sure that it has, satisfied the first if condition and the second if condition also. Correct? So instead of writing this nested if, what if I used and, to basically combine these conditions? Very good. Your code is going to become easier. All right. So what would you say? You would say if A is greater than B and A is greater than C. What is then who is the larger number? A. Let's say I'm going to say large is equal to A. What is the next condition? If A is not larger. Now let's come back to A, B, C, right? We have three numbers, correct? At a time only one number will be larger. Agreed. That means can I use else if? Yes, I can use. Let's say now this block is taking care when A is larger. What is the next one we can have? When B can be larger. How do you check that? You would say else if B is greater than A. Write it again properly. I'm saying else if B is greater than A and B has to be greater than C. If a number has to be larger, it is greater than the remaining two numbers, correct? That means that's what I'm trying to do here. Are you getting my point? I'm saying if a number has to be largest number, when the given three numbers, then that number has to be greater than the remaining two numbers. Correct? That's what I have done here. This is very intuitive. Earlier you did the same thing using nested if conditions. Right? Here I am using this. If B is greater than A and B is greater than C, then my larger is B. What is the remaining part? Remaining, I would say, instead of writing a else if, I'm going to write another else condition where I'm saying else if, what is the last part? I'm saying if C has to be the larger number, C has to be greater than A and C has to be greater than B, then I would say large is equal to C. Did you get me? Correct? Either this is it. So I can say this is greater than or equal to. You can make it equal to also. Understood? Does this make sense? Yeah. This is where your AND operators would come into picture. Okay. Just give this a try. As you know, as an exercise, might be try to code this up. Okay. Try to use AND and OR for doing your, finding the large. Basically converting this, using this instead using an AND and OR operator. Okay. Yeah. Now, let's just do a simple one for AND and OR. I'm going to do, the one which I'm going to do is going to be a simple one for a color code. So what I'm saying is, let's say, if the color code is 2, okay, if the color code is 2, right, and I'm going to enter two numbers. One is the color code, this is my color code, 2 is red, I think 3 was blue, and 4 was yellow. Okay, so what I want to do, what is my question is, if the number entered, okay, the number entered is from 2, 3 and 4, I am going to say that it's a valid color. Otherwise, I'm going to say it's an invalid color. Did you get my question? My question is saying that this is the color code, 2, 3, 4. Okay. If the user enters a number, either it's 2, 3 or 4, which is for whom you know the color codes, you're going to say a valid color code. Other color codes, let's say the user enters 5, what should your output would be? Your output should be invalid. If the user enters 2, what would you say? Valid. Why would you say valid? Because this 2 is present in the color code chart which I have. That means the color code is valid only if it is present in this chart. Otherwise, it should be marked as invalid. Correct? Yes? So how would you say whether it's valid or invalid? How will you do that? Simple, you can use an OR. If your color code is 2 or it is 3 or it is 4, then you can say it is valid. All the remaining cases you could say it is invalid. Got me? Yeah. Let's see how that is done. Show you here. So I'm just going to change this and write it here as code. And I'm going to say enter color code. If the code is equal to 2, right? Or the code is equal to 3 or the code is equal to 4. Now, if you give spaces in between just to make it look good, if you do not give, that is also fine. But it, makes it more presentable, right? What I'm going to say, print valid. Correct? In all the other cases, I need to say print invalid. So I can just use an else. Yeah. So I'm going to say print invalid. So if you look at this will be it will be valid when one of them is true. Okay, at least one of them have to be true. That's what my condition is there, right? So if I say 4, it has to print valid. Let's say if I print a 6, it has to say what? Invalid. If I give a 2, valid. If I give a 3, it is valid. Correct? Now, instead of or, if I change it to and, what do you think will happen? Will this ever be return me valid? No. Why? Because it cannot be true, right? Is code equal to 2 and also equal to 3 and also equal to 4? No, it is not the case, right? Anyways, writing this also doesn't make sense, but just trying to show you how and or works. Understood? So if I do this here, if I give a 4 here, I'm going to say for this part, this is how OR is used and this is this. Now let me even give you a simple one for AND. Let's say this is the code is equal to this, right? And let's say if I even take a color, so instead of having a color code, I'm asking the user to enter a code, a color also. Okay, so I'm saying enter color, right? Now if I'm just trying to see whether the user has made a correct guess or no. Okay, so all I'm going to do is I'm going to say if code is equal to 2 and color equal to red, then I'm going to say success. Otherwise, I'm going to say failure. That means only for this combination, I'm going to say success. So if I run this, if I say color code is equal to 2 and if I give red, what happens? I get success. Yeah. But let's say if I give 2 here and if I give yellow here, according to the code which I've written, what should I get? Failure. Why? Because to print success, both of the conditions need to be true. That means code is all needs to be true and color also needs to be red. Okay, let me switch it. Suppose if I make this as 3 and give this as red, okay, what do you think the answer should be? Again, failure. Why? Because you put a and here. But instead of and, if I just make it as or, right? See, this particular program doesn't make any this, but I'm just trying to show you how and or works. Right? So suppose if I do an or, now what will happen? We run this. If I put a 2 here and if I give a yellow here, what do you think now? Because this is or, this will work as success. Because for or, what is the requirement? One of them has to be true. Now if I run this again, and now what I do is I put a 5 and I put a some number pi j. Let me just get this. Let me put here. Let me put a 6 here. Okay, and let me put some color, enter color, say I put a YH, something. So I get a failure. Why? For or to be true, for the print to be executed, or means one of them at least, one of the conditions should at least be true. Now in our case, we don't have any of the conditions which are true. That is why failure was printed. Okay, now does it means you can only have 2 conditions when you're using or and? No. You can have more than 2 conditions. You can have 3, 4, any number of conditions you want. Okay. In my code, instead of this, if I put one more condition here or, it should be fine. I can also put an or here and whatever condition you want. You want might be something. Let's say 2 is equal to 2. Is 2 always equal to 2? Yes, true. It's always true, right? So that doesn't make sense. Just trying to show you that, you can have any number of conditions are possible. Understood? Okay, the or and the and part. So I think we are good. So we have done all the different types of conditional statements. Yeah, we saw the nested one. We saw we can avoid nested using the logical operators, which is and or. Okay, and as an exercise, maybe I'll just give you a little bit of logic. Try to do the finding largest of 3 numbers using the and operators. Basically and or operators. Okay, let's stop here. Hi everybody, to the next topic. And now we're going to start the most interesting topic in Python, which is called as loops. Right? Let me just on this. Yeah. So we're going to start what is called as loops. So what do you understand by the word loops? What does loop in English? Forget programming. What does loop in English mean? Something is let's play the music on the loop. Right? That means what? Once you play a music, you again listen to the same music again and again, right? On the roll, to keep on playing it until you decide to, like, you're now bored of that particular piece of music. Correct? So same thing in programming. When we say that we have loop concept in programming, it means the same thing. It means that you're doing a particular task again and again until some condition is satisfied. That means, let's say I have to print let's say I have to print hi 5 times. Okay, what would you do right now in programming? So how much Python you're going to write this print statement how many times? 5 times. It's 1, 2, 3, 4, 5, right? You write the same statement 5 times. That means, because we do not yet know how to tell Python, or how to tell how to use Python to tell computer that I need to print this hi 5 times on the screen. Okay, so what available information we know about Python language, we're going to type it 5 times. All right, same thing we can use a loop. Let's say we use a for loop. Okay, and we just type in once hi and tell in the for loop that please print it for 5 times. Then what happens? We look at the syntax later. just and there's a way of telling computer. A for loop is a way of telling computer. So in loops, right, we have two types. One is a for loop and one is a while loop. Okay, both means the same thing. Basically, if you have, like, here the piece of execution, okay, or the piece of task which we need to be done is printing hi on the screen. Correct? That means this line of code, we want this to be printed how many times? 5 times. So instead of telling, writing 5 times a Python code to print hi on the screen, what we're doing is we might use a loop, okay, which will instruct computer that this particular, whatever is there inside this for loop body, right? We know as whenever we have this, that means the start of a body has happened, right? So whatever is there in this block of code, this block of for loop has to be printed how many times? 5 times. So what we have done, instead of writing 5 lines, okay, repetitive lines, we have brought this down into 2 lines. Okay, so what is a loop? A loop is something where there is some logic, there is some execution which needs to be done again and again, repetitively, might be for some n number of times. When I say n can be a finite number, like for 10 times, for 100 times, for 110 times, for something which I can count. Correct? Now you see, if there is nothing I can count, that means if I want this hi to be printed for infinite times, that is not what is supported in Python. What is supported, if you can tell Python exactly how many number of times you want to do it. That is 2 times, 10 times, 700 times, 1000 times, 1 lakh times, some number. Okay. If you want that many times a particular task needs to be executed, you can use loops. Understood the concept? This is what loop is. Simple example, suppose if I have to print hi on the screen 5 times, I want hi to be printed on my screen 5 times. So I would have done, if I do not know what loop is in Python, I would just print hi, this particular line, right, which I just showed you. This you would write how many times? 5 times, right? Okay. Instead of doing this, if you know the concept of loop, you would use a construct called as for loop and tell the instruct the computer that please print whatever line I have here for how many times? 5 times. Understood so much? Okay. This is the basic concept of loop. Now, before we go ahead, I just wanted to again reintroduce. I mean, I just told you what a loop is, and we just discussed something called as, you understood, there's some loop named as for. Okay. So in Python, we have 2 loops. One is a for loop and the another one is a while loop. I just told you, right? For loop and while loop. All right. So far clear? In this lecture, we're going to understand what a for loop is. So whenever we have to understand a particular concept, a new concept in Python, how do we do that? We first understand why was it developed or what purpose does it serve. So in here we know if we need to do some repetitive task, we can use a loop. So if we have to do some repetitive task, we will use a loop to do it. That is the first thing. Then what we need to do, we need to look at the syntax, right? Because we need to have a correct syntax so that we can efficiently or correctly inform computer via a Python programming language, right? First is why, what is the purpose? Like, what is its purpose? Correct? Then the syntax. And third is, we will look at some examples on how to, solve a particular problem, a particular task using a for. Agree? Now, this we have understood. Now, second part is we need to understand the syntax. So, before you go to I'll just tell you the syntax. What happens is, we say for I in range some numbers. So instead of this, let me make it more generic. So what I'm saying is, for some loop variable, okay, you can have any loop variable in means in a given range, right? So you will mention some range. Range means how many times you need to do it. You will have some lines of code. So you'll have some lines of code to be executed. Correct? So what is it saying? For. The keyword is for. Then you have a loop variable in. In means what? Suppose if I say for I. Suppose my loop variable is I. Okay, loop variable is nothing but a variable. Okay, a variable which has meaning in that particular loop. For example, if I say for I in range, let's say 1 to 10, and I'm saying print the value of I. Okay. So now this I has meaning inside this loop. What is inside the loop? This. If I have to say something here, I equal to something, if I say print I would not know outside the for loop because this is outside for loop. Okay. This I has a meaning inside the for loop. That is the first thing to understand. And second thing is, this I is going to take some values. Now suppose if I have to run a particular, say I have to print, you know, how many times I have to print? I have to print high, how many times? Suppose 5 times, right? We just took an example. We need to print it for 5 times, right? Then what happens? This I will basically take value how many times? 1, 2, 3, 4 and 5 times. Okay, that is what this I will take. We'll come to it again later. Just a brief introduction that this is how the syntax looks like. We have the keyword for a loop variable. In is basically called a membership operator. Membership operator. It is basically telling that loop variable, okay, it takes now every variable. What is a variable? Variable is basically a label given to a memory location. Agreed? So what it is trying to say is that every loop variable, whatever variable value, whatever value is associated with this loop variable, those values are coming from some range. Okay, that is why this in is telling that this loop variable's values are basically coming from this range, whatever range we are going to give or define. Okay, that's why in is like membership. This loop variable is basically a part of this range. That is why the in keyword is used, and in is basically a membership operator. It's basically tell the computer that this loop variable will be taking values only from this range. Understood? Now whenever, so now what happens is this is just start of your for block of your for loop, and whatever lines you need to write inside your for loop can be written here. Okay, this is the syntax. Now I know I don't think this would be very clear. I just wanted to introduce the syntax of for loop. Now we'll go step by step in understanding it in detail. Okay, the first things, now in this syntax, what have I have written? What are the things that you do not know? We don't know quite a lot of things, right? We don't know what this range is. That's the first thing. We still kind of don't understand what a loop variable is, right? We also don't understand what in is, right? We are not very crystal clear about it, correct? And we also do not know how can I tell, you know, if I have to say that I have to print, you know, high for 5 times, how am I going to do it? Even I'm not sure about that, right? We do not know these 4 things. We're going to go one by one. Okay. Now, first we're going to start with range. This one, range, how to give a range. Okay. So range, let's say we have a function. So again, range is again a function. Okay. There's a range of function in Python. Okay. And the syntax of this function is, see, for function means what? You have to give a input to the function, right? And it will get some task for you. Correct? So you will have a start, you will have a end, and you will have a step. I'll tell you what this means. Start means if I have to tell you a range, right? If I tell you that, if I tell you, if you ask me, can you just give me a range of numbers, right? So what will I tell you? I'll tell you range of numbers might be, I'm thinking of range from 5 to 12. Now what happens? What is my range starting from? Is basically 5. It's like basically sequence of numbers, right? So range of numbers is a sequence of numbers, and every sequence of numbers would have a starting point, correct? And would have an end point. That's the second thing. Like 5, suppose 5 to 12 is what? Again, what else we require for the sequence? We need to know, suppose this is the first number in my sequence. For the second number, how do I get my second number? Should I be doing +1 or should I be doing multiplication by 2? What should I be doing, right? See, if you must have solved some puzzles, right? We usually have this, you know, you're given a sequence of numbers, something, and you're asked to find out the one of the numbers in the missing numbers in the sequence. Similar, that is what I'm talking about, right? It follows a pattern, correct? So we need to tell that the next number in the sequence, okay, suppose it is 5, this is 6, this is 7, 8. Suppose this is my sequence of numbers or range of numbers. What is the starting point? The starting of my range is what? 5. What is my end? End is 9. And what is, how can I get my second number from my previous, how can I get this number from my previous number? By adding +1. Is it true for all? Yes. If I do +1, yes. If I do +1, I'm getting a number. That means this +1 is called a step. What is it called? Step. I mean, from, if I have to get a current number, I can get it from the previous number by adding the step. So what I can do, my previous number is 5. I add the step. Step is what? +1. So 5 + 1 is 6. So I get this number. Are you getting it? Okay. What is my start? Start of this range is 5. What is end of this range? Is 9. So I have a range from 5 to 9. And I can get all the numbers in between by using the step function, which is step equal to 1. That means what? I start with the first number, I add +1. Again, I add the +1 to my 6. I get 7, then +1, 8, +1, and 9. Understood? So same thing if I have to achieve through my, in Python, I have a function for doing so. Okay? So the function is range, and whatever we spoke about, right, the step, end, these are the same semantics, which are the same meaning, whatever we have in input. Okay, so this is what? This is the start of my range, start of range. What is this? This is my end of the range. Okay, I'm going to add one more term here. I'm going to say included in the range. Here I'm saying excluded in the range. We'll come to this, what I'm trying to say. Okay, so suppose, now let me take so this is the syntax of the function. Okay, this is what it means. Step function is how can you get your next number in your particular sequence. All right, now let me take an example. If I'm saying range 1, okay, I'm saying 11, and instead of taking 11, let me take a smaller number. Let me take 6, okay, and I take a +1. All right, so now what is happening? I have mentioned this. So what does range do? Range gives us a sequence of numbers, right? Now what is my starting number? 1. How do I get the next number? It has told me step is what? 1, right? 1 means I'm going to add here 1 plus 1 is 2. 2 plus 1 is 3, 4, 5. Okay, here this is my end. But I have mentioned this excluded. Excluded means I will only go till a number which is less than the end. That means 5 is 5 less than 6. Yes, that means I can include this in my range. I cannot include 6 in the range because 6 is not less than 6. Okay, so this end is like the stopping condition. What is it? The stopping condition of your sequence. Stopping condition of the sequence. Right? So, I mean, you start with a particular number. So, how long will you go? No, you can do +1, you can go to infinite. But there should be some stopping condition where you're going to stop. So that is given by end. Okay? And it is saying that whatever last number in your sequence is, it should be less than the 6. Strictly less than 6. That's why it's saying it is excluded from the range. Got this part? Okay? So now let's do more examples. If I say range 8, 10, and if I do 2. Now what is happening? Now what we understand? This is my step function. Correct? What is this? This is my end. But this is what? This is always excluded. That means whatever my range is, last number of my range will be less than 10. Do you agree with me? Yeah. This is my starting. I mean, where do I start my this? And this is basically for numbers, and more specifically, this is for integer numbers. This range function only deals with integer numbers. That means what? Your start, end, your your step function, right? All these values can only be integer numbers. Integer means what? You cannot have a decimal point. Understood? Okay. Suppose this is there. So what will this generate? It's a sequence. Starting is 8. What is it saying? Step function is +2. What is when I do +2? 8 plus 2 is what? 10. Now is this 10 less than 10? No. That means what is my range finally? Only 8. Got this? I have only one number in my range, which is 8. Got? Next, let's take one more example. I am going to say in integers, right? What do you have? You have positive in numbers and negative numbers. Only thing which are not allowed are what? Are your decimal point numbers. Agreed? So I'm going to just take one more example. I'm going to start with n. Okay. I'm going to end with say 1. And my step function is -1. So now what will we get? Starting with 10. How do I get my next number? I'm saying -1. Correct? When there is no symbol, it is always plus, right? You don't have to explicitly say plus, right? But I'm saying -1. So 10 minus 1 is what? 9. Now, what we said, this end is basically telling us what is the last value in your of the sequence, and it is always excluded, right? In the positive one, we said this number, whatever your last has to be less than 10. Correct? But here what it will be? Here it would be whatever your last number is has to be greater than 1. Strictly greater than 1. You agree? Do you see this difference? Whenever it's negative, it has to be greater than. Whenever it is positive, it has to be less. Yeah, it is fairly intuitive. Just wanted to bring it out. Okay, this is my end. So I'm going to say 9 minus 1 is what? 8. It's still less than, it's still 8 is greater than 1. I'm fine. Right? Now what is it? -1, 7. -1, 6. 5, 4, 3, 2. Can I have a 1? No, because 1 is 1 greater than itself. No, that's why I can have only till here. So how many numbers do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 numbers are present in this range. And how much? Instead of writing all these 9 numbers, I just have to use this function and I will get this range. What is the range? Starting is 10. What is my end? End is 1. That means it has to be greater than 1. Why I am saying greater than 1? Because I have a negative step function. What do I have? I have a negative, let me write it properly, I have a negative step function, or a negative step, right? Minus 1. Did you understand this? Let me reiterate again. Why am I looking at range? I'm looking at range only because I'm trying to learn all loops, how to write loops in Python. The first you're going to look at is a for loop. In for loop, the syntax which is told to us is for loop variable in range. Now I need to understand how to get this range. Now for this we have a function in Python called range, where all the values are always integer values, correct? Integer can be positive or negative numbers, but we cannot have what? Floating point or decimal point numbers. Okay, so we have start, end and step. So start is basically you're the starting of your sequence. End is that particular last number. I mean, you need to have a stopping condition for your sequence of numbers, right? So that is given by this end function. Step tells us how do you get the next number in your sequence, because you just have the starting. How do you derive the next number? So that is given by the step. Understood? And we did few examples for the range, right? Now we know the range function very well. Now let's revisit the syntax of for loop. Okay, we said for loop variable in, and then when you use the range function. So now what I'm going to do is I'm going to just write this. Then we said the range function. Okay, and we had some this was a syntax, right? Now let's write it using the, now we understand what range function is. Now let's write a range. Range, what is a for loop? For loop basically tells Python how many times you want to execute particular lines of code. Let's say my line of code is, let's take the same example. I want to print hi, let's say for 5 times. If I want to print hi 5 times on the screen, what will the range I'll give? I'll say I'll start with 5, and start with 1. I will say what? End with 6, and I would say 1. Why end with 6? Because my last number would be 5 and this last number is less than 6. How many I'll have? 1, 2, 3, 4, 5. Are you getting my point? Why I do not have 5 here? Because we have a situation, because this whatever your end is, right? It has to be what? Your last number in the sequence has to be less than, strictly less than this end, because it's excluded. Understood? This is why the range function is. Now we said a loop variable. So let me take a, you can have any name of the variable, right? Because it's a variable means you can have any name. I'm just taking here I. Usually it's a convention. Usually I is taken when it is for the loops, but you can take any variable name. It's not a problem. I'm saying for I in. Now what does this I? We said this I basically takes the value from 1 to, from this range. Now this range will have how many values? 1, 2, 3, 4, 5. So what is saying is this I will be sometimes be 1, will be 2, will be 3, will be 4, will be 5. That means in means what is trying to say is we are trying to tell Python this variable I will have what are its possible set of values. What are its possible set of values? I mean these I can take any value from this particular range. That means this I belongs to this range. That is why the membership operator in is used. Do you understand? It's saying this, what does this sentence is now saying is this variable I, which is a loop, which is called a loop variable in syntax. It is saying this I can possibly take this many values of the range. Okay, did you get this part? Yeah. Now so much we have understood. Now let's say how it is actually working. So let me write this again. I'm writing it again and going very slow. Reason being because I want you all to understand this very thoroughly. So now the tricky concept of coding language. You go to any coding language, will have loops concept. Okay. Now we know the range is going from 1, 2, 3, 4 and 5, right? Because we know how range works. Now I will always start from the starting value when I is equal to 1. Correct? Now this one, is this one less than 6? Correct. It's agreed. So it will enter what? The for loop. In for loop, what is there? Print I. So what will happen? On my screen, I will have I printed. Okay. Next what happens is updation happens. Updation means now the value of I has to be changed. Now that change is depending on what? On the step part. Okay. So now this 1 becomes what? 2, because I will do 1 plus 1, which is 2. Now if this number is valid or no as per the given range. How do we check? We check is 2 less than 6. Is it correct? Yes. That means I equal to 2 value is a valid number in the given range. That means I can enter inside the for loop and I can again print a high. Once I print the high, again where will I go? I'll again go to the step part where I have to now update again. I would say updation. I will now, I had value 2, 2 plus 1 which is 3. I have to again check whether this number is a correct number from as per the sequence, as per the range function. Is 3 less than 6? Yes. That means what I'll have to do, I'll come inside the loop and I'll again print a. Again, what happens now? Again, it goes for the updation part. Updation now, what value will happen? Value will become 3 plus 1 which is 4. Now, is 4 less than 6? Yes, it is. That means it will come inside the loop and again print a high. How many times high we have? 1, 2, 3, 4. Correct? Now, what happens? Again, we have to do updation. Right? What is updation? Now value will be 4 plus 1 which is 5. Is 5 less than 6? Yes, it is. That means I enter the loop and I'm going to do a 5. That means to access whatever there is inside the for loop, you have to make sure that your condition is satisfied when you are doing this step. That means whatever number you have in your loop, whatever value your loop variable is holding, it should be a valid value. What is a valid value? Valid value is a value which actually satisfies the condition. Which condition we have given by n. Understood? Okay, so now what happens after 6 is done, after 5 is done, again we have to go for the updation part, right? What will happen? 5 plus 1 will become 6. Now again what we do by usual, we have to check for condition. Is 6 less than 6? No, it is not. The condition is not satisfied. That's why we will not go inside the for loop, and that's why we come out of the for loop. Come out matlab what? After this, after this condition, after where this condition, where 6 is less, where this particular condition fails, right? What happens? Your condition fails. What condition fails? The for loop condition. Or how do we have the for loop condition which is given in the range function by the end part? Correct? So once that condition fails, we terminate the loop and we come out of the loop. I mean, we will not again go and update I. No. We will again come out and whatever, suppose there is a statement here, suppose, to print end, we will come here on the screen and print end. Did you get this? How am I looking? Just try to rewind this lecture and read and, go through it again. Okay, what I'm saying is every time whatever this value of I can take any value, okay, in this range. Okay, in means it's trying to tell the computer I will take possible values and these possible values are from the range only. Okay, so every time I will always start off with the starting value of your range. There will be an updation. Correct? How the updation happens? Updation happens depending upon the whatever step you give in the range function. Correct? Then you need to, after updation, you need to check whether whatever number you've got of the sequence, is it actually a valid number? I mean, is it really belong to the sequence? How do you check that? You check that by, using the end which is given in the range function. Basically this. Okay, because it's a positive step, what will you check? Whether the given number which you have derived, is it less than the end? If it is a negative step, what will you say? That number has, whatever number you derive is greater than your number which is given in end. Why? Because it's excluded. Always remember, this is included, this is excluded. Correct? That many times. So whenever your condition is fulfilled, then only you can come inside the for loop and whatever statements are there inside it, similar to your if. Now, whatever, once you enter a block, you can execute whatever is there inside it. Okay? You keep on doing it until your condition is satisfied. Once your condition is not satisfied, you just you do not go again for updation. You come out of the for loop and then execute whatever is there after that. Understood? So if I have to make a summary, how a loop is, basically implemented in Python, especially for a for loop. What are the 3 important steps? 3 important steps is we have an updation part, we have a conditional check, and we have an initialization. Let me write it correctly. There is an initialization. So initialization, right? So what does initialization means? Initialization is, so remember the start. So you need to give a starting point. No? The value of I should start from something. That is called initialization. So in the range, this is a start. Updation is basically your end. How far it can go. Okay. Sorry, updation is basically my step. My bad. Updation is basically what step? So if you have to update, right? We did +1. So based on what? The step. Conditional check is done using your end. Understood? So your loop part, now right now we're looking at the for loop, okay? But any loop concept, whether it's a for loop or a while loop, it will have these three important steps, right? If you have to take a piece of code and you want to do it repetitively, you need to know from where to start. What is the initialization? Okay, how will you update? And when you update, you have to even make sure the next value I get, whether it is correct and or no, that you can do through conditional check. So all this is achieved only by one function in Python, which is the range function. Look at the beauty of the range function, right? Just one function but does three jobs for us. Understood? Did you get this? Let me do it again. Let me just run this and show it to you so that you know it's more clear. So what I'm saying is I need to print, I 5 times on the screen. I'm going to write a for loop for I in range. I need to run it for how many times? 5 times. So I'm saying 1, 6. My step function is 1. And I'm going to say print I. Right? That's all. So what happens now? Okay, instead of this print I, let's say I'm going to say print. Yeah, let me run this. So I got 5 how many times? 1, 2, 3, 4, 5. Correct? So if I have to make it run for, let's say, if I want to display high on the screen for, let's say, 4 times, what would I do? I'll start with 1. I'll go how many times? I'll go till 5 times, because then 1, 2, 3, 4. Correct? Now here somebody might have a question. Instead of going from 1 to 5, can I just make it from 2 to 6? Will it give me the same number of highs? Yes, because 2 to 6, how many numbers you have? 4 numbers. Your range function is basically deciding how many times the for loop will run. Okay, so if you want to execute whatever is inside your for loop, suppose let's say for 10 times, so make sure your range function is written in a way that many times that range function will execute. Means what? That many possible values of range are possible. Correct? When I say from 2 to 6, how many numbers you have in this sequence? 2, 3, 4 and 5. How many numbers? That makes 4 numbers. And anyways, my goal was what? To print, let's say, high for 4 times. So if I run this, let me run this again. See, I'll again have 4. I make it 2 to 6, or I can make it, 1 to 5. The number of highs I'm going to get is going to be the same. You get this point, right? So the range function is basically used to determine how many times you want your loop to be executed. Okay. We'll stop here. We'll continue in the next lecture. So this is the second lecture for the for loop. So the first lecture we understood what a loop is, correct? We understood that every loop is made up of 3 parts, which is initialization, updation, and the conditional check, right? And if it's a for loop, we have spoken about a range function, which does this job of all these things, right? For initialization, the start is the part which takes care of it. Updation is done by the step, and conditional check is done by the end part. Correct? And the syntax was looking something like this: for loop variable in the range function, whatever we have inside. Yeah, we did the first very basic question was to print let's say a string for n number of times, where n can be, let's say we had taken 4, 5 depending on it. Correct? Now we'll do the same question. Okay, printing a string. Okay, this string, let's say that we have to print string I for how many times? We have to print it for n times. So now this n will be taken from user. Earlier what we did, we did a easier one. We did not take anything from the user. All we did was just gave a random range, right? 2 to 4. We said this 2 to 5. It said it was run for how many times? 2, 3, 4. That means 3 times the loop would run. Now I'm saying this string, and even the number of times that string should be printed should also be taken from the user. Let's try to code that question. So what is the change you would do here? You would first take n. Okay, I'm going to say int input, enter the value of n. Let's the user knows what when I say value of n is number of times you want to run the loop. Okay, after that I want to have a string, so I'm saying input. If it's a string, I don't have to convert it into a number. That's why it's just plain input. Enter your string. I'm just making the previous question generic. Now I need to write a for loop. Correct? Why for loop? Because I have to print this s, whatever value is given in this s, how many times? N times. Correct? Now I'm going to say I in range function. I need to print how many times? N times. So let's say if I'm going from 1 to n plus 1, will it print for n times? Yes. Suppose let's say n is equal to 4. And that means what the range would be? Range would be 1 to n plus 1 is what? 5, right? So 1 to 5. So how many times? 1, 2, 3, 4. So 4 numbers are there in the range. That means 4 times the loop would run. Correct? So this is correct. And how I do want my step function to be? Should look like comma 1. Okay, between increase by 1. And here I'm going to say print. What I need to print? I need to print whatever is in S. So let me run this. Let's say the value of n. Let's say we want it, so say, let's say 3 times. Okay, string, let's say hello. Now if you look at it, see, hello gets printed 3 times. Is it clear? The same function, nothing different I did. I just made it run that many times. Okay, now let's come back. Let's do a few more examples, right? I had already worked out how a particular for loop function works, right? How the updation part works. You go to print, you go to this step, you say start with your I value, will start with this initialization. What is initialization? Whatever is there in this, start of the range function. Okay, each time you will do updation. Updation will depend upon what? The step function. Correct? Then you, after the updation is done, you get a new value of I. What you do, you check whether this condition is fulfilled. Condition fulfilled can be checked with AND, with the end part. Correct? So you keep on doing this until your condition is satisfied. Once condition is breaks, you just come out of the for loop. That's how the working is. Okay. Now based on this, let's do a second example. Second example is using a for loop. I want to print first n numbers. Okay, 1 to n numbers. So let's say the user gives me n as equal to 2. My output should be 1 and 2. If user gives me n equal to, let's say 8, my answer should be 1, 2, 3, 4, 5, 6, 7, 8. So basically, I need to print 1 to n numbers. So what do you think? How can I use a loop here? Here it was easy, right, to understand. Because I had to print hi or print hello that many times, I just ran the loop that many times, right? But here what is happening? If I do not do it using loop, what would you do? You would say print 1, next you would say print 2 for this, correct? When n is equal to 2. Here what you write? You would write a print statement, how many times? 8 times. What changes? What we want to print changes, correct? So here what will change? Print 2. That means print statement is getting repetitive, but what we are trying to print is changing. Correct? It is changing. Now, how do I make use of for loop here? Now, suppose if I write a range function where my starting is 1, okay, ending is n plus 1, and the step function is 1. What will my range value? Let's suppose now n equal to 2. If n equal to 2, what will this range function generate? It will be 1 and 2. Because n would be what? 3. That means you need to start with 1, and this is this what we're looking at for the output when n is equal to 2? Yes. Now let's and this particular range function satisfied. Another one is n equal to 8. Okay, so n equal to 8, what will the range function look like? The range function would look like range 1 to 9 and 1. That means you would generate all the numbers till 8. Is this what we're looking at? Yes. That means if I use this range function in my for loop, right, then I can get this sequence which I basically want to print. Okay, now this values, okay, or this sequence, right, these values are taken by what? Taken by the loop variable which we use. That means I will take the value 1, 2, right? So what you need to print, basically you need to print I inside your for loop. So what I'm saying is, if I do for I, which is my loop variable, I in range 1 to n plus 1, 1, and if I do print I, what is happening? Now let's say when n equal to 2, suppose, range function would be 1 and 2, correct? So I will start with what? 1, because the initialization part, which you get from where? Which you get from the start of the range function, which is 1. Now what is the condition would be checked? Is 1, I equal to 1, is it less than, what is n plus 1? N plus 1 is 3. Is I less than 3? Correct. That means it will enter inside the for loop. And what do we have? Print I. What is the value of I? 1. So 1 is printed on the screen, right? After this, what happens? We need to go to the updation part. Why we go up to updation? By the end of this, end of the for whatever is there inside the statements, right? Inside the for block, that is over. Then we go to the updation part. So updation may what we will do? Now I value becomes what? I1 plus what is the step function plus 1. So 1 plus 1 becomes 2. Again you check whether this new value is in the range. Is 2 less than 3? It is. That's why you will again come inside the for loop and you will print 2. Now again what happens? You need to do an updation, correct? Updation, now I becomes equal to 2 plus 1, which is equal to 3. Again you do a conditional check, right? So now conditional check is if I equal to 3, is this less than 3? Is 3 less than 3? No, 3 is not less than 3. Okay, and that is why we will come out of the loop. And what will be printed? 1 and 2. Do you understand how it is working? Let's try to code this up. Yeah, what change would you have to do in this? Here I will just need the enter the value of n. I don't need this, right? Or instead of s, I just have to make it I. And if I run this, if you see, let me give 2, it's going to say 1 and 2. If I make it 8, it's going to say 1, 2, 3, 4, 5, 6, 7, 8. Did you get this? Somebody might have a question. Why would I need n plus 1? If you do n, what will happen is 8 will not get printed. The last one will not get printed. See, if I do 8, only till 7, right? Because n is excluded. If you remember from the explanation of the range function, the end, whatever integers in n, that is excluded. Okay, because it's a positive step, we do less than. Remember, recall that part. That is why we need to make sure n plus 1. Now, somebody would also might have a question. Instead of starting with 1, why not I start with 0 and then go up till n? Anyways, it's going to have that many numbers, correct? But that is not what we need here, because we need to print 1 from 1. Our question is saying we need to print values from 1 to n. That is why I have to make sure that the loop is ran for n number of times, plus I have to make sure the values are between 1 to n. That is why if I do this, this is not, though it is going to run for 8 times, because 0 to with 0, right? 0 to n would run for n times, right? 0, 1, 2, 3, 4, 5, 6, 7. These are how many numbers? 8 numbers. But then my range, I need the value starting with 1, and that is why I am going to make use of n plus 1. In the high one, that was not my requirement, right? I just wanted that many times the loop should run. That's why I did not really worry about what are my starting and the ending numbers. All I worried about is number of numbers, the total number of numbers in the sequence by using the range function should be equal to the number of times I want my high to be printed. But here that is not the case. I want an additional requirement of I need to even print the value of I, which is the loop variable. Understood? So this is one of the questions which you could do using a for loop. All right. Let's do one more simple question. Okay. A simple question would be something like this. You remember the test of divisibility? What does test of divisibility say? Suppose if I have to make sure a given number is divisible by 2. Simple maths. What do you do? If you take any number, let's say n, if I have to divide this number by 2, what happens? The remainder would be equal to 0. If remainder is equal to 0, then can I say this n is completely divisible by 2? Completely divisible by 2. I think most of people know this from maths, but just trying to revise it here. And I'm doing it for a specific reason. We'll be solving a question based on this concept. So what am I saying is, let's take any test of divisibility. Instead of 2, if I make it another divisible by 3. If I want a number n to be divisible by 3, if I divide that number with 3, the remainder has to be equal to 0. Correct? Obviously. Now, if I have to do this programmatically, do we need an operator which gives us the remainder? Yes, we know this mod or the remainder operator. So now if I have to, check if n is a divisible, completely divisible by 2, what can I do? I can say n mod 2 equal to 0. Whatever I wrote here, I just tried to write it using my mod operator. Correct? So now if any number satisfies this, I could say that this number is divisible by 2. Correct? Agreed with me? Very good. So now if we know this concept, the next question is based on it. Suppose you are given, all you need to do is, let's say between 1 to n, okay, between 1 to n, you need to print, okay, you need to print only the even numbers. What you need to do? You need to print only even numbers. So let's say my n is 10. Okay, so starting with 1, what are the even numbers? 2, 4, 6, 8. Okay, and let's say 10, let's not include 10, so excluding 10. Okay, so 2, 4, 6, 8 needs to be printed. Okay, if n is equal to 5, so what will be the answer? Would be 2 and 4. Okay, so basically all the even numbers which are less than n, so between 1 to n, all the even numbers needs to be printed, is what is my question. Now how do I do that? How would you do it? So let's say one of the easy way might be if I talk about a for loop. Suppose if I say for I in range. Now what I need to do, if it's an even number and between 1 to n, does my always even number start with 2? Correct. Do they always start with 2? Yes. So can I write a starting as 2? What is the end part? It has to be less than what? Whatever my n is. So can I have n? What needs to my step function be? Suppose if you start with 2, what happens? Plus 2, plus 2, plus 2. Will this always be the condition? Yes. Right? Even numbers, right? It's always, if you are at a current even number, to get the next even number, you would just add plus to it. Right? So that my step function becomes plus 2. Can I do this? What do I need to print? What are the values? Which these values are taken by whom? I. And that's what I want in my output. So can I say print I? Yes, I can do this. This is one way of doing it. Another way of doing it might be, let's say I do not understand this. I was not able to get through this logic. Another way of doing this might be easy. I could just say for I in the range from C. How many numbers? Between 1 to n, right? So I start with 1, I go with n, right? And simple, normal one which we have used till far, right? And I need to only print if the number is even. So I'm going to say if I need to check if this number is even. If the number is even, means it is divisible by 2, completely divisible by 2. So I'm using a condition, if I mod 2 is equal to 0, then only print I. Will this do my job? Yes. Now what will happen whenever, let's say it's 1. Is 1 mod 2 equal to 0? No. That means will it print I? No. Next, the value of I becomes equal to 2. Is 2 less than n? Let's say this n value is, let's say 5, right? Is 2 less than 5? Yes. Is 2 mod 2 equal to 0? Yes. So will 2 get printed? Yes. On the next, after updation, the value of I becomes 3. Correct? So now on my monitor, I have till now 2. Now, is 3 less than 5? Yes. Is 3 mod 2 equal to 0? No. So that, no, again, we have updation. I value becomes 4. Now, is 4 less than 5? True. Is 4 mod 2 equal to 0? Yes. That means I am going to print 4. Now, what happens again after updating? My value of I becomes 5. Is 5 less than 5? No. So, this condition fails here and we stop the loop here. Correct? So, you can either do it this way or you could do it this way. Okay, this is a smart way of doing it, this one. But this is like finding the, you're trying to print the even numbers between 1 to n, where, the last even number in the sequence needs to be less than n. Okay, that is the question. Let's try to quickly code this and see both the ways. So let's do the smarter one. All we said is let's take the n from the user. Okay, because it's an even number, it's always start with n. Yeah, it has to be less than n and my step function is 2. That's all. And if I run this and if I say 10, so what happens? See, 2, 4, 6, 8. If I run it again, let's give the numbers as 5. So what happens? 2 and 4. Okay, this is simpler one. The another one which we saw is you could start with 1, n, and step function is 1. And now we have to print I only when it's an even number, right? So I have to check if I mod 2 is equal to 0. Why I? Because I is the variable which is going to take up this values, right? That's why I. So if that is the case, I have to make it inside the if block. So I just gave a space here. And now if I run this, it's going to give me the same output. See, if I run it again, give the input as 5, it's going to give me 2 and 4. I hope this is clear. For exercise, what you all can do is, now here we have printed the even numbers between 1 to n, correct? Try to print odd numbers between 1 to n. Okay, what I'm saying is instead of even numbers, try to print odd numbers. See, you can get it. I think you can actually try to solve this question is very similar to the only one small change you would have to do. That's the thing you need to figure out. And that also, if you remember the test of divisibility which I told you, you can even do it using that. This question of what? Question of trying to print all the odd numbers between 1 to n. We did printing odd even numbers between 1 to n. I'm trying to tell you, try to solve a question to solve all to print all odd numbers. Okay, so here is where we are ending our for loop. Okay, I hope for loop is clear. In the next lecture, we will be doing while loop. So in this lecture, we're going to look at while loop. Okay. So we just had a look at for loop. Okay. So there's one more loop in Python, which is called as while loop. Very similar. We're going to understand how it is similar to for loop and how it's also different, so that it's easier for us to understand. Okay. So I said in for loop that for every loop, you would have these three things. Which was it? One was initialization, updation, right? And then was a conditional check. Correct? All these three things were, in for loop were achieved through range functions. So we had one function which take care of everything. Okay. Now let's look at first the syntax of while loop. While loop, what happens is you say while there is a condition and you just have the body. So while loop, if I have to define while loop, it is basically a loop, okay, where you execute this block of statements until this condition is true. What is saying? Let's say we had here around 10 lines of code. Okay, so these 10 lines of code which is inside the while block. Okay, why do we know it's inside the while block? Because see, this we are using this particular colon, right? So these 10 lines of code would be executed until, how many times will be executed? Until this particular condition which we have written here is true. Okay, so simple, very simple. What was a for loop? For loop, we said whatever is there inside for loop, let's say again we have your 10 lines of code. Now this 10 lines of code, how many times will it get executed? That many times until this I or your loop variable takes the value from a range function. Okay, so number of times is decided by this range. Okay, if this range gives you, let's say 10 numbers in total, right? That means this for loop is going to go how many times? 10 times. But what is while loop? While loop is saying whatever lines of code you have, that will be repeated until this condition is true. Once this condition is false, this loop will be broken. Okay, will be terminated. So that's the main difference, or you can say similarities between a while loop and a for loop. Okay. Now in the case of a for loop, we did see all these three things, right? Initialization, updation, and conditional check. In while loop, from the syntax, we could only see a conditional check, but we do not see updation and initialization. It's not very, straightforward as it is for the for loop. Okay, we need to look into while loop a little deeper to understand where this initialization and updation part is. Rest assured, if while loop is a kind of a loop, right? That means initialization and updation will definitely be there. We just have to see how it is going to work out in the code. Let's take the same example where we are trying to print hi. Okay, let's say 5 times on a computer screen. We did this using a for loop using the range function. Let's do it as a while loop. So what I'm saying is, first we need to make sure of initialization. That means, let's say I have a variable here, I equal to 1. My condition being I is less than, okay, I is less than 6. And I'm here saying print I, and I'm having I equal to I plus 1. So this step I'm calling it as a initialization step. What am I calling? Initialization. And this step I'm calling as an updation step. And this part is basically your conditional check. Let's look at the working, how it is working. So you see, as we had in a for loop, right? Everything was inside the range function. This here in while loop, it is not straightforward. Only condition is there as present as part of the syntax of while loop, but initialization and updation, you have to make sure to take care of it if you want a while loop to be working properly. All right. So now let's start. Let's see how this particular function would work. So initial value of I is what? It's I is a variable, right? I value is 1. What is the condition? Condition is saying is 1 less than 6. Is 1 less than 6? True. That means it will come inside the while loop. What will it print? It will print 1. Yeah, print I. Next, what is the statement? I equal to I plus 1. That means now the value of I would become what? 2. 1 plus 1 is 2. Now after this, again will come back here. After from this particular line, again we're going to come back here. Okay, because it is a while loop. Now what is it? Is 2 less than 6 now? Yes, 2 is less than 6. Now we're going to print 2. Okay. Now is I equal to, instead of I equal to I plus 1? Yeah, is instead of doing that, right? Just let me, I totally forgot we're trying to print high here. So let me just say high. Okay, so now what will happen is instead of having 1, I'll be printing high, I'll be printing high. Okay, so now what happens is 2 is less than 6. Okay, so now again what happens? Updation part, I equal to 3. Correct. Now is 3, again your control goes back to the condition. Is 3 less than 6? Yes. Okay, so you will again come inside the while loop. You will print what? High. Again updation, I becomes what now? 4. Is 4 less than 6? Yes. Again you will print high. Again updation, I becomes now 5. Is 5 less than 6? Yes, 5 is less than 6. So now what happens is print high. Again now what happens? You will have to come to this step, right? Now value of I becomes equal to 6. Now you check the condition. Is 6 less than 6? No, the condition is false. Once the condition is false, let me show it by different line. Once the condition is false, the control will be coming out. This is when the condition is false. When condition is false, okay, then the control of execution will be coming out of the while. That means when, in other words, we say that the while loop is, its execution is over. Understood? Okay, very easy to understand, very similar. So here what we did is we trying to print high using while loop. Okay, similarly we could even try to print what to say 1 to n numbers. So what I want to do is how many number of problems which we did using for loop, we'll try to do the same one using while loop, so that you understand how the representation is. Okay, so your first one is I showed you how we print high for 5 times. If you had to, let's say instead of 5, if you wanted to print it for let's say 10 times, so what is the change you would do in the code? The change you would do in the code is, you would say instead of 10 times, what would you do is you would make this 1, that is fine, but instead of I less than 10, you would have made it I less than 11. You could have the condition either I less than 11, or you could have the condition I is less than or equal to 10. Both of them would work, correct? And then and this rest all thing remains the same. Okay, no change in that. All right, so based on how many times you want, you can change the condition. Okay, the second question which we had done in for loop was to print the numbers 1 to n. If n is equal to 2, number is 1 and 2. If n is equal to say 5, you had to print 1, 2, 3, 4, 5. Right? So what will you do using while loop? You would have a condition, correct? Now to have a condition in a loop, you need initialization. Let's say I have an initialization I equal to 1. Why did I initialize I equal to 1? Because I want to be printing from 1. Okay. Then I said how many times I need to print. I need to print how many numbers? I'm going to say, suppose if it is 5, I need to print, let's say, and I need to print until 5, right? Including 5 I need to print. That means I'm going to say I is less than or equal to n. Either I can say this, or you could say I is less than n plus 1. Both of them means the same thing. But here I'm saying I is less than equal to 1. If you want, you can even write this as your condition. And I'm going to do what? Print I. Is anything else left from my loop? If I have to worry, I've done the initialization, I did condition. What is remaining? Updation. This is very important. If you forgot the updation part, what will happen is it will go into infinite loop. The reason being, or the I value will always be 1, right? And this 1 is always less than or equal to n. That means it's always going to go in infinite loop. So make sure, so in for loop, it is a part of range function. So usually there is very less probability of making a mistake. But in the while loop, you have to make sure to explicitly take care of the updation and initialization part. So be very vigilant when you're trying to write a while loop. All right. You do this, you will get your numbers 1 to whatever n. This is the second part. What was the third question? I did, we did one more question. Third question was to print even numbers, right? Even numbers between 1 to n. How would we do that? What do you think? Again, you'll say, let's say even number starts with 2, correct? So I'm going to say while this I is less than 2n, because if you remember, if it was 1 to 10, we tried to print the number, even number which is less than 10. That means this n was excluded. So that this would be 2, 4, 6 and 8. Okay, so that's why I'm saying I is less than n. Then what I'll do, I'm going to say print I, and I would be now I plus 2. Correct? This is one. Another way we could do is using the test of divisibility, where you could start with what? I equal to 1, while I is again less than n. If I mod 2 equal to 0, then only we would do what? Print I. Correct? But this condition, this I equal to I plus 1 should be there. So either you do this, either you do this, both this remains. If I am starting with 2, then accordingly I'll have my updations. If I'm starting with 1, accordingly I'll have my updations. Understood? Okay. Let's try to just run this, on our compiler and see how it goes. Simple. The first one will have a simple while loop. Okay. So what I'll do is, instead of taking the string high always, I'll again ask the user to give me the string and number of times it wants to repeat. That I can do. Right. So I'm going to say int input, very similar to what we did in the while in the for loop section, right? Enter the value of n. Next is I want to know the string which the user wants to repeat. Now here, if you see, I'm not converting it using an int or float because it's a string, right? And input by default reads whatever you type on the terminal using a string, correct? Now, what we did is I equal to, let's start with I equal to, so where you start, you have to you have to make it run, print for how many number of times? N number of times, right? So I'll say I equal to 1. I'll say while I is, let's say, less than or equal to n, because suppose if it is 4 times, I need to run it for 4 times. Okay. Next I do what? Print I, and now I have to do the updation part, I equal to I plus 1. So now if I run this, let's say enter the value of n, I say I entered 5, so it has 2. Then I'll, let's say, give the word hello. It's gonna run for, okay, why is it saying I? Because I made a mistake. Instead of saying I need to make sure to print it as s. So if I now run this is 5. Let's say the string is hello, so enter hello how many times? 1, 2, 3, 4, 5 times. Okay. If I run it again, give it to run it for 2 times and say the string is hi, it's gonna string this. Okay, very simple, right? It's the same, the logic remains the same, only the way of writing it changes. And the way you terminate the loop here, what is it? While is very focused on the condition, so it is going to run as long as your condition is true. Okay. Another thing was, another question we had seen was to print 1 to n numbers, right? So the earlier thing, just make it I, and I think you are good to go. I do not need a string here. Let me stop here. I don't need a string here, right? Because I need to print numbers from 1 to n, where n is inclusive. So I'm just running this. I say I need to print, let's say, 20 numbers. What will happen? See, 1, 2, 3, 4, 5, 6, 7, 8, 9 till 20. Got this? So this is my this. Now, what is the next part where we had tried to see whether the given number, you have to print only the even numbers, correct? So we said while I equal to 2, correct? I just had here to make one change, which is I plus 2. Now if I have to print the even numbers, so now see, I'm printing even 10. My question was to exclude 10. So what I need to do, just remove this equal to sign in my, and now if I make it 10, so now I will have 2, 4, 6 and 8. Got this? Yeah, the other one you can try on your own, where where had one more way of showed you, right, in the code. Okay, so this is your while loop. Now let's do one last question for while loop. Okay, not just while loop, but for loops, which I would say is, you suppose a given n. Okay, you take this n from the user and I need to print, I want you to print the reverse numbers, okay, starting from n and going till 1. Starting from n and going to 1. So how would you do this? Using for loop and using your while loop. Suppose if n is equal to 2, your answer would be 2 and 1. If your n is equal to 5, your answer should be 5, 4, 3, 2, 1. How would we do this? If you remember from the for loop section, I had spoken about, a negative step. Yeah. Can I use that? So your range function is starting with what? N. Until where should it go? Now when I'm saying, it's a negative -1, means what we have to do, whatever the last value of your sequence is in your range function, that value has to be greater than your n, right? It has to be greater than whatever value you have n, whatever sequence numbers you have, it should be greater than n, correct? So we need to just make sure this is done, and it's -1. And if I do a print I, do you think this will do the job? Yes. Suppose if n is equal to 2, correct? Is 2 greater than 0? Yes. So 2 will be printed on the screen. Next becomes decrement, means becomes 1. Is 1 greater than 0? Yes. That means 1 gets printed on the screen. Now what happens? Again, -1 means 0. Is 0 greater than 0? No. That means this is not printed on the screen and the for loop is terminated. That means this works. Can we do the similar in using a while loop? Yes. What we need to do? We need to have run what? Till your I, let's say if I make I equal to n, right? Till I is what? Greater than, it is greater than 0. Or you could write while I is greater than, or what is it? I is greater than, what you could say, or I is always greater than or equal to 1. Right? You could also say this, right? So one of this, it's both the same thing. Right? I'm saying I is greater than 0. And the next what I have to do is, I'm going to say print I, and my updation would be I minus, -1. Simple. That's all I will do. And I. So now what happens again? N values, suppose if n is equal to 2, will work. How will it work? Will work 2 here, right? Is 2 greater than 0? Yes, that will print 2 on the screen. And now value of 2 becomes 1 here. Now is 1 greater than 0? Yes, we'll print 1. Now after that what becomes? 1 becomes 0. Is 0 greater than 0? No. Correct? That means this will get through while loop, this will get through for loop. This is basically printing the reverse numbers. Let's just quickly code this up. Let's do using for loop for I in range n. So let's take, instead of taking from the user, or let me take it from the user. Just take this part. Okay, for I in range n to, what is it? You want it till, you even want 1, right, included. If we're saying n to 0 -1, right, then you're saying what? Print I. That's all. And if you run this now, and if I have a 10, you will have what? 10, 9, 8 until 1. Got this? If I have to just replace this using what? While loop, I would say I equal to n, my initialization, while I is what? Greater than 0, correct? Then I'm going to say print I, and I'm going to say I equal to I minus 1. Now if I run this, again I give a 10, it's going to give me the same output. Now someone might have a question. Okay, why? What if I do first I equal to I minus 1 and then I do the print? What will happen? You would lose the value of n. N is going to be suppose 10, right? Okay, so what will happen? Is 10 greater than 0? Correct. Then line number 4, you would decrement the value of I. So I becomes 9. Now you're going to print 9. That means though the loop is running for, let's say 10 times, you will have values, right? 9, 8, 7, something like this. Okay, let me run this. If I give the value of 10 here, see what happens. You get 9, 8, 7, 6, 5, 3, 2, 1, 0. Okay, you get 0 also there. Are you getting my point? Because why would you get 0? Because your I is what? 1, correct? Is 1 greater than 0? Correct. Means 1, it is greater. Whenever the value of I is 1, you will enter the loop. But as soon as you enter the loop, you are trying to decrement it and you're printing that value, which is a 0. Okay, so you're printing 9 to 0. This is not what you want. That is why the order also is important. That is also part of your logic. You first want to print it and then you want to, decrement the value. Okay, I hope this is clear, and this ends your loop chapter. Always remember, whether it's a while loop or whether it's a for loop, we need this three parts. What are the three components for a loop? One is your initialization, your updation, and your conditional check. All this is, in the case of a for loop, is obtained through a range function. But in a while loop, only what is taken, condition is there explicitly mentioned as part of the syntax, but updation and your initialization you need to take care of. If you do not take care of these two things, you have a possibility of running into an infinite loop. All right, and I hope you understood the loops chapter. So guys, let's start with a new topic, which is called as jump statements. Okay, so what do you understand by the English word jump? Jump means you are suppose at some one point, you take a jump and move to another point. Correct? This is the starting position, this is the ending position, right? When you take a jump. Similarly, in coding language also, suppose if you're, let's say we are at, we have these lines of code, suppose line 10. You might be at this line, okay? And a jump statement might, cause you to jump, might be somewhere here, might be at line 9 directly. When you do this jump, that means you are kind of ignoring all these lines of execution. Directly from line 3, you are trying to execute now line 10. Or there can be a jump where from line 3, you are trying to go to line 2 again. Right? That means what? You will again execute line 2 and again execute line 3. Understood? So that is what jump statements in programming means. It means from one particular, at your current line of execution, from that line, you're either going forward or you're moving backward based on what kind of jump statement you are using. Okay, did you understand the word? Similar to what we have in real life. Okay, that's why the word jump statements. So we are going to see in Python two different jump statements. One is the break and the other one is continue. Okay, break and continue. So let's first look at break. It's easier as compared to continue. Suppose if I have a loop. Okay, we have seen two loops so far, a for loop and a while loop. Now jump statements work. I mean, there's nothing like that it only works with for loop or only works with while loop. No, jump statement can be used anywhere. Okay, and usually they'll be used mostly in the case of loops, right? In loops, what we have, there is we keep on doing some part of code, right, again and again until some condition is met. Okay, so jump statements might be used in a loop to break a loop. Okay, based on some condition, you want to skip a particular execution and go forward. All right, so here I'm taking example of a for loop. Now let's look at first the break. What does a break do? Suppose if I have for I in range, let's say 1 to 10. Remember, right, the range function from the for loop. Okay, what does this range 1 to 10 means? That means this will go from 1, 2, 3, so on till 9. 10 is always excluded, and because there is no step mentioned, that means by default it is +1. Correct? I is nothing but the loop variable. Instead of I, you can use any other variable of your choice. Right? Now here I'm writing something saying, I'm saying printing the value of I. Okay, and then I'm saying if, writing a if condition also. So inside your for loop you can have a if also. So if I mod 3 equal to 0, I'm saying break. Okay, what am I doing? If I mod 3 equal to 0, then what does I mod 3 equal to 0 mean? When would this condition be true? What does I mod 3 equal to 0 mean? This means that whenever you divide a number with 3, if the remainder is 0, okay, what is the mod function? The remainder function or the mod function? Okay, that is what it means. That means if a number is completely divisible by 3, right? So if I have 9, if a number is completely divisible by 3, then the remainder is always 0. Correct? So by using this condition can be used to check whether a given number I is completely divisible or is completely divisible by 3. Correct? Is a completely divisible by 3. Then what happens if I is a completely divisible by 3? Then what I have to do is I have to do a break. Now let's see what do I mean by what happens by break. Let's have a look. Let me just clear this part. Did you understand this mod thing? Yeah, why this is completely divisible? If I give you a little bit more explanation, suppose if I have 9 and I have 3. What will be on 3? 3s are 9. What is the remainder? 0. Correct? But that means if I do 9 mod 3, what will my answer be? 0. Remember from the arithmetic operators chapter. Correct? But if I take a number which is not, completely divisible by 3, if I take number like this, what will happen? You'll say 3 3s are 9. What is the remainder? 1. Before a decimal point, do you have a 0? Is it possible to get a 0? No, because 1 is less than 3. So unless and I do not take a decimal point, I won't be able to completely divide further. Correct? So this, when I do 10 mod 3, what will your answer be? 1. What is saying? I mod 3 equal to 0. So can I be sure whenever a number is completely divisible by 3, that mod of that will always be 0 if I do it with mod with 3. Correct? That means this I can use as test of divisibility when you're trying to write a code. Understood about this? Alright, fair enough. Let's start. So what it's saying is, see, the I values will be what? 1, 2, 3, 4, 5, 6, 7, 8 and 9. You won't include 10, correct? Because 10 is excluded, right? The last one is excluded. Now it's saying where I in range. Let's say I becomes is 1. For I equal to what is going to say print I. You will print I. So on your monitor, let's say this is the output, you would print I, right? Then what you will check is 1 mod 3 equal to 0. No. 1 mod 3. 1 is what? 1 is a number less than 3. Can you do anything with it? No. Unless and until you don't take a decimal point. Correct? That means that's why numbers which are less than 3 will always be as it is. So 1 mod 3 would be 1. Correct? Is it equal to 0? No. So that means you will not go inside the if statement. Right? Again, now next what happens? It increment happens and you are here. I equal to 2. You will print I. Now, is 2 mod 3 equal to 0? No. What is 2 mod 3? Again, 2 is less than 3. That means the value would be 2. Correct? So 2 mod 3 would be 2. Right? So is it equal to 0? No. That means your if condition is not satisfied. Therefore, you do not go inside the block. Right? Now here you are here. I equal to 3. Print 3. Yes. Now, is 3 mod 3 equal to 0? Yes, it is. How would I say 3 mod 3 is equal to 0? If I take, let me put here, if I take a 3 here, divide by 3, right? So 3 ones are 3, remainder is 0. Yes, that's what it's asking. So is it true? When I come inside, what is it saying? Break. What does break do is, break will always terminate the current loop. What I'm saying, break will always terminate the current loop and you will be moved outside the the current loop. What is the current loop right now? We have the for loop. Which for loop? This for loop, which is going a range from 1 to 10. The moment I get a break, what is the current loop I am in? Is if conditional loop? No. What is the loop I am in? This for loop, right? That means this loop will be terminated. Terminated means what? I will come out of this loop and let's say out of this loop if I have a end, right? So my line of execution will be here. If this break was not there, what will happen? After I equal to 3, I would go to I equal to 4. Agreed? No, because it is a loop. But because it is a break will always terminate the loop. Terminate means what? End the loop. End which loop? The current loop which you are in. So it is always for a loop, it will end the current loop. What loop you are in? You are in this particular for loop. Instead of for, if it was a while, same thing. It's while is also a form of loop, right? We have two loops, correct? So break will always terminate the current loop you are in and it will get you out of this. So out of this for loop, what is it? Suppose there's a print statement. So now this line will get executed. If there is no print statement, now what will happen? Your program execution is done. So what is the output for this particular part of code? Output would be, it will print what all values? It will print 1, 2 and 3. Right? It will not print anything 4, 5 and nothing because after 3, the 3 mod 3 is equal to 0 and after that in that block there was break. That's why we came out of the loop. Is it clear? Did you all understand? Now let us, let us take one more thing. Suppose if I did, instead of for, if I did while, okay, let's say while I is less than 10. Right? And I have initialized it. In the case of while, you have to initialize it before, right? Give some value, correct? Otherwise, it will give you an error that it has not found the label, right? It has not found the label. So when I say I equal to, let's say I is starting from 1, I'm saying this, okay? Here I'm going to put a value here, print I, yeah? And I'm putting if I mod 2 is equal to 0, then I'm saying you have to do a break. This is my lines of code. Now what will happen when I is equal to 1? I'll print I, correct. Is 1 mod 2 equal to 0? No. Again, 1 is less than 2. That means it is not equal to, that means the value should be 1 and 1 is not equal to 0. Correct? Now what happens? You have to again give a increment sign on. So I'll write here increment I equal to I plus 1. Okay. Now, sorry, before that, let me just add it here. Yeah, I'm going to say I equal to I plus 1. Now the increment step. If I do not increment, what happens? I is always 1 and 1 is always less than 10. That means I have not given any way to terminate the loop. So it will always run. It keep on running. That is called an infinite loop. It will keep on running on an infinite loop. Okay, understood? So now what is happening is, let's say now you have one I becomes, now from 1 it become value as 2. Correct? Is 2 less than 10? Yes. So you will print 2. Correct. Now is 2 mod 2 equal to 0? Yes. Similar to 3 mod 3 is equal to 0. That is 2 mod 2 is also, that means the number is divisible by itself, right? So when it is divisible, you're going to say break. What does break do? Break will always terminate the current loop. Okay, and you will come out of the current loop. What is the current loop you are in? You are in the current loop of while. Correct? That means this will not, so after this, okay, your execution control will come here outside this loop. Okay, this is inside the loop, this is entire inside the loop, right? That means I equal to I plus 1 also will not execute. From here directly will come outside the loop. Whatever the statements are here will be executed. That means what have you printed on the screen? 1 and 2 only. Understood what we are going to do here? Yeah. So this is a while loop. Let's say along with this while, suppose here if I had a one more for loop here. Suppose I had a for loop here. I had a for loop here which said, you know, for say j in range, let's say 1 to 10. Okay, and I'm going to print the value of j. Okay. Suppose this is the case. Now tell me, when you say break here, this break is going to terminate this while loop. It's not going to do anything with this for loop. So it's always for the, you are inside which loop? This loop. Okay. So it's going to be the immediate one. Suppose we had something like this. Suppose we had a for loop. Okay. And one more for loop was there. And suppose there was a break here. Now this break is going to affect which one? This for loop. Let's say for one, for loop 2. This break is going to terminate the for loop 2, not the outer one. Okay, so one break is going to affect only one for loop, and that is the one it is currently inside. Understood? There won't be any issues for the outer for loop. Understood? So what does break do? The moment you you get a break, you terminate the loop. Nothing is executed after that, and you come outside the outside your loop, whether it's a for loop or whether it's a while loop. Is this clear? So we did two things, right? We understood what a jump statement is. We understood what a what a break is, correct? And what the third thing we also understood, if you have to test something for divisibility, right? So we could use this mod function, right? So the remainder, suppose if you test divisibility, let's say with 8, okay, of a number. So if whatever the number mod 8, if it is equal to 0, that means this a is divisible by 8, right? So you can use this part of the code. Okay, you put this in a if condition and your code is ready. Understood this part? So this is the break part. Let us try to see how it actually works in our Python interpreter. Let me just, yeah. So the same thing we're going to try to do. Okay, all I'm going to do is I'm going to say write a for loop, simple. Okay, just trying to demonstrate the break step. Okay, so I'm saying for I in range, let's say 1 to 10. Okay, so we said first let me print it. So I'm going to say print I. Then I'm going to see, look at, I'm maintaining the indentation. Always take care of indentation when you're trying to code in Python. Okay, then my condition is if I mod, let me give space just for visibility. If I mod 3 is equal to 0, I'm saying break. Okay, then after this, let's say I have here, let's say after break, for example, I'm just saying print break. Okay, just for to give you an idea. This will never get printed, but I'll say okay, let's see now what should be printed on the screen. 1 and 2 and 3. Okay, this break, do you think will get printed? No. Why? Because what I said, the moment the computer sees break, it is going to come out. It is going to transfer the control from line number 4 to line number 6. So that's why 1, 2, 3 followed by end would be printed. This line number 5 will never get printed. Okay, because it is inside the if condition and it is out immediately after break. Okay, so let's run this. See, you see 1, 2, 3 end. This break is never getting printed. But if I want to print break, what will you do? you would try to just take this Control X and you're gonna just put it here. Now this will print yes. Why? Because before hitting break, okay, I am printing the word break. So what is happening whenever your a number is divisible, completely divisible by 3, right? You come inside the if condition. What is the first thing you will see? You will see print break. So computer will first print the number break, print the word break, and then it is going to see the break command. Now break command means it is going to transfer the control, the execution control from line number 5 to line number 6. Understood? So suppose if I now run this, now I have 1, 2, 3, break and end. Right? This is with the while loop. Similarly, let's look for the, sorry, this is with the for loops. Let's look with the while loop also. So while loop, let's say I give a value here. Let's do the same thing. No? Instead of this, I equal to start with 1. Right? We need to initialize. I'm saying while I is less than 10. Correct? We had a range from 1 to 10. So you're also saying I to less than 10. Then I'm saying print I. Correct? Then we're doing if. What is it? If I mod 3 equal to 0. Then what I'm saying break. Okay. Then I'm writing your print n just to. Yeah, now if I run this, now what is happening? See, it's got an infinite loop. Do you see this? It's got an infinite loop. What is the reason? Because I will always be less than 10. It's always in a loop. But there should be some way I can break this. There should be some way I have to increment it also. No? Otherwise, this loop will never terminate. Got it? So let me just stop this. Let me run this. Is it not? Let me just, because it is gone in an infinite loop, no? Let me just refresh the browser. Now if I try to run this, see, it's working. So let's see, even if you run into a problem like this, try to refresh the browser and it will work. Okay, because it's got an infinite loop, no? That's fine. So what will happen now? I equal to 1, while I is less than 10, print I. Okay, so if I mod 3, now let's see what happens is, now this line number 6, right? If you look at it, 1, 2, 3, okay, that gets printed. Now whenever the moment is 3, when it goes inside the if condition, it sees break, right? So from line number 5 it comes to directly from line number 7. Understood? Got this? If you want to see that after 3 this I value never gets incremented, I will just try to print the value here. What I'm trying to say is, after at the value of I would always be at 3. The value of I would never be 4. The reason being, because this line number 6 will never get executed once it is inside the if block, because it is break. Let me just show you what I'm trying to say. See, the value of I is still 3. Okay, so if you had a doubt that okay, after this break, okay, this I equal to I plus 1 might get executed. No, it will not get executed. Once it sees a break, it just comes out of the current loop. All right, and this I equal to I plus 1 is also inside a loop only, right? It is inside loop. So that's why it will not get executed, because from line number 5 directly the control goes to line number 7. So that's why if you see this, the I value is 3. That line is. And if you want to make it more this, I could say the value of I is, and if I put this, now you can see it's 1, 2, 3 and this. Got this? How it is working? So break will just make you terminate from a loop, whether it's a for loop or a while loop, and it will move to the next part. Okay, so that is all about the break statement. The another one while given introduction of the jump statements, another one which I spoke about was continue. Break we have done, correct? Now let's talk about continue. Okay, continue. So let's take an example and understand. Suppose, now what I said, see what I told you when I was explaining jump statement, if you are at this line of execution, might be you go here or might be you go back. Correct? You can go anywhere. It's jumping from your, instead of going linear, okay, after one line you go to the next line, it's going to some other lines, okay, which is non-linear. Let's look where does while go. Sorry, where does this continue statement makes your control go of execution. Okay. Suppose if I have something like this, for I in the range 1 to 10, okay, I'm saying print I if I mod 3 is equal to 0, okay. What am I saying is, I'm saying continue. Earlier what we had, we wrote a similar code, right? Break. Instead of continue, we had break. Correct? Now let's see what is the difference this is going to make. So now what happens is, it's going to print. What do you think it's going to print? It's going to print the value I. Okay, so I is going to go from, again, you know, right? You are very smart now. It goes from 1 to 9. 10 will not be included. Okay, so it will be 1, 2, so on till 9. So it's going to print I, that is 1. Okay, is 1 mod equal to 3? 1 mod 3 equal to 0? No. So that means if condition is not executed. So I becomes 2. For 3, what happens? It will print 3. Correct? But now what happens? This is true. This condition is true. Now it is going to go to continue. Now continue means what? Continue is, see in the loop, when we studied loops, we said loop is made up of 3 parts. One is initialization of your loop variable. Correct? The second part was the turn condition. I mean some condition. Until some condition is true, you're going to keep on executing this loop. And the last part was updation. Remember where you update the loop variable. In for loop, usually the range function takes care of all this. But in the while loop, we have seen we have to do initialization and updation separately. And even condition is given. Correct? Now, this continue is related to the updation part. So what happens is, the moment you say continue, okay, what happens is it's going to go directly to this part, the updation part. It's going to go directly to the updation part. So if I have a print continue here, suppose, let's say, okay, let me say here print, okay, and I'm going to say outside, you know, if, okay. So what happens is, after this one, this outside if will be printed here, right? Outside if. Then there'll be a 2, then there'll be then again there'll be outside if. Okay. Then there'll be a 3. Okay. Alright. Now what is happening is, the moment it goes continue, it's gonna go here. Right? That means for 3 you will not see outside if, because from here the control goes directly to your where part, the updation part of the loop. In the for loop, where the updation is taking place in the range part. Okay, so now your value becomes 4. Right, updation is 4. That means whatever is there out after your continue is not getting executed. Understood? In break, what was happening? In break, what the thing was that we will come out of the loop directly. You just break the loop, terminate the loop. But in continue, do not terminate the loop. You just go to the next updation part. You directly go to the updation part. So whatever is there after continue is missed. Okay, let's try to run this code. I think that will be make more easier to understand. And you know, we'll see. So instead of this, I have a for loop. I'm saying for I in range 1 to 10. Okay, I'm printing I. Then I'm saying if I mod 3 equal to 0. Okay, I'm saying continue. Then I'm saying, see, this line what I'm trying to print, right? Outside it, it's outside it. Okay, even the statement says so. So it's outside if. Okay, and as usual, let me just say print time, so that we know that we are done. Okay, so if I run this now, see, it's saying 1 outside if, 2. After 3, you see there is no outside if. Ideally, it should print, right? But it is not getting printed. Why? Because after the line number 4, the control goes where? Control goes to line number 1. At what part of line number 1? The updation part. So updation means what? After 3, it should become 4. Now, is this 4 less than 10? Yes. That's why it will go inside. It will print 4. Then, you know, see, now for how many times, you know, we are getting this if condition is getting true. If condition is true for all the values which are completely divisible by 3. That means it's going to work for 3 and it's going to work for which one? 6 also, right? See, 6 mod 3 is also 0. See, after 6 also you do not have outside if, right? After 9 also, 9 also you do not have outside. That also makes sense because see, after 9 is anyways, after 9 you have, it is 10 also. 10 is never get included, and also it satisfies that condition also. Okay, did you understand how it is working? Okay, so continue what it does, instead of taking you outside the loop, continue will make you take the control to the updation part of the loop. Okay, similarly you have for loop, similar thing it will work for while loop also. We saw for break, right? So how would you do for while loop? If I have to change this for while loop, what change I would do? I'll have to first initialize. Let me, I'm starting with this. Instead of this, what I have to write a condition. I would say while I is less than 10. Correct? Do anything else I have to do here? Yes. What has to be done? I have to make sure that the value of I is updated. So I could say I plus 1. You could write I plus 1 at line number 6. That is also fine. It's not going to make a much change. And then print n. So if I'm going to run this, okay, something went wrong. What is it? It again went for infinite loop. Did it go for infinite loop? So what is the issue? What do you think? Where did we go wrong? We said we did here, right? Print I, right? Then we did if I mod 3 is equal, then we said continue. Something went wrong. What went wrong? What went wrong? So here something went wrong, right? So what did go wrong? So you're in while in this in your while loop, okay, in your while loop, there is no updation part. Where it will go? Where will this continue go? That is important, right? In while loop, there is no updation part. So where that will go, that we have to see. Okay, so that means this is not working. We'll see in the next lecture. All right. Okay, so remember, let's welcome back to the next lecture, right? So it's a continuation of the jump statements, right? So you remember we had done a big blunder, and we have got this infinite loop. You see it's 333, right? It's still not even, usually if it is green, right, once it's stopped, so it's still running infinite loop. So what happened? See, continue, what I told you all, that whatever continue will take your control of execution to the updation part, right? In for loop, yes, it works because updation is there in the range function. In the while loop, is there any updation part as such? Yes, it is, but you have to always manually put in some value, correct? So in continue statement, whenever it finds continue inside a while loop, it takes the control to the start of the loop. That means what it takes from line number 5, the control goes to line number 2. Do you understand? That means my updation has to be before this, somewhere here. So let's say instead of 1, I'm going to say put a value as mine. Let's start with 0. So now what will happen? Is 0 less than 10? Yes. You're going to print I. Yes. What will you print the value of I? Instead of printing here, I'm going to make it as, okay. The reason I'm doing it, I'm trying to generate a similar output as I generated for the for loop. Okay. So let me now just refresh this because it's already gone in, infinite loop. That means I have to refresh. Okay. For the code. Now let's first run this and I'll explain. See, it's working fine. We got the similar output for the for loop, but you see the code is a little bit different. Okay, let me explain you that what has happened here. See, for the while loop, the whenever you find a continue, the control from line number 6 would go to line number 2, which is the start of the while loop. For loop also, it actually, if you look at it, for loop also, the control goes to the range function. Where is the range function? Is the starting of your for loop, right? So that means in both the cases, the condition goes to the start of the loop when it is a continue, right? Now what happened is I want to generate from 1, 2, 3. That is what I wanted to generate. So if I start with 0 and if I print I equal to I plus 1, so you're going to print 1, correct? Print I is done. Then whenever my value is, whenever the number is divisible by 3, I'm going to skip printing what? Outside it, right? And my flow is going to continue until when my value is less than 10. In the earlier thing where you are getting this, infinite loop, the reason you are getting an infinite loop, what was happening this is I equal to I plus 1. This was after my continue, it was here, correct? Because of this, what was happening? See, whenever a number is divisible by 3, what is the number? 3, right? So 3 mod 3, correct? Whenever a number is divisible by 3, which was 3 when we were finding out, this control was going back to which number? To line number 2. Now again, is 3 less than 10? Yes. Again, what you're going to do, you're going to print the value of 3. Again, what? 3 is divisible with itself, right? Again, because it is continue, again it is going to go back to the start of the loop. You're getting my point? So this is going to keep on happening, and this value of I is always 3. Why is always 3? Because this increment part is out after the continue, right? After it has hit continue. But will it ever go to that part? No, because once you hit continue, the control is taken, go to the starting of the while loop. Right now, because of this, it went into infinite loop after the value of I equal to 3 was reached. Okay, so this was the incorrect thing in our code. That is why what I did to avoid that, I removed from here. I made it a start of this. Okay, Now I also wanted to print 1. That's why what I did, I changed the value, initial value, the initialization of I to 0. And when I come inside the loop, okay, what I'm doing, I'm immediately doing I equal to I plus 1 and I'm printing the value of 1. Okay, that's what I wanted to print first. Okay, now let's see, whenever you, similarly you did for 2, 2 also worked fine, no issues. When you see, when it comes to 3, now what happens, see, 3 is a divisible by itself, yes, that's why 3 mod 3 is equal to 0, right? Now you hit continue. Now this continue will take you where? To line number 2, correct? Now this, what is the value of I value is 3. Is 3 less than 10? Yes, 3 is less than 10. Okay, but now what happens is you are immediately incrementing it, which is what, I becomes now 4, and you'll be printing the value of 4. See, from here you see I equal to 4. You get this? This is I equal to 4. Now this means, now again, now this, what is a, for if condition, what you are going to see is 4 mod 3 equal to 0. No, that means you have broken the loop. You have broken the infinite loop. Why? Because the moment it goes to this condition at line number 2, you're incrementing it directly. So be very careful when you're trying to use this jump statements, especially continue. Okay, in while loop and for, there's a slight difference. In while loop, you have to take care of the initialization part. So if you're using jump statements, make sure to do not make a mistake. That's the reason, I made it by, what we do is, when you have to convert from for to while, we'll do it there, only some code changes, right? But we did that, right, in the last lecture, and we saw we ran into an infinite loop. It's very important to think it through and make sure to bear in mind that the continue will take you to the starting of the while loop. So ensure that the initialization or the updation part of your loop variable is taking place. Okay, so after continue, if it is going to the start of the loop, make sure this your updation has to be between the start and continue. You're getting my point? Somewhere has to be there, otherwise you're going to run into an infinite loop. If you recall, the infinite loop was there because the updation part, which is line number 3, was after the continue statement. Got this? So it works a similar way. So we have seen both the cases. One was break and the another one was continue. If I just replace this with break, what will happen? What will happen? Just 1, 2, 3. That's it. It will not print the further lines, right? So break will terminate the loop and continue will just, transfer the control of execution to the start of your loop. Okay, that makes more sense to say. I hope you have understood this jump statements. All right. Last topic, in this series would be functions. Okay, so congratulations, making it till the end. So functions would be the last topic, and then we would go ahead and do a small project based on whatever we have learned about Python, right? The basic Python programming. We will try to do a project, a small problem statement we'll try to code. Okay, so that would be the last part. Now, let's look at functions. If, I hope first few of them, I think most of them would be, if you guys are attending, like seriously paying attention to the lectures, I think the word function must remember somewhere you must have heard this function. I think the first or second lecture, we spoke about functions. Remember? Could you recall? Remember the print function was the first function we did. Then we did something called as input function, right? So we spoke about these two functions, which, what was a function? If you remember, a function was something, yeah, where it is basically you're telling the computer, just you need to do a particular task without telling him how to do it. Okay. For example, if I'm saying print, so computer knows that when I use a print function, I'm telling the computer print something or display something on the screen, and I just provide what needs to be displayed on the screen. I do not tell the computer how he has to display on the screen, because the computer knows how to do it. Similar for input, the moment I say input, when I use an input function, computer knows that he has to read something, he or she has to read something from the, from your terminal, yeah, whatever the user gives, he has to read something. Okay, but I do not tell the computer how to do it, so he knows how to do the job. Correct? So functions are something, okay, so there are some in a pre-written piece of code, okay, where you just call the function. All right, you just pass, whatever input needs to be passed, and the job is done for you. Correct? So in functions, what we have seen, print and input, they are called as system or system defined, okay, system defined functions, or they're called as inbuilt functions. Inbuilt functions means something which whoever has developed this Python language, right? Somebody must have developed or created a Python language. So that person or that committee has, created this functions. For examples, what we have is seen print, we have seen input. Okay, so they make our job easier, correct? You just call them and you just tell what has to be done. For example, what they, for example, if you tell what has to be printed, but how to do it, that how is already done. So basically, the how is already been triggered, already been there inside that piece of code, and then you give a name to that part. All right. Now, why do you think this was done? Why do you think in the first place this print or input was written? The reason being, no matter who uses this Python language. For example, you and as a beginner in the coding world, okay, we wants to learn Python. You will also use the print function or the input function, correct? And somebody, let's say a data scientist, who usually uses Python language, to write complex models and, build complex machine learning models, will also use print and input functions, correct? That means somebody who's a beginner and somebody who's very professional and doing in a high tech would also be requiring some functionalities, okay, which are common in both the scenarios. For example, no matter what what kind of person you are, I mean, at the level beginner level or at the high level, okay, of usage of Python language, you might need to print something on the screen, correct? So instead of let's say you as a student have to write a, let's say, a print function, suppose, I'm not sure, but let's say print function, let's say, is of some 10 lines. So you as a student, whenever has to, print something on the screen, you might have to write this 10 lines of code. Okay, a computer scientist who's working on complex machine learning models will have to again write those 10 lines of code, right? So what is happening? Everybody is writing this 10 lines of code all the time whenever they have to use, and these are some common functionalities which everybody is going to use, correct? Most of the people, like 90% of people, are going to use. So what these people who develop Python said that, so such repetitive lines of code or such repetitive logic, okay, such repetitive task, okay, instead of making the user write it, let's put that task, put those 10 lines into one block of code, and let's name it something as print. So this is what they call as function. That means whatever this 10, so whenever I say print, this 10 lines of code gets executed. So whenever you say in your code, in your normal program, in your Python program, you say print, what happens is this 10 lines of code, okay, this 10 lines of code is executed, okay, with whatever input you give to the function. So function helps us, okay, to remove the repetition of the lines of code in your actual program, correct? Now what has this done is that now you as a user, you do not have to worry about how to write those 10 lines of code. You just need to call this function print, and this 10 lines of code will take care of printing it onto the screen, correct? So such common functionalities, okay, which everybody use, the Python has made your life easier by writing this common function, writing this code of common functionalities already and giving you a name to it. So basically it's like giving a name to a piece of functionality. It's a functionality. What does functionality do? This 10 lines of code, this 10 lines of code will basically print something onto the screen, correct? Now this functionality is required by everybody, and I'm writing this code, 10 lines of code suppose, and I'm naming this 10 lines of code as print. So the moment I just need to remember print, correct? So the moment I say print, I can just, this 10 lines of code gets executed for me. All right, so it's like a label. So if you remember, variable was like a label given to a memory location. Similarly, if I have to say on similar lines what function is like a label which is given to a piece of functionality or a lines of code, a block of lines of code, okay, which does a particular task. What it does, finally it does accomplish a particular task. Here the task is to print something or display something on the computer screen. All right, now what is when I say system define or inbuilt functions are nothing but those functions which Python, whoever created Python language, they have created those functions. Example, print and input. There are many more, but the ones which we have seen in this course is print and input, correct? So those are common. So that means whenever you pick up any version of Python, right, here we're doing Python 3, but any version of Python, you would definitely have this inbuilt of function. That means some common task, okay, the code for this common task, you do not have to worry about it. Those are already written by the Python designers or developers. You just need to remember how to use it. Okay, now how do you have system defined? Similarly, you have user defined functions. Now let's say after we have learned Python, the basics of Python, and you go ahead and let's say you have to develop a game. Okay. Okay. So now what will happen? You would write hundreds or thousands lines of code, right? Obviously, I mean, if you're creating a game, obviously it's not going to be just one, 10-line code. Definitely not. It's going to be more than 100 lines of code. Correct. Now let's say in this line, in this 100 lines of code, some functionality is repeating. For example, you have a character might be in a game. I'm just drawing his back. Just say suppose this is a person, this is a man, and there's some character in the this, and every time you are no matter, let's say you have some 10 levels in your game. Okay, at every level you would require this character, let's say, to jump from whatever your starting position to, suppose here, to some end position, right? That means suppose if I pass 10 meters, might be your this will move from here and will be located here. It means jumping from here to here. This is the function. Let's say this is a jump functionality. Now this jump functionality will be required in every level, right? Every level the player can jump. Now, instead of writing this jump functionality for all the levels, what you could do, if you know something, what is something as function exists, this concept exists, you would write, suppose this jump functionality, to implement this jump functionality, we need 20 lines of code. LOC means 20 lines of code. So I would write this 20 lines of code only once and convert this into a function. Correct? I would convert this into a function. The only thing I need to pass is what is your starting and how many meters you need to jump. How many meters you need to jump, right? Suppose the starting position was, let's say, he is located at say 0,0, and now he has to jump, let's say, say 10 meters, and let's say left. Okay, I just need to provide directions, but how to take it from here to here, that line of code is already written here. Okay, and if I just give a label to it, which is a function name, right, I can reuse this functionality in all my 10 levels. That means I just implement this jump functionality only once in my code. Okay, and I'm reusing it in all my levels. Did you understand how it is making your life easier? So functions does that. Okay, so where you have a piece of functionality which can be used again and again, right? Only thing you need to do is just input changes to it. Then you can just choose to write that piece of code into what we call as functions. All right, it's the first main important reason why we have the concept of functions, and this concept of function is there in each and every object oriented language. Okay, forget object oriented. In most of the programming languages you will have this functions concept. Okay, it's the first point why we have this function concept. Second thing is, it also makes your code cleaner. Okay, for example, you're writing some, let's say you're in level 1 and you're writing some code. You just, instead of writing those 20 lines of code, I'm just saying jump. Okay, and then you have these lines of code. It's very easy, no? Suppose, let's say there is a code here to let's say run, then there's a code here to jump. So it's easy to read through the code, right? Okay, I know this. Now there'll be a jump. After a run, the person should do a jump, right? That means there'll be some line of code. I don't really need to go into the details of how jump has to be done. Okay, so it becomes, your code becomes easier to read for the other people and also for yourself. If you come revisit your code, might be after a year or two, it's still easier to understand. All right, so that's why the second reason why we have functions. I hope it is clear. Okay, so we have two kinds. One is your system build. System build is coming by the people who have created Python by default, and the other one is you as a developer. When you're trying to code in Python, you can also create functions. Okay, now having said that, like we know, right, there'll be a syntax, right, basically grammar for every concept we do, so that computer understands what we're trying to communicate. Okay, similarly for functions, if you have to define a piece of code as function, okay, then there's a syntax which you need to follow. So the syntax starts like this: def. The word def, DEF, stands for definition. Okay, so definition, then you give a function name. Now your function name can be anything. You can follow the same rules as you have for the variable rules. Well, you can follow the same rules. Then you would have something called as parameters. What am I saying? Parameters. In simple terms, is nothing but the input to the function. Remember when we spoke about what a program is, we also spoke about input, right? Without input, a program doesn't make sense. Similarly, here also, if you are going to execute a block of code or a functionality again and again, the reason you're doing it, because it can be called more than once, right? So then it obviously makes sense that whenever you're calling again and again, might be the input is going to change each time you call it, correct? So it's better to have some input for the function. So that's the input. So whatever your code, whatever logic you're going to write inside this function, right, it's going to operate for that particular input you pass here. Okay, so not every function will have an input, but some of the functions will, most of the functions will have input. Okay, so that's why we have this bracket where you have comma separated parameters like this. So if I say parameter PA1, comma PA2 and so on, you can have any number of parameters. Okay, you may or may not have, right? Then to say that it is a start of a function block, we have like this. Very similar to your if block, right? If else also, this is how we start. We denote that the block has been started, right? So this is a function. Now here you will write whatever your logic is, whatever lines of code you want to execute. Understood so far? Yeah, is it clear? Right? And then usually we will have a return statement. Okay, we'll have a return statement. So what does this do? Let's look at that. Suppose I am writing a program here. Let's say I've taken an input, might be okay, I think just take this down first, maybe like the definite, I mean how the syntax is, and we will look at an example and see how things are working for us. Okay, I hope this is at least clear. There's a definition, the function name, and you can have this definition written anywhere. Okay, so one of the example which I'm going to look at is finding the area of a square. So I hope you all remember we had done a program, I think in the second or third lecture, where we had found the area of a square. Okay, we had taken the input A and B from the user, right? Sorry, only A we had taken because it's a square, right? We just require one, which is side from the user, and we calculated area equal to side into side. Now I want to write a function. Okay, instead of doing like this, I want to write a function and then call the function. Okay, we'll see how it is. That means we just saw right now what a function is. We saw how to define a function, correct? Now we're going to look into, through an example, the other important things about function. If you have a function, you should also know how to call the function, no? As per your needs. So we're going to look at that. Okay, so now what we do is, let's say I'm going to say, let's write this function only. I'm going to say def, right? And then I write a function name as area of a square. I can give any name, correct? Now, what do you think the input would be? The input would be the side, right? So I'm going to say here side. All right. Then I'm saying area equal to side into side. And I'm saying return area. So now what has happened? I've defined a function named area of a square. So whenever I mention area square, then computer knows that this 2 lines of code needs to be executed. Did you get that? Oh, fair enough. Now let's come to the part here when I'm taking the side. So I'm going to take from the user, let's say int input. I know you know this part. This is where you will give your message saying please enter the side of a square. Agreed? Now I need to call this function to get the value. Okay, let's say my value is, let's say I'm going to say result equal to, and I'm going to call. Look at the way I'm calling the function. This is what I'm doing. I'm doing a call to the function. Which function? Area square. So I'm going to write the name of the function, area square. So how a function is called? A function is called using the name of the function. What is the name of the function? Area square. Now I need to pass. Is this function expecting some input value? Yes. What is the input? It expects one parameter, which is a side. So in my case, I'm passing the value as A. Okay. Then let me just write here print. Let us see what happens. Be very, just listen to this very thoroughly. Okay, what I'm saying here, I have defined my function. Function definition is done. Here I have taken input. So let's say in my memory, let's say the user has entered the value as 10. Assume. Now what I'm doing in this line I'm trying to call the function. What is it doing? Area square. Now let us understand why this area, why I'm saying result equal to area square. What is happening? Let's understand. The moment it says this, what happens is the control. Okay, what control? Control of execution. I hope you remember the word control of execution from the jump statements. Okay, so now what happens is from here, if you let me take a different color. Okay, from here the control of execution goes to this. Why will go to this? Because that is the definition of my function. So from here the control of execution goes here. What is the value I've passed here? A. A value is what? 10. So now this 10 also, so side becomes 10. Why? Because A is here, this. So this is your value put here A here, right? So this A will be reflect, this A value will be given to side. Okay? Okay, did you understand this? This whatever you give here will be given to side. Alright? Now, it will do this execution. What is the execution now? Area. Area is what? 10 into 10. What is 10 into 10? Is 100, right? It is saying return. What is it saying? Return. Now what happens is after your this is done, return is going to take this value. Okay, from here now, the execution is coming back here, where it is coming back here. And when it is coming back, it is getting along with it the value of area. What is the value of area? 100. That means 100 is coming back. If it is coming back, it's a number, right? It has to be stored in some variable. Now that is why, because this function is returning a value. It is returning a value. What value it is returning? 100. Now this needs to be stored or captured, right? That is why I'm saying equal to this value 100 goes to result here. Are you? So now in my memory, I'll have one more this result where I'll have. Are you understanding? Let me explain that again. Let me tell you the numbering. First, what happens is there's a call to the function. What is the call? This number one. This is what call to the function. What is the function we have? Area square. Okay, call to the function along with whatever input you have given to the function. Okay, along with your input. If there is an input, yes, along with input. Correct. What is the input here? 10. Now from here it goes here. Okay, the value side gets 10. Whatever execution is done here. Now what happens is return. Return means what? Now you have to, your function execution is done. Whatever value is there, this value is what? 100. That needs to return to the caller. Okay, who is my caller? This person is my caller. Where is my caller? Here. Now whatever value I have returned here and 100, now that has to be getting what? That needs to be assigned to my variable, right? So whoever has called me, what return is, return means I have to go back to from the point from where I was called. Where I was called from here. So I'm going back here. When I'm going back, what if there is some variable here? I'm going to take that value along with me. I have to return that value to my caller. Are you getting my point? You're from this is from point from where I was being called. So I'm going to take this value 100 to the point where I was called. I was called here. Now I have a value 100 and I need to store this value to computer's memory. Now to store something in a computer's memory, I need to have a variable. That is why, because we know that's going to return a value, we have assigned it to. This is an assignment operator, right? So now this 100 gets assigned to the variable result. So now in my memory, I would have a variable with value 100 assigned. So that's why when I print this, my value would be 100 on the computer side. Getting my point? This is the function, correct? Now, how is this function useful? At the moment I change something here, right? I can send, say, instead of 10, I can send another value of -2. It will work, yes, because all I'm doing is this function will always remain the same. This is a block of code which has the logic of to calculate the area of a square. Understood? Did you understand how it is working? The return statement will always take whatever value. If there is some value to be returned, we'll take that value and go back to the point from where it was being called, from where the function was being called. Okay, now because if you need to store the value, whatever the function has returning, then you need to assign it to a variable. Okay, understood this part? This is how a function is called. This is how function works. Okay, understood? Now suppose instead of, now let's try to code this up and let's see how is it really does what I'm trying to tell you. Okay, let's see in practical. It's the same one. Okay, we're gonna first define the function. So instead of saying, let's say I'm gonna say define, instead of saying area square, let's say I have a name, compute area of a square. You can give any name you like as long as you are following the rules of the variable naming, right? Same rules will be followed for functions also. Okay, so I'm saying define compute area of a square. Okay, I need if you do not have input, it's okay, then you cannot put. But in my case, I need to give an input because I want that particular function, particular block of code to work for a particular specific input. So in my case, this variable name also you can give anything. My variable name is side equal side. Okay, you can, instead of giving side, you can even give a, that is good. Now I'm going to say area equal to side into side. For this, then I'm saying return area. Okay, so my function definition is done. Now what I'm doing is I'm going to take an input from the user. I'm saying int input enter side of a square. All right. After that, I'm going to make a call to the function. So I'm going to have a variable because I know this function is going to return a value to me. I'm going to say result equal to compute area of a square. If I make mistake in the function name, then I'm going to get an error because it's not going to find any label like that in the memory, correct? So I'm going to pass the value a, right? And what I have to do, I have to print the result. Okay, let's run this. So let's say we give the same value 10. Did you understand? Now certain things I wanted to show you. Suppose instead of, now see what this is going to return a value, correct? Yeah. Suppose if I do not do this, what do you think will happen? And let me run this. Same value I'll get. It's not even giving me error. Reason being, see, you called the function returned a value. Whatever return statement is there in line number 3, what happens is when the moment it sees return, it will take the value, whatever value is there in the variable area, and come back to line number 6, correct? Now line number 6, it got the value, but it has to be assigned to a variable, right? Now you have not given assignment here. That means the value, whatever the function got, is lost. You can't do anything. Okay, but it won't give you an error because might be you chose to not use the value. All right. Suppose you want to print, but say instead of taking a variable, you want to, if I just put this in print, what do you think this will work? So what is happening now? Compute area of square A, with this particular part, right, of my code is going to get a value. What value is going to get? Value whatever is present in the variable area, right? Now I put this inside print. What does print require? Print require basically a value to tell you, you need to tell print function what needs to be printed on the computer screen. Do you think this will do the job? I think it will. Let's see. Suppose if I put 10, see it's printing 100. So what do you think? You saw how it worked. The reason it worked because whatever compute area of a square A, when it was returned area, it sent the value of 100. Okay. Now this was captured by the print function. See, if you look at it, print is also what? A function only, no? And how do you call a function? You call a function by open and closing parenthesis. If there is some input, you put some input, right? In our case, usually we put what? We would usually put, either a string if you have to print something, or you will print the value of the variable. Variable name will print, right? That's what you do. Now in our case, the function is already returning a value, and I am passing it. I'm passing this whatever the function is returning as a input to my print function. Correct? What is that value? 100. And why? Then it's going to print it. Simple. So if I even change the value now 6, it's going to print 36. Did you get this? Yeah? Did you understand? So this is how it happens, right? So this is your definition of the function. Let's see if I change this def and if I give it later on. Let's see whether it makes any difference. Let me give a value. Let's say 9. See, it's giving an error. What is it saying? It's saying it did not find compute area of square. Why did it do so? See, because you are calling the function in line number 4. Correct? Until line number 4, the computer does not know what compute area of a square means because there's nothing like that existing in the memory. So make sure before you call your function, always, define the function. Okay, so before you call the function, this is the calling part. So before you call, you have to definitely make sure that the function is already created in the computer's memory. Understood? This is how the functions thing happens. So what is a function? Might be just a label to a lines of code. Okay, you can have an input passed or you do not have an input passed. Okay, if you pass an input, whatever, when you're calling the function, make sure you pass a value to that input, right? For example, if I just remove this A and if I call the function, it's going to give me an error. Let me say it's 10. See, it's giving me error. It's saying missing one required positional argument side. Obviously, now you're telling when you define the function, you said that you will always get an input or an argument. Argument is nothing but an input to a function. When an input to a function is nothing but called an argument. If you do not give it, it's definitely gonna scream, right? Oh boss, you did not give me an input, right? So always make sure whatever number of input parameters you put in while defining a function, make sure to give those when you're trying to call the function. Otherwise, you will get an error. Understood? Understood this part. Now let's say we got this value. Now instead of say, let me put this as result. Yeah. And I'm just gonna say this. Now I need to also give a, I have to write a print saying that the area of my, area of my square is, let's say, what is it? Whatever the value is present in my result. Okay, I need to do that also. Okay, we need to do that. So instead of, writing like this, usually what we do, we just say print. Okay, and we said the area of square is, and the value would be result. Correct? I can do this, and if I run this now, it's going to work very nicely. Let's say this is 9, it's going to say the area of the square is 9, 8. Now, along with this, we write one more function, which is to compute area of a rectangle. So what we're doing, compute area of a rectangle. You can do that, right? Compute area of a rectangle. Yeah. And let's say now you will need to pass two things, let it be length and the breadth. Correct? Because to finding the area of a rectangle, what is it? Length into breadth. So we're going to say area again equal to length into breadth. And you need to return this value, which is area. Correct? Now, what happens is after this is done, I need to say length equal to and breadth equal to. Agreed? Yeah, let me write this also completely, length equal. So let me just write this. Okay, I'm going to say enter length of a rectangle, and this will be enter breadth of a rectangle. Correct? Now I have to, let's say instead of saying result, now I'm going to say area of square. Okay, similarly I'll be calling one for area of rectangle, and what is my function name? Compute area of rectangle, right? And I'm going to say pass what? Length comma breadth. Now this is very important. Suppose if you're passing length comma breadth, okay, in this particular fashion, right? Okay, length and comma breadth. So let's say you pass length first and comma breadth, right? Then length will get whatever values present in this length in line number 14, and breadth will get whatever values present in 14. Okay, but let's say instead of that you made a mistake and you change the order like this. Okay, you made it like this. Now what will happen is this, in this function, okay, whatever you're passing as breadth would be given to length because you changed the order. So the order of the arguments is very important. It just keeps on filling the value depending on the order. So if you, let's say your breadth was 10 and your length was 5, now this would get length as 10 and breadth as 5. Here it does not make any difference in the answer because finally you're going to do length into breadth, right? But might be it will be an issue if if the values are something different and it is created. Instead of doing it into multiplication, might be some plus or something. It might create problem. So it's very important that you follow the order of the arguments, right? If you're intending to send length, whatever you're capturing in this length, if you want it to be given to the first argument of this function, make sure you write it as first. The order in which you're sending the input to the function is very important. I just want you just be mindful of that. All right. Now let's say I have area of a square and area of the rectangle. In both the cases, I need to print this, right? Whatever the area of the square or whatever the area of the rectangle is and the result, right? How about I even say this as a function? Declare a function to display the results. I can do that. So let's do that. I'm saying def display results, right? This is going to display results. So what do I need to know? I need to know whatever the area the person is, the function the person wants to, show, and what is the shape, right? If it is a rectangle, I would say that the area of a rectangle is this. If it is a square, I would say the area of the square is this, right? Depends. That's why I also need shape as my input. Agreed? So I'm going to say like this. I'm going to say print the area of what? The shape, right? Is what? The area, right? And do I need to return anything? No, I don't need to return anything. All I need to do is call the function. So not every function needs a return. So if I just do this, display results, I have to make sure to send first, let's say if I'm sending first area of a square, yeah, and I'm going to say here square. It's a square. Okay, now let's run this. Let me say for square I'm 10, length is 4, it is 5, and say the area of the square is 100. Okay, now I also need to display the results of a rectangle. Display results, area of a this, I'm going to say area of a rectangle. Okay, I'm going to say Control V, here I'm going to say rectangle. Right, now if I run this, both the display should have done. So because this is 6, this is 9, this is 18, and this is your answer. Right? Now you would ask me a question, ma'am, you do not have this return in the function display results. Yes, though you do not have a return, it's okay. The reason being, after this is done, okay, after it reaches the end of the function, okay, anyways, it's going to go back to the caller. The only difference being this time, it is not going to carry any value with it. Because if you have to carry any value to the column in the function compute area of rectangle and compute area of square, in both the functions we wanted the function to return a value to the caller, correct, from where it was called. But in the display results, I do not need to return anything to the caller. I just want, whenever I call this function display results, I just want it to just execute the lines of code and I'm done. Similarly, so what will happen is once you call this line number 17, when you call this display results, it will come to line number 9. It will, just print, it will do its job of, executing line number 10. And after it has done, reach the end of the function body, it's going to just come back to line number 18 because this job is done. Do you understand? Okay, return is used when you want to return a value to the caller, which is in the two functions which we saw, compute area of a square and compute area of a rectangle. That means you can use a function to return a value to the caller, or you can also have functions which do not return a value to the caller, which we have here. Depending on your need, it was gonna. Okay, now just to show you right the order, I'm going to just print the values here. Print length. Let me just print length. I think that would be clear. So now if I run this, okay, if you look, just we want 12 here, we want 10 here. Now look, length is 12 and I'm passing, when I'm calling the function, I'm passing length comma breadth. That means this variable length here in this function should get the value what? 12, which is correct. Okay. Now instead of length comma breadth, now I'm changing the order as breadth comma length. Now what do you think this should print? Line number 6 should print. Line number 6 should now print whatever value I give to breadth, correct? Because I've changed the order. This is 5. Let's say I gave a value 12 here. I gave a value 10 here. If you see now, length gets value 10. Why? Because I've changed the order in which I'm setting. Okay, so the naming doesn't matter. Here, instead of length, okay, instead of here, and also one more thing. Not necessarily because you have length and breadth, you should also have the same names here, length and breadth. No. If you look here for the square, we had the variable which stored a, right? We're passing a, but here the name of the variable was side. Only matters is the number of arguments or the number of input to the function, and the order in which you're sending the input is important. Understood? So always make sure that you're giving proper ordering. Yeah. So now I'll just remove this, and if I run this, right? And if I give a square value, let's say 9, let's say 8, let's say 13, and I have the values. Okay, so this is how functions work. I hope this is clear. So we have finished with the Python basic series. Okay, and in this last bit, what I wanted to do is come up with a small project where we use all the concepts which we have learned so far, right? We have done conditional statements, we have done loops, okay, we have done functions, variables, right? Done quite a lot of things, and we will try to use it in a practical example. So the project which we would be looking at, okay, or the problem statement is, we would try to design a calculator. Okay, now here this calculator, we won't have a UI part of it. I don't want to make it, I want to keep it realistic. I don't want to, promise you that you will be suddenly doing, web applications and machine learning models just by doing basic Python. No, this is basically just to make sure that we try to, simulating a real life calculator. Okay, and we'll do it using simple Python. Now, what all functions our calculator will support is addition, subtraction, let's say multiplication, yeah, and let's talk about a complete division. So these are the operations which our calculator will support. Okay, so plus, minus, multiplication, and a complete division. Okay, now how to have an interactive experience with the user, right? How we do in the calculator. So what are we going to do is, we're going to give some codes. What we're going to do is, we're going to try to now design this calculator. So how will we do? We will say first, you have to first ask the user what does he want to do, or even before that you need to tell the user that your particular program, calculator program, can support this all operations. Okay, and Also, you need to tell them what code you have, right? Suppose if they want to do addition, might be they have to press 1. If it is subtraction, the code is 2. If it is multiplication, the code is 3. If it's a complete division, the code is 4. And if they want to exit, okay, they want to exit a calculator application, then they have to press a 5. Understood? So what am I saying is, if we have 1, 2, 3, 4, so if they have to exit the application, then they have to press 5. And for all the other things we have for additions, that means what? Let's say now a person runs our calculator application, right? So now suppose we will display them. This is the code for our calculator, right? This was our code. Now suppose the person presses, enters 1 as its choice. Okay, 1 choice. So you know what? 1 is nothing but addition. That means our code has to next ask the question, what are the 2 numbers you want to add? Might be A and B. Let's say the numbers are given, let's 10 and 5. Okay, the user enters 10 and 5. Then you need to display what is the sum of 10 and 5 and 15. After that, again, what will you do? You will again ask the user what is the next thing he wants to do. Does he want to do addition again, or he wants to do subtraction, multiplication, or division? Or does he want to exit now? His work is done. So let's say he says, I want to do subtraction. So what will he do? He'll give us the code as 2. Again, what he will do? He will ask for 2 numbers. So let's say it's given as 10 and let's say 2. So subtraction you will display is 8. Okay, 10 minus 2 is 8. Again, you will ask the question. Or you'll ask the question, are you done with the calculator, or do you need to do something else? So it says, no, I want to do multiplication. So he'll enter the code 3. Now what happens when you enter the code 3? Again, you're going to ask, your code should ask the question to the, user, what are the 2 numbers which you want to multiply? And since the user says 3 and 2, what is your output? Your output would be 3 2s are 6, and this will be displayed on the screen. Again, we will again ask the same question, right? So we're not going to exit the program unless and until the user doesn't tell us to exit. Okay, now the user comes and tells us, boss, that now I am done and it wants to exit. Then what it has to say? It has to give a code of 5. The moment you see 5, you're going to say thank you, or you can say just bye and just exit the code. Got it? Now let's say instead of 5, suppose user gives us some number as 8. Okay. So user gives us 8. Do we have anything for 8? No. That means if a user gives us a code which we do not understand, you need to tell the user that the entered code is incorrect and please enter a valid code. And the valid codes are this 1, 2, 3, 4, and 5. Okay, because user can tend to forget, no, what are the codes for addition, subtraction, and all. Correct? So do you understand when at first the user enters, runs the program, you need to tell what are the choices a user can make. Right, depending on the choice, you're going to ask appropriate input and then make the whatever processing and provide the output to the user. You need to keep on asking what else he needs us to do. Okay, until he gives us an exit code, which is 5. If it gives an invalid code, your code should should be able to tell the user that the entered code or the given code is invalid and please enter a valid code from the codes which we have, which is from 1 to 5. Did you get this? Now we will do this question. Okay, so what all you think will be used here? We'll be using a loops concept, definitely. We'll be using the concept of conditional statements here, and we'll also be using the concept of functions. Okay, so we're going to try to use all the functions, all the concepts which we have learned in this Python programming course, and I'm going to try to solve this problem statement like a mini project. Okay, I hope the problem statement is clear. So let me just go through again. We're trying to design a calculator. All right. Now this calculator is going to support all these operations, which is how many operations that we have? We have addition, subtraction, multiplication, and division. Total 4 operations this calculator is basically going to support. Okay, we be having a code against each. Once a particular user starts a calculator, your calculator program, you should display the choices and then ask the user to input his code. Depending on the code, you would ask the correct input and also give out the output. Once you finish one processing for one particular code, you again ask the user what is the next thing he wants to do. We keep on asking this until the user exits by using a appropriate code. Here we have the exit code is 5. If a user enters an inappropriate code, when I say inappropriate, it's a code, suppose user enters say 10 number or 12 number, for which you do not know what operation is associated with it. Okay, so that is an invalid code for our program. If that is the case, then you need to notify the user that you have entered an invalid code, and please, select a proper code from the list which we have, which is from 1 to 5. Did you get this? This is what we will be implementing. Please give it a thought before you move on to the solution section. So we saw what problem statement we have to do for the mini project, right? So the problem statement was regarding a calculator, and this were the operations we were going to look at: addition, subtraction, multiplication, complete division, and if the user has to exit, he has to put a code of 5, right? So now let's look at the solution. How can we do this? Now, I think when you start to write a program, a longer problem, right? When you start to write a solution for a longer problem statement like this, it's always better to things in bits and pieces. All right. So now we have seen that we need what? We need to take one code from the user, correct? So that means we'll have to somehow take the code from the user, and let's say based on the code, if it is 1, then we need to do some operation. If it is minus, if it's subtract, multiplication and all, we need to do some operation, correct? So let's try to do that. What we can do is we can use what? We can use a if, else if, and then there is an else part, correct? So where can we use this? Because let's say suppose we have used n variable to store the value of the code which the user has given. Okay, so this code, right? 1 2 3 4. So suppose if n is the variable which stores it, then we can say if n is equal to 1, then we have to do what? We have to do addition. If n is equal to 2, if n is equal to 3, we need one more, I think, else if. So one more else if, which will take care of n equal to 4. Yeah. And then what else we need? We also need something for 5, right? We need something for 5. Do we need something for 5? We'll see. And let me just put a else here. So right now I'm not putting anything for 5. And there is a reason. See, if you remember how we want our function to operate was, we have to keep on asking user for what he wants to do next, what operation he wants to do next in the calculator, as long he doesn't choose to tell us to exit, right? That means it has to go on a loop, correct? That means we need to use a loop. Now, we have learned two different kinds of loop. One is a for loop and one is a while loop. Now, in this situation, in the current problem statement, what do you think is more efficient? Is it making for loop or is it using while loop? If you recall from the lectures, I had told you that while loop goes very well if you know a stopping condition, that you want to, repeat a certain block of code until a condition is satisfied. Okay. And here the condition is until the user does not tell me to exit, I have to keep on asking user what he wants to do with the which operation he wants to do next. That means I know a condition. So while loop makes more sense here. Did you get this? So I'm going to put a while loop. Now what can be the stopping condition? So we said whenever the user enters 5, all right, he has to exit the code. Correct? That means any other number other than 5, what will be if let's say if he puts 1, 2, 3, 4, then we can do operation, correct? But if he gives us something like 6, then what we have to do? Suppose something like something like 8, suppose a user gives us, then we have to tell the user that please enter a valid code, correct? So that means if it's any other number other than 5, I have to keep on going in a loop. So my condition can be while n is not equal to 5. While n is not equal to 5, if n is equal to 1, then I do addition, correct? Let me write this. I can say do add. If this was subtract, right? This was, I think, multiplication. This was a division. Now, why is this else part? Else part is, let's say when the user enters a code like, let's say user enters a number 8. For n, the value is 8. When n is equal to 8, we do not have any corresponding code for it, and it's also not the code for exit, correct? That means then we have to tell the user, please enter a valid code, right? So that part will be taken care by else part. So if it is none of this, okay, then what we need to tell is we have to tell the user, please enter, please, we have to print the message that enter a valid code. Enter a valid code. What are the codes we have? 1, 2, 3, 4. Or if you want to exit, please enter 5. That means here you have to again, you have to give a message to, that you've not entered a valid code. Please enter a valid code. And then you also have to take the input from the user, right? User will then input from you. So you will also have to take the input here. That means you will take an input here before, then you will define int input. Correct? Here we'll take the input. Do you understand why I'm taking the input here? I'm taking the input here because otherwise how would you say while n is not equal to 5, right? And here also I'm taking, let me write it properly. See, I'm saying else is equal to, I'm saying here first I need to print, I need to display that the code whatever was given by the user was invalid. So I need to first tell him that the code was invalid, and then I have to ask him to please enter again. So code is invalid and enter your option again, right? I need to tell this to the user. So once I tell, that means user is going to again enter a valid code. I need to take it, read it from the user here. Correct? So I'll do that in the else part. Also, before I start my, while loop, I have to first take an option from the user. Correct? I took an option from the user int input and took an option, right? Why do I need this? Because I want to keep on asking, for a correct option for the operation. Yeah, and do an operation unless and until the user does not ask me to quit. That means unless the loop will go until the exit code is given to you. What is the exit code? We said exit code is going to be 5. That's why I've written while n is not equal to 5. So when you have a stopping condition, it's very useful to write a while loop as we have written. Okay. Now inside this, inside each statements, addition, subtraction, multiplication, and also one more thing, why have we used an if, else, if, and else? Because this n variable, this choice can be only one of the value at a time, right? So that means if n is equal to 1, if this condition is true, the computer need not check any of the below. This need not be checked at all, because n can only have one value at a time, right? And when we have a situation like this, we spoke about when we did if, else, if in conditional statement, that if, else, if, else is the best construct to use. Okay. Now in this inside part is easy. What you will be do, suppose if the user wants to do addition, then you need to ask user what two numbers he wants to add, correct, and do the addition and print the value. Okay. So you can choose to write that code here inside the if block directly, or you can create a function, right? You can also create a function for subtraction, create a function for multiplication, create a function for division. Can you do that? So that's why what happens is, see, you can also, instead of writing a function, you can also write the lines of code here, but then might be the code which will not be more readable, right? And we have learned functions, correct? So it's better we write functions for all this. So how many functions we'll be writing? We'll be writing 1, 2, 3, and 4 functions in total. All right, did you understand? So this is the entire code for your problem for designing a calculator. Okay, let's see in our let's write that actual code and look at it. Okay, so first I said this, first I will be basically taking the code from the user. So it's in input, and again obviously because the codes are 1, 2, 3, 4, 5, that means I'm expecting an integer, right? It cannot be a float. So I'm going to say end input, and I'm going to give the codes here, right? Enter your code for operation. Even before that, I want to kind of welcome the user to my calculator. So I'm going to say print welcome to calculator. So let's give a name. Let's say welcome to smart calculator. Right? You can give any name you want. I'm just saying, yeah, just to give a heading whenever the user runs this. It's good for to show a welcome message for him. If you do not give, it's okay, it's fine. So I'm saying enter your code for operation, yeah, and I need to tell him what is the code also, correct? So here only I can mention here in my print. The next I can say is what all codes he has to enter. So I'm going to say here enter 1 for addition, correct? Then I'm saying enter 2 for subtraction. So instead of like this, I can see, it's better to have, what to say, enter, right? You want to go into different next line. After enter 1 for addition, might be want to give a space, and that enter for subtraction wants to be given in the another line. What could you do? One solution is you could write that many print statements. Print enter 1 for addition, another print statement, enter 2 for subtraction, and so on, right? Instead of doing that, you also have one operator which is like an enter operator. So what it does is it adds an extra line. Okay, so when I say enter 1 for addition, it will print that. When the slash n will basically add a line, okay, and then print the next one. The next one is, I'm saying, enter 2 for addition. So let me just go to the codes. What was the codes we agreed on? 1 for addition, 2 for subtraction. Okay, again I'm going to say slash n, enter 3 for multiplication. Okay, then next is slash n, it is 4 for division, enter 4 for division. Okay, and next is, I'm going to say 5 slash n, 5, enter 5 for exit. Okay, let me first show you how this actually runs. See, welcome to smart calculator, right? And then saying enter 1 for addition, 2 for subtraction, 3 for multiplication, 4 for exit, and 5. Now that this reason is, I've added here and enter 5 for this. Let me run this again. See, now if you look at this, I've written slash and I've not given any space and written enter to this, right? Because there's no, this slash and only is going to add an extra line. If I give a space here, what will happen is, after this enter to subtraction will have a space before it. See, if I run this and show it to you, see, there's an extra space here. The reason being because after slash n you have given a space. So slash n is nothing but it has to be inside double quotes and it's going to just add an extra line. Okay, so you can use this. So instead of having how many statements have we printed? 1, 2, 3, 4, 5. 5 print statements. I put it everything in one print by using the operator slash n, which is basically adding a line. Okay, I hope you've got this. So we've displayed the message. We have told you, we basically welcomed to smart calculator, and we have also displayed the message. Correct. Now what our job is now to write the code. Before that, I need to take input from the user. So I've taken enter your code for operation. All right. So the code is I've already displayed. Right. Now, what is it? While n is not equal to 5. Okay, remember for this not equal to, there's one more symbol, right? Those angular symbols. You can either use this or the angular symbols, but the this repel, right, which I'm repel it, which I'm using, right? So this particular does not recognizes this as not equal to symbol. Okay, so if you're using another different kind of interpreter for Python, and if it is not recognizing not equal to this symbol of not equal to, you can always write the other one. The other symbol is this, right? So, but in my case, it's basically depending on the interpreter which we are using. Okay, mine one is basically taking this for not equal, right? Just a small note there. Now, what we are doing, we have to basically write an if-else, right? So, if my n is equal to 1, then I'll do something, correct? Then I have to do what? Else if, what I'll do, if n is equal to 1, I'm going to call the functions. Let me just say sum. And yeah, even before doing that, let me just first go and write the functions, right? So I have to write functions. So let me say I'm going to write functions here. Remember, when you're trying to call function, you have to make sure that the function has already been defined, okay, before you call it. So, let's assume that even before taking the input, I'm going to write the function here using def, okay. So what is it? Def, I'll need one function for summation, and there'll be 2 input I'll require, right? The numbers. That is one function. What is it? I need to say, what is it? Your sum is equal to a plus b, correct? And I also need to print the addition or the sum of, okay? The sum of, what is it? A and b is, and I'm going to print the sum. Right? And what is it? That's all. I don't have to return anything here, so I'm not using the return function. All right. So similarly, I also have to write a function for control C. I'm just trying to, I can just make addition here. I can use something for subtraction. Okay. Subtraction. And it has to be a minus b. Instead of sum of, it will be the difference or the subtraction of. And I have used this as a statement. You can also use something like the difference between A and B, right? So that is nothing to worry about. Sub, and I'm going to use here. Okay. Another would be after subtraction. What else we had? We also had multiplication. So I'm going to use a function multiplication here. So def multiplication. Okay, so it's going to have to change this to A into multiplication, and the multiplication of, instead of multiplication, you can even choose to write the product of, right? So this is what, let me change this to MUL, and multiplication becomes, okay. Next, what else? One more function I'll require is for division, correct? So let me say division here. And I remember if the problem statement said that we wanted a complete division. So I'm going to use just this symbol, and this is div. And what need to change here? The division of A and B is this, right? So I have now defined all my functions. How many functions I have? 1, 2, 3, 4. So 4 for some addition, subtraction, multiplication, and division. So 4 functions we have, right? Now here what again coming back, if n is equal to 1, that means I need to do addition, and I'm going to call the function sum. Before that I need to ask the user what the two numbers he wants to add, correct? So I'm going to say A equal to int, okay, int input. I'm going to say enter first number, okay, first number to add, all right, and same thing I need to do is enter second number to add, right? Make sure your indentation is correct. If you're leaving 3 spaces, make sure you also, have that uniformity, okay? So enter second number to add, and now I can just call this function sum A comma B. Okay, it's not returning anything, it's printing it and it's doing my job. Next is what? Similar thing I have to do it for else if also, right? What is it? Else if now? Now what is it? N equal to 2. Okay, so if you look at this, the indentation is okay. Yeah, now it is fine. I'll just copy this and make the changes. Okay, what I have to do is now I have to call the subtraction. What is my function name? Subtraction A comma B. Enter the first number to subtract and enter the second number to subtract. Okay, I got my subtraction. Similar thing I have to do what? I have to do for multiplication and division. Okay, so now instead of else if n equal to 2, this has to be 3. Make sure about your indentation. See if it's on a particular, yeah, it is all correct. N equal to 3. Now you're supposed to do what? Multiplication. If this is to multiply, first number to multiply, second number to multiply, yeah, and the function name should be multiplication. Okay, so this is done. Again, now what is remaining? Division. So I'll write another one here, else if n equal to 4. Okay, look at this. Yeah, my bad. Yeah, so now what I'm going to do is just make sure this is in the same line. Now here I'm going to do what? First to add, subtract, multiply. Now this fourth option was to division, remember? So I'm going to say division. Here also it's going to be division, right? And what is it? The function name is division. It's going to be A comma B. It's going to even do that or print it out, right? If this is not the case, I have to do else. Okay, when it is else, what we thought, that means any number which is it's not exit but some invalid code. So I have to first tell the user that he has entered an invalid code. So I'm saying print entered invalid code, please enter correct code. Yeah, that's what I've done. Now I have to again take the input. I have to take input. So we had taken input here also earlier, remember? Where was the n? Yeah, we could just copy this. Okay, so somebody would have a question, why do I need to do it here? Because see, the user's already entered an invalid code and still an invalid code, right? Now if we have to ask the user what's the valid code is. That's why in the else part I need to read the input from the user. So I'm saying enter your code for operation. Okay, This is done, and I think this should work, right? Have we taken care of everything? Yes. Okay, let me show you the entire code. So let me just, just so that, it's multiplication. Okay, so if it's saying def sum subtraction, okay, multiplication, all this thing is there, right? Let me run this now. See, there's some issue. This thing, indentation issue at else if n equal to 2. Okay, so there's some issue with the indentation. Okay, so see, this is important, right? So this is how you will get your indentation issues. Now let's try. Yeah, it's working. So enter your code. Let me stop here. Enter your code for operation. After that, let us give a nice space. Yeah. Here also enter your code for operation. Let's give a nice space. Okay. Now let's run this. Okay, enter your code. Let's say we want to do, let's say 2. Okay, what is 2? 2 for subtraction. First number to subtract, let's say I put 10. Second number to subtract, let's say 5. What is my, I say return, subtraction of 10 and 5 is 5. Okay, enter first number to subtract. So it's again asking me, let me just give a space here because it's becoming not very readable. Let me just make it readable here. Okay, let's run this, stop this. Let's run it again. Enter your code. So let's say let's start with addition first. Okay, first number to add, let's say 19. Second number to add 20. I got the sum of 19 and 20 is 39. Okay, again it's saying enter the first number to add. Okay, so there is some issue, right? Because again it is asking enter the first number to add. That should not be the case. So after you're done your this, what do you think is the issue here? What is the issue here? This n, okay, so there's something wrong, right? Can you see? See, I did my addition. It's again asking me to first number to add. That should not be the case. Why? Because see, why is it always asking again you to add? Because n is still 1, right? That means this part, this n, I should always read it outside. This should not be inside my. So see, if is n equal to 1, you do something, right? If n is equal to 2, you do subtraction, multiplication. If there is an invalid code, you just tell them, please enter, you have entered invalid code, please enter a correct code. Then you need to take this output, correct? Now this output I had to put in inside the else statement, which is wrong. It has to become outside. The reason why, because after I'm done, let's say one option, let's say, in this case, right, we have done addition. After we have done addition, I need to again ask the user to give me input, right? So that is possible only if it is outside the if-else-if-else block. Did you see the mistake which we had done? Okay, now if I just stop this and if I run this, okay, let's say enter your code for operation. Let's do first addition. It's saying let's 12, 56. The sum of this, m of 12 and 56 is 68. Now it's giving me properly, right? It's saying, see, what happens is when n is equal to 1, this part of the code was getting executed, right? After this is done, after this execution is done, it's going to come out of if-else-if block and it's going to execute this, which is enter your code for operation, which is still inside the while loop. Okay, so I'm saying enter your code for operation. Let's say next I want to do is let's put what do you want to do next? Let's say want to do multiplication. Multiplication is 3, so I'm putting 3. First number to multiply 12, next number to multiply 7. So multiplication is 84. Now again ask me enter your code for operation. Let me put 8. I put an invalid code. So see it's saying entered invalid code. Please enter correct code and you again enter your code for operation. Let's say I want to now, after I've done, what we done addition, we did multiplication. Let's try to do subtraction. So I'm going to put say 2. Enter first number, let's say 56. Next number is 9. Okay. So the subtraction of 56 and 9 is 47. Again, let me say now what is, let me again put an invalid code. See, enter invalid code, please enter correct code. Now enter your code for what we've tried. We tried addition, we tried multiplication, we tried subtraction. Now let's try division. So the code for that is 4. Okay, let's start with 60 divided by, let's say 2. So I'm getting the answer is 30.0. Why did we get 30.0? Because we are doing a complete division here, right? And complete division by default will give you answers in point, in decimal point. That's why it's 30.0. Okay. Now enter your code for operation. Now let's say I want to now exit the code. So what is my exit code? It's 5. So I'm going to say 5 here. You have come out of the loop. Now what have we left? If you remember from the problem statement, I said once you come out of your calculator, you need to just thank your your user that he has used your calculator. So you could just give a message here, which is outside the while block, print. Okay, see, it's outside the while block, right? Your while is entire here. See, your while is here. Okay, I'm just giving a print here, and I'm going to saying what? Print. Thank you. Okay, hope you enjoyed our calculator. Okay, so this is what you're going to give a message once the user is done with using a calculator. Let's try this out once. Let me run this now. Okay, I'm saying let me just do a simple one. Let me just do addition, and these are the two numbers I want to add, and let me just exit the code. What is exit? 5. I want a message again. Thank you, hope you enjoyed your calculator. So did you get this? I can do any number of calculations until I do not exit it. Okay, if I do an invalid operation, it's going to give, the code is going to tell me that I have entered an invalid code and again ask me to enter a valid code. Have you understood this? Now, one more thing also, you see in this code, if you remember, if you see, right, this A and B, for every type of code, n equal to 1 or n equal to 2, you are taking two numbers as input. Okay, so instead of having this repetitive code everywhere, what you could do, you could just write a function which takes the input of two numbers, right? And that function might be, you can use that function first, and then you could call this function which does the job of processing your input. Correct? Try that out, might be. Got it? Rest all we have done. So we have finished our mini project. See, such a beautiful code, right? So you first given welcome to smart calculator. Again, you have done what? If you want to leave a line after welcome to smart calculator, how you can do? Just add a slash in here. Let me just run this and show it to you. See? Okay. Let's say after this also you want to add a slash in. So let me stop this. Yeah. See? So now it has become more clean and readable, whatever your output is in. You get this into your code. Okay. Got this? Yeah. So just try this out. And I hope you have understood all the concepts which we have done in this as a part of this course, right? My aim was, to anybody who has not done coding before, okay, is new to the coding world. So my aim was for this course, so that it's your first step, first baby step towards coding, right? And Python is the easiest language because very similar to English. All right, and I hope you have understood all these concepts of conditional statements, variables, loops, and functions, because these concepts are very basic, the foundations of your programming world, and they are being used, same concepts are there in every other programming language. Okay, have a wonderful career ahead and happy coding.